Data analytics is like uncovering hidden stories in a giant puzzle. Imagine you have a bunch of information puzzle pieces scattered all around. Data analytics help you collect and organize these pieces so you can start fitting them together to see the bigger picture. It's like having a detective's eye searching for patterns, connections, and insights that are not immediately obvious. By using special tools and techniques, data analytics allows you to dig deep into the information and find valuable insights that can help you make better business decisions. By studying data analytics, you become the go-to person who can make sense of all the information that businesses collect and store. You become the one who can find answers, spot trends, and make predictions that help companies grow and succeed. Besides, there are abundant job opportunities available in this particular domain that offer handsome salaries. So if you like to dive deep into the numbers, then definitely data analytics is a best career option for you. And today with this video, we are going to cover everything you need to know about it. But before we begin with that, I'd like to request you guys to enable both the subscribe button and bell icon so that you wouldn't miss out on the multitude of tech-oriented updates coming from our Intellipaat YouTube channel. Now let me take you guys through the agenda at first hand. We'll start this session with what is data analytics. Moving on, we have what is data manipulation, what is NumPy, array in NumPy, NumPy functions, and hands-on as well. Then we dive into what is Pandas, what is the difference between NumPy and Pandas hands-on. Once done with all that, we have an introduction to Matplotlib, concepts of Matplotlib, and HR analytics. After done with that, we dive deep into Excel skills for data analytics and data visualization. Then we'll create data analytics project. And towards the end, we cover data analytics interview questions that are most commonly asked in job interviews. I hope I have made myself clear with the agenda. So without wasting any time, let's get started with the first topic on our agenda.
What is data analytics? Data analytics is the buzzword you would have heard a lot about in the recent years. To put it simply, it's the process of analyzing raw data to get insights and find patterns about the information. Using various techniques and processes, the raw data is transformed into a format which could be further visualized and be made human readable. To understand the definition in an even clear way, let's take a look at this example. John, who is a digital marketing professional, is running an online advertising campaign to promote a new smart television. John starts by targeting the group of people who might have bought the previous versions of the smart TV in question. As said campaign runs, data analytics comes into the picture through the data generated whenever people clicked on the published advertisement. Now, by inspecting the data about these users' interest and their buying patterns, you might come across that many of them are interested in streaming 4K UHD video. The reason behind this might be that the new smart TV has a better streaming quality than the previous versions. Using this information, you could tune in your advertisements to focus on users who bought the previous version of the smart TV and are interested in getting 4K streaming quality. This data can also be used to attract new customers who did not go for the previous version of the smart TV but are very interested in a better version of the TV. Why is data analytics significant? Businesses use data analytics to optimize and grow by making better business decisions and finding more efficient ways of doing business. The company can build new and better products with the buying patterns and better understanding what the customers need. So how do data analytics work? The data analytics process has some components that can help a variety of initiatives. By combining these components, a successful data analytics initiate will provide a clear picture of where you are, you have been, and where you should go. Generally, this process begins with the descriptive analysis. This is the process of describing historical trends in data. Descriptive analytics aims to answer the question, what happened? This often involves measuring traditional indicators such as return on investment. The indicators used will be different for each industry. Descriptive analytics does not make predictions or directly inform decisions. It focuses on summarizing data in a meaningful and descriptive way. The next essential part of data analytics is advanced analytics. This part of data science takes advantage of advanced tools to extract data, make predictions, and discover trends. These tools include classical statistics as well as machine learning. Machine learning techs such as neural networks, natural language processing, sentiment analysis, and more enable advanced analytics. This information provides new insight from data. Advanced analytics addresses what if the question. Data analytics affects every aspect of our day-to-day lives. You may not even realize it, but you probably use data analytics almost every day. Here are some of the everyday applications of data analytics. Social media stats instantly register anytime there's a visitor or a post to a page. Cell phone bills can pull up months of calling data to show you patterns of usage. Sensors monitor the changing weather and report the data to you instantly on your smartphone. Sports fans collect statistics on their favorite athletes and often use the data to form the term of fantasy leagues. Schools across the nation are involved in high-stakes testing that generates voluminous data on each student's progress. Educators then utilize data generated from extensive reports to drive their instruction. Data analytics is a growing field and will always be a top domain to get into. The average salary of a data analyst in India is 7 LPA and in the US it's $70,000. There are 27,000 plus data analytics jobs available only on LinkedIn, and there are very few skilled professionals to fill that gap. That's all about data analytics.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
So as a data scientist or as a data analyst, our job is to analyze the data, do various apply various manipulation techniques on the data so that we have our data set in a proper format and identify some insights from it. So before we analyze the data, before we get the insights from the data, we need to ensure that our data set is properly formatted. Our data set is clean without any mistakes, without any errors, without any impurities. So to make that happen, to have our data set properly aligned, properly cleaned, we use various libraries available in Python. Data manipulation. Data manipulation is one of the important tasks that we as a data scientist or data analyst perform before we get any insights or before we start building any machine learning models on top of it. So we will talk about what is data manipulation, why data manipulation is required, then what are the different tools available for the data manipulation. Then we will understand what is NumPy, how NumPy is different from our built-in data types lists. Then what is array in NumPy, what are the applications of array, how to create NumPy arrays, and how to use those NumPy arrays to solve all the mathematical problems. What all mathematical problems we can solve, or what all mathematical computations we can do on these NumPy arrays. Everything we will be understanding. So let's understand what is data manipulation. So let's understand what is data manipulation. So data manipulation is the process of converting data into a format that is easy to process and is more organized. So when we in real life, when we work with different kinds of data sets. Data is scattered across all over places. So some data set might be available in CSV files or Excel files. Some data set might be available in some structured databases like SQL Server or Oracle. Some data set might be in simple text files. So data comes from all the variety of sources. As a data scientist or as a data analyst, our job, one of the job is to merge all these data files which are required for the analysis, get them into one place, get them into one single format, which is which will be uniform across all the sources, all the file sources which we have, from which we are getting the data set. So data manipulation involves getting the data from all these sources, get them into the Python, okay, and perform some operations on that data inside Python so that we will have our data set cleaned, organized, and in a single uniform format so that we can do various analysis on top of the data set. Now, there are various tools available for us in Python. Using these tools, we can perform our data manipulation activities. NumPy and Pandas, these are the two mostly widely used libraries in Python.
Let's have a quick quiz question, guys. And the question is, which of the following is not a commonly used data visualization tool? And your options are Tableau, Power BI, Python, or ClickView. Please mention your answers in the comment section below.
Which we use on a daily basis, every single day. So if you want to become a data scientist or data analyst, these are the two libraries which you cannot skip as a part of your learning exercise. These libraries are very easy to understand. If you have understood the Python basics so far, learning these two libraries are just a piece of chocolate. So we will ensure that everyone is getting a good, clear understanding of both these libraries, NumPy and Pandas. Apart from these two libraries, there are some other libraries like SciPy and Matplotlib. There is one more library called Seaborn. And there are many such libraries. There are n number of libraries, okay, which are, and on a daily basis we are getting to know many different libraries, because Python is an open source language, and anyone can build libraries and put it on the package manager, from where we can download it and use it. But these two libraries, NumPy and Pandas, they have been in existence for a very long time, and they will be there for a very long time. So it is important to understand these two libraries. Okay, so we are going, as a part of our syllabus, we will be covering NumPy, which stands for numeric Python. Then we will cover Pandas. Then we will cover Matplotlib and Seaborn. So SciPy is not part of our syllabus, but quickly I will give you, if time permits, I will give you what this SciPy does and what is the significance of SciPy in data science. Okay, so why data manipulation is required? First of all, why do we need to do all these data munging and data cleaning activities? Because as a data scientist, we gather large volumes of data from multiple sources. And many times data from these sources has problems. Now, what kind of problems these data sets have? So these are some of the challenges which we may face when we gather the data from various multiple sources. So our data, one of the problem in our data set could be missing values, meaning some of the records in our data set do not have any value. In terms of Excel files, maybe there are some blank values. In SQL, there are some null values. Okay. So when we have such when we have such missing values in our data set, we need to ensure that we do some appropriate processing over those missing values before we proceed for the analysis or before we proceed for the machine learning model building activity. So since the data is accumulated from multiple sources, some values in a row might be missing. This could be due to multiple reasons such as equipment not being available, user not willing to share the data. So for example, if the data set is coming from particular sensors, okay, let's say it's a manufacturing plant, and to measure the temperature, there are thermometers installed in a manufacturing plants. So for, let's say, for some reason, for equipment malfunction, for a 10-15 minutes, that thermometer was not working. So because of that, for that 10 minutes, the data would not be recorded in the database. So that is one of the reasons why your database data might be missing in your data set. Another reason could be users are not willing to share the data set. So for example, I'm sure many of you might have, filled various survey forms on the internet, or even in the when you visit malls or some of the supermarkets. Some companies are always doing surveys for a particular products. So they might give you some product to test, and they will ask you to fill some forms. They will ask you to provide some information like your name, your phone number, your then your age, your sometimes your salary. Okay, these kind of information usually are asked in these surveys, or even when you create some accounts on various platforms online, they ask for some information. So some of the information is mandatory, some of the information is optional. So most of the times we users feel that to maintain the confidentiality, or to not share the some confidential information or some vital information with third party, we tend to avoid sharing the data set. So we may not be sharing. Yeah, so this is one of the reason that our data set might be missing. So we need to perform some appropriate techniques. We need to treat those missing values. That's where data manipulation can come into picture. Other reason why we need to do data manipulation is because of incorrect format. So sometimes data from different sources might be formatted differently, such as having different date formats or format of currency, etc. Suppose you are a multinational company and data is coming from different sources. So, and let's say you are getting a data from data in a Excel files. So in India, we follow date, month, and year format, DDMMYYY. This is the format we follow for the dates. In US, they follow month, date, year format. In European countries, they might be following something else. So that is one issue for the date formats. We need to ensure that when we merge all the data from different regions, we need to ensure that we are collecting the data and we are storing the data set into a single format. Otherwise, it will create an issue. So if you are merging the data from US and UK and India, and all three data set have different formats, then it is going to be a challenge, because the months would be considered as days, and days would be considered as month if we don't treat them properly. So this is one of the reasons why data manipulation is required. Another formatting issues would be related to the currencies. So let's say if we do not have for a amount column, okay, or for amount parameter. In India, we are having rupees as a currency. In US, it's a US dollar. For UK, it would be euros. For Britain, it would be pounds. So if we don't convert everything to a one single currency, then it is going to be a challenge, because dollar value is definitely higher than rupees. Pound value is definitely higher than dollar. So if you don't treat them, if we don't convert them into a one single format, it is going to be an issue. So that is why data manipulation is important. Another good example I can give you, when we write amount. So if we want to write 2500, so in India we would write it something like this. Okay, I have posted in the chat 2500. So comma in most of the countries, comma represents the comma means it's we are going from tens to hundreds to thousands to millions or billions, etc. So that is the reason we use commas. But it is a 2500. Some of the South American countries treat this as a decimal point. Comma is treated as a decimal point in some of the South American countries, like Brazil, Portugal, etc. So if we don't manipulate our data and convert them into a single format, it is very much possible that someone might consider this to 2.5 as a 2500. So it is going to be a blunder when we will be doing some analysis, because data is not in a single format. So to get the data set in a correct format, we need data manipulation. Then different units. Different countries follow different measurement units for various parameters. So for example, in India, for measuring temperature, we use Celsius. In US, they measure it in Fahrenheit or Kelvin. In India, we measure the distance in kilometers. In US, they measure the distance in miles. Similarly, we measure the distance in centimeters or inches. In some countries, they measure distance in feet. So it is very another is for measuring liquid products like milk or water. We measure it in liter. In US, they measure it in ounces and barrels, or sorry, not barrels, gallons, ounces and gallons. So what are the units which are used in across multiple data files, multiple data sources? It is very important to get them onto the same scale. Otherwise, it is going to create an issue. That is where data manipulation is required. And the fourth reason, which is unnecessary data set. So sometimes we have a large data set with columns that contains values that are not relevant to the task, and that you need to eliminate from your data set. For example, some data set has unique IDs, columns which are not important. Yes, correct, Vaibhav. Uneven scenario for machine to understand the data measurement. So machine does not understand what are the what is the difference between kilometer and miles. So we as a users, we need to make them understand, or we need to convert it manually. Sometimes we also have unnecessary information in our data set which is not required for the analysis. So for example, customer ID, okay, or user ID. So we know customer ID or user ID, these are unique numbers given to a users or customers. We won't be able to do any analysis on top of it. For example, we can't measure what is the average customer ID for Mumbai region. Or we cannot say what is the average user ID or what is the maximum user ID for this particular locality. Okay. So we can't do any operations on such data sets, such columns, or we also call them variables. You will understand these terminologies later when you will be learning statistics and other part of it. Okay. So for now, there are some columns in our data set which are not important, so we don't need them. So we need to eliminate them, and that is where data manipulation comes into the picture. Okay. I hope the context is clear why data manipulation is required and what are the challenges that we may face in the data set. We have already talked about what kind of tools we have available in Python, which we can use to perform this data manipulation. So NumPy is one of the one of the important library or module in Python, one of the important library, package, module, whatever you want to call it. All of them are kind of referring to the same thing. So we will talk about what is library, what is module, and why the libraries are important in Python, where are they stored. We will talk about in a minute. So let's understand what is NumPy, why it is important. So NumPy is one of the very popular library in Python. The abbreviation NumPy stands for numerical Python. So this NumPy is a full form for numerical Python. That is where this name comes from. The purpose of NumPy library is to do scientific and mathematical computations on various data elements. So we have seen there are various data structures or data types in Python, like list, dictionaries, and tuples, sets. And we have done a lot of data manipulation, computational, mathematical computations on these data sets, those data sets as well. We have seen how to calculate the average of list, or how to take the sum of all the values inside the list. So similarly, NumPy is little bit advanced version of those data types. And we will understand why we are saying it is a little bit advanced version of it. So NumPy is a Python library available in Python, okay, designed to perform all the mathematical and scientific calculations. So let's understand what is library first of all, okay. It is an open source library. What is library? What is the meaning of module? Whether library and module, all these two things are same, or what is the difference between these two things? So let's talk about it. So in our when we talked about functions, okay, we created one file called as module. Okay, those who are, it's a collection of files. That part is correct. It's a collection of files. What kind of files? It's a collection of Python files. Library is a collection of Python files. We use that file, we store that file in a .py format in our local file, local directory. And we imported that file from some other Python program. And we were able to use all those functions without defining them again inside our new program. So module or library is a collection of some programs, some functions, and some files which someone creates so that people can use them again and again without writing them manually. So similarly, NumPy is such Python library. Okay, someone understood the need for having these mathematical computations in Python, and they wrote a program. They wrote multiple programs to perform these mathematical computations, and they made it open source so that everyone who has access to Python and internet, they can download this and they can start using it. Now yes, module is a part of library. So Bhavnik, module, these are interchangeable terminologies. Some people call it as a module, some people call it library, some people call it as a package. These are kind of one and the same thing. So where these files are located, first of all, where is this NumPy file which someone has wrote and open sourced it? So in Python, there is a package manager, okay, or there is a library, or there is a big storage available called as PyP. So if you go to this website, okay, pyp.org, pypi.org. This PyPy library is collection of all such libraries people have written and published, so that, and they are open source, so that anyone can access it without any licensing issues. It's an open source. So how do we search which library we are looking for? So we are looking for NumPy. So if I search over here NumPy, I will get list of all the NumPy related libraries. This is the main library that we will be talking about, which is NumPy, and this is the version 1.24.3. This is the latest version of this NumPy library. How do we download this library? So by default, when you install Python using Anaconda, and all of us have done that, all of us have installed our Python using Anaconda only. So when you install Anaconda, there are some a few number of libraries, some 40-50 libraries pre-installed, pre-loaded with that Anaconda installer, with Anaconda package. So we don't need to install this NumPy library manually because we have installed it using Anaconda. But what if someone did not install using Anaconda, they installed Python using some other methods? Okay, they downloaded Python from some manually from the Python. So yeah, Colab also has some pre-installed libraries, but let's say Colab also, yeah, they're using Colab and they want to install this library. So any libraries which we will be installing manually, when those are not available inside Anaconda framework, we make use of this command called pip installed. So pip installed is a command for pip manager. So this is, as NP is for loading the library. For installing the library, okay, I'm talking about installing the library. So when we do not have this NumPy library in our do not have this library installed, we use this pip install command. So how do we use this pip install command? You go to your Anaconda prompt. Okay, so I'm using Mac, so I don't have Anaconda prompt, I have terminal. You would be having Anaconda prompt. Okay, so you go to this Anaconda prompt or this terminal, and then you paste this command over here like this, pip install NumPy, and you hit enter. Don't do that now, okay, otherwise it will mess up with your current installed package. So when you do that, it will take couple of minutes to install this library from that PyPy website, and you will have it installed inside your local machine. So that is how you download any Python libraries, not only NumPy. You will install NumPy, Pandas, SciPy. Then there are some other libraries you will learn when you will talk about machine learning, which is sklearn, then NLTK. There are various such libraries which you can install using this same command, pip install. Jupyter Notebook is part of Anaconda framework only. So Jupyter Notebook is IDE. It's called as integrated development kit. So Anaconda is a framework and IDE is one part of that Anaconda. So I hope you understood what is library, why, what is the significance of PyPy and what is pip. Okay, so let's move on. So it is fast because it is written in C++, C and Python. So we have lists which are very close to something called as array. So in our classes, when we were talking about data structures and data types, we talked about that. I told you that Python does not have any data type called as array or data structure called as array. The closest which comes to the data type array is a list. Okay, so but since there is no built-in array installed, there is no built-in arrays available in Python. NumPy is a alternative to array. Okay, it is an array. NumPy is a type of array. NumPy is a library which allows us to create arrays, okay, which are much better compared to list because they are faster. Why? Because those are written in C. C is a very native language to the kernel or your hardware compared to Python. So that's the reason it is faster. And there is no built-in array capabilities in Python. So NumPy provides alternative to the array data structures, which are usually available in the other programming languages like C, C++. You can use list as an alternative for arrays, but NumPy is better. How it is better, we will discuss that. Okay, why NumPy is better? So what features does NumPy provide? It is a durable n-dimensional array. Why it is called as n-dimensional array? We will talk about it. Tools to manipulate and work with array. So since NumPy Python does not have array as a built-in data type, NumPy provides that capability to work with arrays. It helps to perform mathematical and logical operations on arrays, and it also provides different built-in built-in functions which we can use to perform various operations on the arrays. So why NumPy over list? Okay, so first of all, let's understand why it is better to have, why NumPy's arrays are better than list. So let me give you one quick example to you. Okay, so suppose I have this list called ls is equal to this list, and there I have 1, 2, 3, 5, 3, 6. These are some of the elements in my list. Now, if I want to perform some vector operations, so consider, let's say this is also one kind of a vector only. I want to multiply this list with 2 or 4, any particular number. What will I have to do? I will have to loop over this list using for loop or maybe list comprehension. Yes, correct, Kirti. I will have to loop it using for loop, and then I will have to multiply with that number. But what if I do something like this? What will happen? What do you think will happen? If I multiply this list with 2, what will happen? Let's try. It will create another list with the same numbers repeated again. It is not multiplying it with 2. See, from here, it has created another, it has added the same number of elements inside the list. So we cannot do such task inside this list. We cannot do matrix vector multiplication or vector addition, matrix multiplication. We cannot do such tasks. If I want to, if I have, let's say, another list 2, which has some other elements. Now, if I want to add these two lists, list 1 and list 2, add as in I want to do element wise addition. So which is basically my list 3 should be 1 plus 2 is equal to 3. Okay. Then 3 plus 3 is equal to 6. 5 plus 4 is equal to 9. 3 plus 5 is equal to 8. And 6 plus 6 is equal to 12. I want this to be an output. Again, I will have to loop in through a for loop, and then I will have to do. I can't do just like this, ls plus ls t. If I do this, again, it will add these two lists. It will concatenate these two lists and give me the another list. So it is not doing the matrix addition, matrix multiplication, or vector addition, vector multiplication. Run button, or even in Colab, you can use shift plus enter or control plus enter. Okay, these are the two options. Control plus enter. This is a shortcut for running the query, or shift plus enter. Both of them will execute the query. The difference between these two queries is control plus enter. If you type it, it will stay on the same cell even after running. If you type shift plus enter, the cursor will move to the next this thing. So this is the reason the lists are not very powerful tools when we want to do such mathematical computations or the vector or linear algebraic computations. That is where NumPy comes into the picture. So NumPy array consumes lesser memory due to contiguous memory location. What does it mean? When you store the data inside list, how it is stored? It is stored at wide variety of locations. So we know in our memory, okay, we have a memory blocks, okay, like this. We have memory block. So suppose we have these 10 elements, we have to store these 10 elements, 1, 2, 3, 4, 5, 6, 7, 8. We have to store these 8 elements inside our memory. So when we store data in our list, they are stored across wide variety of places. They are not stored consecutively in the series of memory location. They are scattered across different locations. That's the reason when you retrieve data from list and when you want to do perform, it takes longer time to retrieve data set and perform the operations and again store them back into the store location. But when you store data set in NumPy, the data set is stored serially. So if your address location is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up until 1024, when you store data set in list, this one element might be stored at one location, number 1, 2 might be stored at 25th location, 4 might be stored as 100th location, something like that. But when you stored it in NumPy, it is stored from 1 to 8 sequentially in a series. And that is the reason NumPys are faster. There are a lot of predefined functions available. We are going to talk about in detail in today's environment. Okay. So this is all about the NumPy arrays, why NumPys are better and everything. Let's not waste any more time on theory. Let's start using the let's start implementing the NumPys using our Python. Okay, so let's see how to create a NumPy array. So one thing before we move on, one thing which is very important, before Python got popularized or all these open source techniques got popularized like Python, R, etc. There was a tool called Matlab. Okay, still it is our existence. It is an enterprise tool, which means you have to pay huge amounts to have the license to this tool. And this tool provides the applications of mathematical operations and scientific calculations, etc. So NumPy is one of the alternative open source or free alternatives to this NumPy, this licensed costly tools like Matlab. So this is the reason why it is important to understand NumPy. Another reason, Pandas library that we are going to talk about in next session, that library is built upon this NumPy. So basically the backend which is used to design Pandas library is actually based on the NumPy. So that is the reason it is important to understand the NumPy. All right, so let's get started with our practicals and let's understand how to create the NumPys. Kirti, third point. Okay, and it is important part of machine learning because machine learning algorithms that you will be learning in your upcoming modules, that those also use this as a backend. So sklearn is one of the widely used library for machine learning techniques. The backend is based upon NumPy. Panda is worked as front end and NumPy as backend. And both of them are backend techniques only, but it's like NumPy, consider NumPy is as learning alphabetics and Pandas is learning how to write essays. Okay, so before you write essay, you need to learn how to form the words and form the sentences. Okay, so Pandas is higher level library. NumPy is the base for that. Okay, so let's get started. Okay, so we have seen how to install NumPy library using pip install. No need to do that now, but this is just for your understanding so that going forward, if you have to install any other libraries, you can make use of it. So let's understand how to create NumPy libraries, NumPy arrays. And before that, let's understand how to load the NumPy library. So I told you that NumPy library comes pre-installed with the NumPy with the Anaconda framework. So we don't need to install it separately, but we have to load it. That doesn't mean we don't install, does not mean we have loaded it. So to load the Python NumPy library, we use our import command, import NumPy. So even if you write this like this, still our library will be loaded in our memory. But as a general practice, data scientists or data analysts or even programmers use aliases to this NumPy library. So we write it like this, NumPy as NP. So what it means, going forward, whenever we will have to access this NumPy library, we are not going to write NumPy as a complete name, we will write just NP. So we have given the alias name NP to this NumPy library. So we have loaded our NumPy library as NP. NP is kind of a alias name. It's a short version name to this NumPy library. Now you can give any name as alias name. Instead of NP, you can just say N. You can say blah blah. Okay. You can give any name, and it will still load it, and you can still able to access it using this alias name. But as a general practice, there are some words that have been in existence since so many days, okay, since so many times. Even the code which is available on various repositories online, they use this abbreviation NP for NumPys. Okay, so let's load NumPy as NP, import NumPy as NP. Now we can create the oh yes, sure, Gawara, I will zoom in my screen. So we have loaded our NumPy library as NP. So now to create the array, to create the NumPy array, we simply use this NP, that NumPy module that we have imported as NP dot array. So array is a numpy.np.array. Array is a method or a function available in this NumPy module or NumPy library that converts the other data structures or other data types into array format or into NumPy array format. So how do I create? I can give a list as an input to this array function, and it will create that list. It will convert that list into a NumPy array. So let me give some example like 1, 3, 4, 6, 8. So I have given one list. Okay, this is the list because it is in a square bracket. So I have given one list as an input to this NumPy array, and if I run this, see, it has converted this to an array. I'm just printing it. I'm printing as in I'm just running this code without storing back into any variable. So this becomes my array, NumPy array. So to create NumPy array, I use this array method, correct? We call this array method from NumPy library, okay? And why we are not writing complete NumPy? Because we have loaded that library as an NP. So we have given alias name to this NumPy library. So going forward, all the methods that we want to access from this NumPy library, we are just going to use this NP. Okay, so we can give this, create this array like this, and we can store it in some variable. So I'm giving variable as array1, okay, ARR1, array1 as my first array. So if I run this, now that array1 is stored as array1 is my NumPy array. It is also called as ND array. Okay, it is also called as ND array. I will write it over here. Array or ND array. So ND array stands for n-dimensional array. Okay, n-dimensional array. Why it is called as n-dimensional array, we will talk about it. So this is how you create your NumPy array. You can use any other data type also. So instead of list, if I pass my input as a tuple, okay, how do we create tuples? We create tuples using round bracket. Still, it will create the array in a same format. So if I print array1 and array2, see, both of them are created. Both of them are exactly the same format. So don't be confused. Don't get confused because just because they are printed like list, both of them are array. Okay, both of them are arrays. Both of them are NumPy arrays. Now, why it is useful? Tuple is not mutable. Menas, tuple is not mutable means you cannot change the values inside original tuple, but you can convert the tuples to other data formats. We have seen it during our data types classes also. We can convert tuples to list, list to tuples, tuples to dictionary. We can convert it to some other variables. We cannot modify it. Okay. So we are not modifying our original tuple over here. So let's understand what is the difference between list and tuple. So sorry, list and array, not tuple. Tuple we have already covered. So suppose this is my one list. LS is same chip, same with same elements. Yeah, those who have issues, please type your queries along with code. Okay, I hope others are getting. So let's say here we have seen that when we were multiplying this list with 2 or any number, we were not getting quite the output that we wanted to be. It is not multiplying it by 2. So we are getting, we used to get some other list with these same elements repeated again. But if we multiply our array 1, which is our NumPy array, if I multiply it with 2, see, it is giving me the output. This is the output, which is multiplied array by 2. So 1 multiplied by 2 is 2. 3 multiplied by 2 is 6. 4 multiplied by 8 is, 2 is 8. 6 by 2 is 12. 8 by 2 is 16. So this is the importance of array over list. So in list, we cannot do element-wise mathematical operations or matrix operation directly, but we can do it in a using array. So this is the example of one-dimensional array. Let me give you the heading. This is the example of one-dimensional array or 1D array. This is the example of one-dimensional array. Why one dimension? Because it only has one dimensions. So this is the example of one-dimensional array. Why one-dimensional array? Because it has only one dimension. Because it is only a one dimension, as in one list. So one-dimensional array means it is a vector. Okay, in your mathematical termination, in your linear algebraic terminology, it is a vector. One-dimensional array is a vector. Now, what is two-dimensional array? So two-dimensional array is your matrix. Two-dimensional array is your matrix. So what is matrix? It is a table kind of a format. So suppose if I want to create a matrix with 3 by 4 elements, okay, so which is like this: 1, 2, 3, 4, 5, 6. Okay, so I hope everyone understand what is matrix. So this is my matrix, correct? This is my matrix. What is matrix? Matrix is a two-dimensional array. It has two dimensions. What are those two dimensions? First dimension is a row. Okay, so this is one row, this is second row, this is third row, this is fourth row, this is fifth row. So yes, rows and columns. So row is the first dimension. So how many rows we have? We have 5 rows. We have 5 rows. And how many columns it has? Columns is the second dimension. So it has 3 columns. This first is a 1 column. This second is this is second column, and this is the third column. So this is the metric of 5 by 3 shape. The shape of this matrix is 5 by 3. The first element represents number of rows. The second element represents number of columns. So matrix is a, yes, 5 by 3. Correct, Shilpa. So matrix is a two-dimensional array. So in Python or in NumPy, we can create such matrix or two-dimensional arrays using same np.array function. So how to create it? Let's understand. So I will write array3 is equal to np.array. I'm going to use the same method array, but inside this, now instead of passing just one dimension, I will pass 2 dimensions. How? First dimension will be my upper matrix or the upper layout. Let me just write the code and then we will talk. Okay, so let's see what I have written. So to create two-dimensional arrays, I have created 2 vectors inside one big vector, or I pass the information in 2 smaller lists which is part of one bigger list. See, so inside this is my one dimension, and this bigger one is my another dimension. So what it means, this is the array with 2 by 3 dimensions, because we have 2 rows. This is 1 row and this is second row. If we add one more row, we will add like this 4, 6, 9. So here in this array, we have added 3 rows. This is first row, this is second row, and this is the third row. And it has 3 columns. This is my first column, this 1 and 4 and 4, these are my third. Yes, now it has become 3 by 3. Supreet, now it has become 3 by 3. We have 2 dimensions. This represents row, this represents columns. Let's print this, then we will understand how it works. So let's print our array 3. So see how it has printed. It has created this matrix-like structure that we were talking about in the beginning. So this first element, 1, 2, 3, is our first row. This second element, second list of list. So everything we have as a part of our bigger list. So the second list is our second row, and this final list is our third row. So this is how we create a 2-dimensional array. We do not have any other data set as of now. So what we are doing is we are passing our data set, okay, passing our information to this NumPy array in form of list. It is not just important. It is not necessary to provide the data in list. We can even use tuples. So like here, we created our NumPy array using tuples. So we are not using list. We are passing the list information in terms of list, and we are converting them into a NumPy array. So we are not using list. We are converting them to a list. So we are doing the typecasting. We are creating our data set in terms of list. We have to create the data set in at least in any of the format. Okay. So what data type you are using? We are using a list, and then we are converting it to NumPy. All right. So this is how we create a 2-dimensional array. Now we also can create a 3-dimensional array. We will talk about it later on. Okay. First, we will talk about some other functions of the NumPy, and then we will talk about 3-dimensional array. So now, how to initialize all the elements? Let's see what are the other methods to create the NumPy arrays. Okay, so this is the technique which we have seen how we can create the NumPy arrays with using other data types, whether it's a list or whether it's a tuple. Okay, how to create our NumPy arrays using other data types. Now let's see what all other predefined functions available in NumPy to create our lists. Create our Pythons. So we can create Python NumPy arrays using some predefined functions such as ones, range, zeros, full, etc. So let's talk about those functions. Okay, creating arrays using built-in functions. Make sure the syntax, how you are passing it. Okay, so I created one bigger list, and inside this bigger list, I pass these 3 small lists. So let's talk about now how to create the Python NumPy arrays using some built-in functions. So we have already imported our library, import NumPy as NP. So we don't need to import them again and again. We can use the same alias for all the functions. So let's say we want to create a 2-dimensional array with all the values being zeros. So that's where we use a method called as np.zeros. And inside this function, you need to pass the shape of your array which you want to create. So if, for example, if you want to create a 2-dimensional array or a matrix with 3 by 4 shape, meaning you want to create a matrix with 3 rows and 4 columns with all the elements of that matrix being 0, then you use this np.zero function. So see, when you execute this code, it will create an array with 3 rows and 4 columns, or it will create an array with 3 by 4 shape with all the elements being 0. So we can store it in a matrix. So let's say 0 matrix. So create an array with zeros. You can even create now it will create any type of matrix based on what shape you have passed as a input. So if I pass np dot zeros, instead of passing shape as 3 by 2, if I just pass 5, so it will create a vector, one dimensional array with 5 elements. Okay. So whatever number of shape you pass inside this, it will create 1D array. Okay, so if I write this as like this, it will create a one dimensional arrays with only 5 elements inside this. Then we have another function called as arrange function. Now, how many of you remember range function? Aryadip, what is the difference between vectors and matrix? Vectors are one dimensional arrays are called as vectors. Okay, matrix have 2 dimensions or 2 or more dimensions. So here in NumPy, everything is array. Okay, whether it's a one dimensional array, whether it's a 2 dimensional array, everything is array. Okay, so how many of you remember the range function of base Python? So when we wanted to create, let's say, some values, we were using range function. So when we were using our range function, if we have to create values from 0 to 5, okay, we were using something like this, range of 0, 5. And if we convert it to a list, it will create values from 0 to 5, excluding the last value. So this is the starting position, this is the ending position. So in array, we can have similar functionality. For that, we have arrange function. Okay, we have a function called as arrange. Mind the spelling, ARANGE. So arrange function works exactly same like the range function. So the first parameter that we want to pass is from where we want to start. The last parameter is up until when we want to stop. And if we print it, it will create the array with all the elements from our starting and ending position. So arrange function is used to arrange the values from particular point till the particular point based on certain scenario. So this will create one array. I'm giving name as A. Okay, I'm running out of alphabets. So I will give this name as A. So what it will do, it will create an array from 1 to 9. Okay, it doesn't create. Yes, Shami, you can use this function to create any type of matrix. Okay, we will understand how to convert this to a matrix going forward. Arrange, not arrange, spelling mistake, Shilpa. There is only one R. Yeah, here I have made the mistake. Okay, I will correct it. Yeah, that was heading. Okay, yeah. Okay, so this is how we use our arrange function. Now, in range also we have seen that there is a third parameter called as step function. Okay, step parameter. So what the step parameter does, suppose if I want to create numbers from 1 to 10 with two positions by skipping the alternate number. Okay, so basically I want to this is not slice. Okay, so basically I want to create numbers like 1, 3, 5, 7 and 9. Okay, skipping one parameter, skipping one number. Okay, so that is where this third option of step comes into the picture. So now what it will do, it will create the array with 1, 3, 5, 7, skipping one number, alternate number. So by default, this step value is 1. By default, this step value is 1. So that's why when we created the first array, we get values like this. Yes, if you give from 0, 10 to, it will create even numbers. If you create from 0, it will create even numbers like this. This is the same function. If you have studied the range function, this is the same thing. So what it does, suppose this last parameter, okay, this last parameter is for step. So for example, if I want to create from 10 to 100, so from 10 to 100 values, okay, and I want to create the values like this, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So what I will do, I will call this np.arrange method, and I will pass the first parameter is 10, which is starting position. Last parameter is 100, which is my ending position. So I will give 101 because it doesn't take the last value, correct? So I will give 101, and I will pass that I want to increase my step by 10 numbers. So from starting position, create the values till 100 by incrementing the values by 10. So now if I write this, it will create 10, incremented by 10, 20, incremented by 20, 10, 30, and so on and so forth. So this is how we can create, arrange the values using arrange function. It is just like range function. So there is one function called as line space. Okay, line space. So what this function does, it creates the numbers between between starting and ending point with equal distance. So let me give you an example. So if I want to create the numbers from 5 to 10, and if I say create 10 numbers between 5 and 10, which will be equidistant from each other. So see what will happen. Distance, it has created 10 numbers from 5 to 10. So 5 is the starting point, 10 is the ending point, and the third parameter 10 refers to the number of numbers between starting and ending point. So it will create 10 numbers from our starting and ending point 5 and 10, which will be equidistant from each other. So difference between 5.5 and 5 this number would be same as difference between this and this number, which will be same as difference between this and this number. Okay, so that is what line space function does. So if I write 5, it will create 5 numbers with difference of 1.25 between each numbers. If I just write 2, it will just create 2 numbers, 5 and 10, which will be having just 2 numbers. If I write 20, it will create 20 numbers with even smaller differences. So use of this function, I don't recollect any particular use case at the moment, but just see if you ever want to initialize the variables or initialize the numbers which are equidistant from each other. So you will talk about when you in your statistics, you will learn about the distributions. Okay, various types of distributions like normal distribution, uniform distribution, and binomial distribution, various kinds of distributions. So this line space function helps you to create a uniform distributions in your data set. So I don't have any a very layman example to give you, but it can be used anywhere where you will want to create the n number of numbers which will be having same distance from each other. The simplest example I can give you is suppose if you want to create a layout for a particular so this is how you create your vector, okay, or matrix using this line space function. Now there is one more function called as full, np.full. So what this function does, np.full function does, just like zeros, it will create a matrix or a two-dimensional, one-dimensional array with one constant value. So for example, if I want to create a matrix of dimension 3, 4, and I want to fill all the values with 5, then this is the syntax. So how it does, this first parameter is the tuple of, first parameter is basically the shape of matrix I want to create, and second parameter is the value that I want to fill inside my matrix. Okay, so line space is the function which you create. Let me give you an example. Suppose if I want to create a matrix or a vector with values starting from 5 and ending at 10, and I want to create 10 values. Okay, I want to create 10 values from 5 to 10. So it will create 10 values from 5 till 10, okay, and all the values inside that will be equidistant from each other. So that is the line space function. Okay, so full function is used to create a matrix or a two-dimensional or one-dimensional array with the same value filled in that function. Correct, Suprit. Your understanding is correct. Okay, hope you have understood the full function also. Full method. Say yes if you have understood up until now. Okay, perfect. Now there is one more method called as random. So what is this random? There is a module called as there is one sub module inside this NumPy library called random, and inside that random module there is a function called as random. So this random function creates a matrix of shape that you will pass. Suppose if I pass shape as 2, 3, which is 2 rows and 3 columns, it will fill the matrix. It will create a matrix of 2 by 3 and it will fill the random values inside it. Okay, so here in earlier ones we were using one constant value to create a matrix. Here we were creating a matrix for a particular shape with any random values. Hope everything is clear now. So these are some of the methods in NumPy library which we use to why two randoms here? This is the syntax. Can we control the data type of random? Data type, it will always be float. Okay, this random function generates the value between 0 and 1. Okay, it calculate, run it hundreds of times, it will always be between 0 and 1. So it will always be float. This random function returns the value between 0 and 1. So all the values will always be between 0 and 1. We are using two randoms over here because this is a syntax. So in NumPy library, there is one sub module called random. So consider it like NumPy is our big file. Inside that there is a class called random, and inside that random there is a method called as random. So to access that we are using this syntax. Okay. 2, 3 means 2 rows and 3 columns. Exactly. Okay, say yes if you have understood how to create the matrix or two-dimensional, one-dimensional arrays using various functions. Perfect. Now we will talk about inspecting the arrays. Now, what is it? What is the meaning of array inspection? Basically, understanding the shape of array, how many dimensions we have in array. Suppose if we load the data set from some other files, okay, and we want to see how many number of dimensions we have or how many number of values we have in our array, that's where we use the inspection code, or it is called as array inspection. And let's understand what are the different functions we have available for inspecting the arrays. So let's say if we have created the array, let's create one array called A using np.array method, or let me just copy the one which we have created over here. So, okay, I have just copied this third array. So np.array, and I have created 3 by 3 array. Okay, this is my array with 3 rows, 3 columns. Now, to understand understand the shape of my array, which is basically how many number of rows I have, how many number of columns I have, I use this function called this method of my array, NumPy array, called as shape, and it will provide me the shape. Please note over here, this particular method shape, this particular function shape does not have parentheses. Okay, there is no parentheses. Okay, without parentheses we use it. So print it. Always, if you want to print something, always use print function. So it is printing the shape, which is 3, 3 rows, 3 columns. If I create another matrix from the same one, so for example, let's say if I delete one row from this, and if I print it again, print the shape of it again, then see it is printing 2, 3 because it has 2 rows and 3 columns. So this is how you understand the shape of the array. Now we can resize our arrays. We can reshape the array. Let's understand what is the meaning of resize and reshaping. So let's say we have, let me give the heading as reshaping the array. Let's say we have created the array with some elements. A is equal to some 12 elements. Okay. So let me use the arrange function, np.arrange, where I will create values from 1 to 12. And let me print it. It will create 11 numbers. So let's create from 0 to 12 because we want 12 values in our data. So there are 12 values in our array. Okay. It's a one-dimensional array. Now, what I want to do is I want to convert this one-dimensional array into two-dimensional arrays with splitting them into 1, 2, 3, and 4. So I want to create 4 rows and 3 columns. So my this one-dimensional array should look like something like this: 0, 1, 2. This is one row. 4, 5. This is second row. 6, 7, 8. This is third row. And 9, 10, 11. This is the fourth row. I want to convert this one-dimensional array to two-dimensional array of shape 4 by 3, which is 4 rows and 3 columns. So that's where I use my shape method like this. So what I will do, I have created my array. I will use my shape method, which we have just seen above, and I will assign this the new shape to this my shape method. So what I want to create, I want to create a new matrix with 4 rows and 3 columns. So 4 rows and 3 columns. This is the syntax. So if I convert this, and now if I print my A again, it will be converted to 4 by 3 shape. Suppose if I want to convert this again to other shape, let's say 3 rows and 4 columns, then I will simply change it to 3 by 4, and it will convert it to 3 rows and 4 columns. So see, something like this. I can even convert it to 2 by 6. I can even convert it to 2 by 6. Any shape, as long as the mathematic fits. Meaning, the number of total elements should match with your shape. So, in our original data, original matrix that we created, it had 12 elements from 0 to 11. Okay, so here we can convert it to any shape as long as it matches the number of elements. So we had one-dimensional array with 12 elements. Then we converted it to, yes, so 1 by 12, we already had 1 by 12. So we can convert it to 1 by 12 also. It should not start from 0. What should start from 0? Here we have created these are the elements inside our array. Okay, this is not dimension. This is the values that we are creating in our one-dimensional array. And this is how we are reshaping. So we can create one-dimensional array and we can convert it to a, no, 0 will never be the case, because 0 is not the dimension. It will be like this. Or if you want to convert it to so this is still a two-dimensional array with only one row. Okay, this is still a two-dimensional array with one row. If you want to convert it to a one-dimensional array, just pass the number of records. Because you are creating from 1 to 12. So if you create from 1 to 12, it will generate only 11 numbers. Okay, arrange function does not create the value with the last element. So that's the reason either create it from 1 to 13 or 0 to 12. All right, let's move on. So this is how you resize and reshape the array based on your need. Now let's understand the another function called as dimension. So if we want to understand the dimensions, how many number of dimensions we have? So we know what is one-dimensional array, two-dimensional array. So this shape function gives you the shape of your matrix. So whether it's a 2 by 3, 3 by 4, etc. But if you want to get the number of dimensions from your array, then you use np.dim. Okay, np.dim function, ndim function. So for example, suppose this is my array. I will copy the first two lines of code, this one, okay? np.arange and a.shape, this one. And if I print the dimension of my first array, which is my one dimensional array. So how do I do that? a.ndim, okay, without any brackets. So this will print that it has only one dimension. And after reshaping, if I print ndim, it will say, after reshaping, the second array has two dimensions. The first array has only one dimension. Okay. So dimension and shape, these two things are different. Okay. Please make sure that you understand the difference. Dim shows the number of dimensions. So we have seen what is the one dimensional array. What is one dimensional array? It's a one single vector like this: 1, 2, 3, 4, 5. So this is a 1D array. So this will print this np.arange. This is our one dimensional array like this, correct? So it is this ndim will np not defined because you are not importing NumPy as np. Write like this: import NumPy as np, then only it will work. And two-dimensional array is our matrix, so it can be any shape. It can be 3 by 4, 4 by 5. So it can be 2 by 3, 3 by 5, 6 by 7, anything. Okay, any shape. It will still be two-dimensional array. So this ndim will print. So hope you have understood the difference between dimensions and size and shape. Okay, dimension is the dimensions: 1D array, 2D array, 3D array. The A is equal to matrix multi, exactly. Yes. Our total number of, so size is basically how many elements we have in our data set. So I will copy this once again. I'll copy these two these two lines of code once again, which is size. Now, what is size? How many number of elements we have in our data set? So that is the next function. So how many number we have in this 12 exactly. So both these print statement will give us 12 output, because we have 12 elements. If I print the matrix, we can count it. So see, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements. The second matrix or second array also has 12 elements: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So size method, okay, returns the total number of elements. Exactly. So size is basically number of rows multiplied by number of columns. That is perfectly correct way to understand. Okay. So if I create another matrix like this, C is equal to, let's create two-dimensional matrix, 2, 3. Then, so if I create this C matrix and if I print the size, what would be the size of this matrix? The C array. What will be the size? Can you just, yes, correct. It will be 6. So there are 6 elements. We have 3 rows and 2 columns. So number of elements inside the internal array is our number of columns. Okay, so we have 3 rows, 1, 2, and 3, and we have 2 columns. So shape is 3 by 2, size is 6, and dimension is 2. Got it? Okay, perfect. Now, regarding the data type of array. Data type of array, NumPy arrays. So unlike list, first of all, unlike list, NumPy array can only support one type of data type. Meaning, when I create list, I can create list with multiple values, multiple types of list. So I can create list like this, Ganesh. So my first value is in string. Then I can create the second item as integer. Then I can create third item as float. Then I can create fourth item as boolean, something like this. Inside list, I can have elements of multiple data types, but in NumPy arrays, okay, if I try to convert this to a NumPy array, it will throw an error. Just see NumPy.array a, okay, it got converted, but I think by default it is converting it to a UTF-32 format, which is string. So see, it did not give any error, but it is not accepting their individual data types. Everything got converted to a string data type. So even this 32, 6.77, this true, all the other data types got converted to a string data type. So NumPy array, okay, NumPy array only supports, why string means yes, U32. So in NumPy, okay, in NumPy, the data types have this different kind of acronyms. This D type is little bit different than our Python data types. Okay, so this U32 stands for string. Okay, so apart from our normal, yes, in NumPy only. So this data type is specific for NumPy. Now, how to understand what is, so if that is the case, since it accepts only one type of data type, so let me create one more array, A2 with np.arrange. I'm using arrange because it's easier. Let's say from 5 to 20 separated by, let's say 5 to 20. So np.arrange has these many values. So now if I want to understand what is the data type for this particular array, this NumPy array, I simply use the D type method and it will show me what is the data type inside this NumPy array. So it is int64, which is integer. If I print the data type of our first array, which is mixed one, which got converted to string letter, if I print it using D type, okay. Oh, so now it is throwing error because we have not reassigned it. So see, it is showing U38. You can check the data type using this D type method. Okay, so NumPy array supports various types of data type, including Boolean, integer, float, then it also even supports the date time data type as well. String also, yes. So this U32 which you are seeing, this is actually a string. Let's create A3 with all the float values. Let's say np.array with float values. So let's say 2.4, 5.5, 6.9. Okay, and let's print the data type of A3. So it says float 64, which is a float. Yes, Suprit, this is a string. This U32 is string. Okay. Mine is providing string output as U6. Okay. U6. So let's understand the different data types available in NumPy. All right. So this is how you check the data type of the string. Moving on. Now let's understand what kind of mathematical functions are available in NumPy. So we have seen that even in base Python, there are various mathematical operators and mathematical functions that you can create. So let's see what kind of inbuilt or built-in functions we have in a NumPy library. Okay, if there is a spelling mistake, please ignore. So I'm just writing it as a reminder again. Okay, we actually don't need to import this once again. I'm just importing as a reminder that how do we import NumPy. Okay, because since we have started a different section, but if you have imported once, you don't need to import it again and again. So let's say we have a list. Let's say we have an array. Let's create an array. A is equal to np dot array with values, some values 3, 4, 8, 9, 12. Okay. So if we want to take the sum of the array, then there is a function called as a sum. Okay. So this is how you can use the sum method to calculate the sum of all the values inside your array. When we were using list, remember we had to loop this array using you loop this list using for loop, and then we had to create one external variable. So just understand the importance of NumPy. Just with the single line of function, we can calculate this sum. Now there are some variations of this sum method. So this sum method, if we don't pass any value, without print, it will give you output Shilpa, and as long as this is the last function, this is the last line in your cell, this is also will give the output. But if I write one more line over here, then it will not print this particular thing. It will print the last one. That's the reason it is important to use print statements whenever you want to print the output. Now you can use this sum function in other way by using the NumPy object. So like this, np.sum, and inside that you can pass your array. So this is also same output. This is also going to give you the same output. These two lines of code are exactly the same. Here you are creating the array and you are calling the method. Here you are calling the method using NumPy's object, and then you are passing the value as the input, array as an input. Now let's say we have two different arrays. So this is our first array. A is our first array, and we create one more array called B with same shape, np.array with same shape. So how many elements we have? 5 elements. So I will create another array with 5 elements with some other values. Okay, this is my another array. Now if I want to do the element wise sum, means 3 plus 12, 3 plus 21. I want to create a third array C, which will be the addition, element wise addition of these two arrays. 3 plus 21, 5 plus 45. Yeah, we can do that. A plus B will also. Okay, so A plus B will also work. So when it's a one-dimensional array, we can straight away do this using this plus operator. A plus B, C is equal to A plus B. This is also fine. Now there is a variation of this sum method where we can use np.sum, and we can pass A comma B. If we do like this, it will throw an error. So we have to pass one more parameter called axis is equal to 0. Not taking. Some dispatcher got multiple values. Okay, I think it will only work on. Okay, forget about this. Okay, I think this has something to do with other. So this is how you can create the element wise addition. In other methods, you were not able to do that. So suppose if you do not have NumPy arrays, if you have list 37, moving on. So this is what this is what is the sum function. So similarly, we have subtract function also, np.subtract, but that works on that works on the this thing. So np.subtract, you have to pass the values like this. If I pass my two vectors A and B, it will give me the element wise subtraction. I have given you the two different ways to access this sum method. Okay, so we can use our object, okay, our array that we have created to access the sum method, or we can access it like this np.sum, and inside the argument we can pass our value. So no difference, both of them are exactly same. Okay, two different ways to answer. How to use np.sum? Okay, np.sum a comma b. This is throwing an error. Only integer scalars can be converted to scalar index. Okay, so it is np.sum. This function, it is saying that it is only working on scalar value while subtract is working. So I'm not sure what is the issue, but let me give you why np.sum, how you can use np.sum on the different values. Ideally it should be working. Now it is working. So you need to pass your values, okay, in np.sum like this. So see, so how to use np.sum to use to work on this too. So this is the one method. So you need to pass your two vectors in a tuple, as a tuple a comma b. Then if you do that, it will give you the sum of all the elements from A as well as from B. Now, if you want to, if you want element wise sum, okay, let me do this. If you want element wise sum, okay, which is that is what I wanted to talk about now. So if you want to do element wise sum, you need to pass this one more parameter called axis is equal to 0. So what it does, it calculates the sum column wise. Axis is equal to 0 means it calculates the sum column wise. So it will add 3 and 21. Then it will add 5 and 45. So this is the element wise sum. Now what if you want to create two matrix to another matrix with row wise sum, which means it will sum all the values from the first matrix and it will print all the values from the second matrix or second array. So that is where you need to change axis is equal to 1. So if you do axis is equal to 1, then yes, then it will calculate the sum of first element and it will store it in another array and calculate the sum of second element B, second array B, and it will store it in another element as well. So axis is equal to 1 will do the row wise sum. Axis is equal to 0 will do the column wise sum. Okay, are you understanding the difference? And if you don't provide any access, then it will do the sum on the entire data set from A and B. No axis like this, then it will sum all the numbers from this axis as well as this axis and it will give you one number. See, it is giving 173, which is a sum of all the values. Okay, so this is the first function, which is sum. Then we have talked about subtract function, which will do the element wise subtraction. Without axis, it will do sum all the numbers from both the arrays. Okay, Abdul, I will repeat for axis 1. So for axis 1, it will sum the individual arrays. So it will sum the values from this first array, which is 37. If you count it, 3 plus 5 plus 8 plus 9 plus 12, it is 37. And it will sum all the elements from second array, which is 136. So that is how axis is equal to 1 will work. Here we get column a plus 1, a plus b will give you this. I am talking about the sum function. Okay, a plus will give you the column wise sum, but I'm talking about np.sum function. So this is what subtract does. Subtract will just simply subtract, do the element wise subtraction. Now all these things are applicable to two-dimensional array as well. Okay, two-dimensional array as well. So this is a homework for you. Create a two-dimensional arrays and see the summation of create two-dimensional arrays. Okay, and see how the summation function works. So it will create the element-wise subtraction, addition, and element-wise subtraction. Okay. So I'll just quickly go through the other mathematical functions. This is subtraction we have covered. Now, other mathematical functions, other math functions, which are multiplications and divisions. These are, the syntax is same, np dot multiply, and if I pass a comma b, it will do the element wise multiplication. So for, okay, I'm not defining the arrays once again, we are using the same arrays. So this is multiplication. Then we can similarly have division, which is np dot divide. So it will do element wise multiplication and element wise division. So a will be divided by b. I'm just writing the print function because so that we can see all the values. This is for division. No, yes, Danny, this is element wise. This is not a matrix multiplication. Correct. You're right. This is not matrix multiplication. It's element wise. See, A is 3, B is 21. So 21 multiplied by 3 is 63, and same so on and so on. This is not dot product. This is a element wise multiplication. Then we have some other functions like exponent. So if you want to calculate the exponential of array, we use np dot exp, and if you pass our array, it will calculate the exponent. Exponent. Then we have np dot sqrt, which will calculate the square root of your array. Square root function will calculate the square root of all the element inside your array. Exponent function will calculate the exponent of all the values inside your array. And all these things are also applicable on multi-dimensional array. Okay. Then there are many other functions like np.log, which will calculate the logarithm. Then there is np.sin, np.cos, all the other tangent trigonometric functions, everything. So I'm not sure whether sine trigonometric functions you will ever use, but the other functions like logarithms and exponents and square root, all these functions we will be using on using frequently. Okay, let's move on to the next topic, which is array comparison. Now, if we want to compare the two arrays, whether two arrays have same elements, then that's where we have another method called as equal. So let's say if I have array, or these functions also works on lists also. So if I create a is equal to 3, 4, 5. Okay, this is one list. There is a second list called b is equal to 3, 4, 5. Same. And let's say I want to compare whether this a and b are same. I will use np dot equal, and I will pass a and b my values, and it will compare element wise. It will tell you which of the elements inside these arrays match. So all the elements are matching. It will give you the true wherever it matches. Element wise comparison. It will give you whether which all elements in your arrays are matching. That's where it will give you true. If you change the element, yes, exactly, that's the condition. It should have the same shape, otherwise it will throw an error. It won't be able to compare. Yes, Mohammed, that's correct. So see, in this array I changed the value, so first two elements are matching, second last element is not matching. What if we want to compare? Let me create one more array with same element 3, 4 and 0. So what if I want to compare whether two elements are matching exactly? TTF. Yeah, this will give you TTF. But what if I want to see whether the entire array of B and entire array of C are matching or not? So that is where we have another function called as array equal. np.array underscore equal. So this checks whether the entire array is matching or not. So if I compare A and B, in A and B, we have one last element different. So it will give you answer as false. So this is called as array comparison, array-wise comparison. And since since B and C have exactly same elements, if I change these positions to B and C, C and B, let's say, then it will give me the true because both of them are same. So when we want to check, it does position wise. Internally it does position wise, it will check. Yes, if you change the order, then it will throw an error. So it does position wise again, element wise. So if your 4 is here and 3 is here, still it will give you the false. See, so it does element wise, and then it throws whether the entire array is matching. Okay, hope you have understood it. Say yes if you have understood this. Now let's understand some of the aggregate functions in Python. Aggregate functions in NumPy. So what is the meaning of aggregate functions? Aggregate functions are those functions which gives us one single value. So addition is also one aggregate function, which is sum, which we have already seen. So let me copy this three arrays once again over here. So this works on list as well as NumPy arrays. So you can convert this to NumPy arrays, or you can use it as a list. It doesn't matter. Equal can be possible for two-dimensional arrays also. Yes, multi-dimensional also. It will check element wise. So if it is a two-dimensional array, it will check for each position in row as well as each position in column. Supreet. Okay. So let's say these are the three arrays, and let's see what are the aggregate functions we have. So we have np.sum, which we have already seen. So if I pass A, comma B, it will give me the sum. Okay, it is not working. Sorry, it is not working because I will have to pass axis also. Yes, or we will have to pass it in double brackets for both the things. So if I pass only one array, it will calculate the sum on the entire thing. If I have to calculate the sum of two arrays, I will have to pass it in a tuple in double brackets. Correct. So sum is one of the aggregate function. Then we have minimum. So it will give us what is the minimum value from that array. So here in the first array, we have minimum value as 3. Minimum is 3. Then we have mean. So np.mean. So mean calculates the average. Okay, it calculates the average. I'm only doing it for one array. So these are aggregate functions. These are not matrix operations, Shilpa. These are aggregate functions. That's the reason we have created a separate section. I'm doing it on only one array. And there is no need to define the second array for these functions. I will tell you why we have defined this second and third array. So you can pass multiple values also like this, A, comma B, and it will give you the average of the entire thing. Okay, so it is giving you the average between both the values. Okay, so I'm just showing you what all are aggregate functions available in our NumPy library. So we have median also. I hope you know what is median. Median is always the middle value. So if you don't know what is median, in your statistics class, you will understand. I'm just giving you what are the functions available, because if I explain median, it will take a lot of time. Then we have something called as correlation coefficient. Okay, so np.corr coefficient, correlation coefficient. It calculates the correlation between two arrays, A, comma B. Okay, what is the meaning of this correlation coefficient? I'm not going to explain now because it will take a lot of time. I'm just explaining. I'm just giving you the functions to calculate the correlation coefficient. You will understand the correlation coefficient in your statistics class, because it's a completely different topic altogether. Then we also have something called as standard deviation, STD. The function is called STD. You just need to pass the your array. So standard deviation. If you don't know what this means, don't worry. It is going to get covered in your statistical classes. So don't worry about it. I'm just telling you what are the functions available to create. What is the meaning of it? You will understand in your statistics class. So these are various statistics functions we have available as a part of our NumPy library. Okay, so mean, sum, minimum, mean. Then there is also one more function like minimum. We also have maximum. Okay, we also have maximum, so which will calculate the max from this output. So if you use print statement for all these values, you will get output for all the things. Since we haven't used print statement, it is just giving answer for the last function. Okay, next chapter, which is slicing. This is very important, indexing and slicing. Next topic is, okay, let's understand indexing and slicing. Okay, this is very important. Now let's understand it with some theory. Let's understand indexing and slicing. So let's start with one-dimensional array first, and then we will move on. So suppose if I have my NumPy array, okay, x is equal to np.array, and inside that I am creating some values. Okay, this is my array, and I will print it. Now, indexing in Python is very similar to indexing in list. So if I want to extract this third element, 45, how will I do it? I want to extract third element. If I were to do it in list, what will I write inside this square bracket? I'm asking you. Positioning, correct. Not all the elements up until 2. I just want to extract 45, not until 45. So I will just write 2, because indexing starts from 0. So my first element will have index 0. My second element will have index 1. And the third element that I want to extract will have index as 2. If I want to extract the first 3 elements, yes, Shilpa, opposite starts from -1. So negative indexing will be from last position. If I write -1, I will get the 12, the last index. So indexing is exactly same as we have it in a list. If I want to extract, yeah, in my Python list, correct. So index extract 45. So I will write x of 2, correct. Now if I want to extract first 3 elements from 1 to 45, what will I write? We will write either from 0:3, because it doesn't extract the last element. Okay, 0:3, because it doesn't extract the last element. It extracts n-1. So we will write 0:3. Or we can also write just :3. This is also same. So :3 indicates from beginning till the third position. Yes, indexing starts from 0. So from beginning, from the 0th location till the n-1th position, n-1st position. Extract. So this is extract till 45. So all the other syntax which we use generally for list remains exactly the same. If I want to extract after 45, all the elements after 45, I will write 2:3. like this. So yes, Menas, you are right. 2 colon. So it says after 45. So it says from second index up until the end of the array. So this is how we do it in a one-dimensional array, because here we have only one dimension. So we just need to pass our starting position and ending position separated by colon. So this is for one-dimensional array indexing. Now let's understand about two-dimensional indexing. Okay, let's create in a second another sheet. Two-dimensional array indexing. So let me create one two-dimensional array. A is equal to 2, 3, 4, 5. Then, oh, okay, for simplicity, let's create in a sequential 1, 2, 3, then 4, 5, 6, then 7, 8, 9. So this is my two-dimensional array. If I print it, it's a 3 by 3 array. Let me convert it to a string. Array. NumPy array, np.array. So it's a two-dimensional matrix with 3 by 3 shape. Now, if I want to access, so let's understand how indexing and slicing works in a two-dimensional array. So if I want to access the first row, okay, so indexing in array starts like this. So we have comma to separate between rows and columns. So before comma, we have rows. Before comma, we have columns. So suppose if I want to extract first row, entire first row from this matrix, I will write 0 colon all the columns. See what is happening. Or this is also same thing. Why? What I did? I wanted to extract my first row. So indexing start with 0. So 0th row. And if I don't specify any value after comma, it assumes that I want all the columns. So 0th row and all the columns. So columns are 1, 2, 3. So extract first row and all the columns, or entire first row. Don't get confused with first row and 0th index. So first row means 0th index. You can write this same thing like this also. 0 colon 0 comma colon. This thing and this thing is exactly the same thing. So first of all, we have seen that colon we use. Yes, comma is important because the comma will decide whether we are talking about rows or comma. So before comma, it is row. After comma, it is column. So let's understand with other example. So these two things are exactly the same thing. So for example, if I want to extract first row value in this, if I want to extract 1, so 1, what is the position of 1? 0th row and 0th column. Do you agree with this? 1, the position of number 1 is 0th row and 0th column. Do you agree? Yes. So I will simply write a comma 0th row comma 0th column. And if I print it, I will get my value 1. If you want only column, means you want 147. Is that what you are asking, Akshay? We want 147. Yes. Then we want only column, which means we want all the rows and first column. So what comes after comma? Column. So we want all the rows. Okay, let me write it in some other value. Extract first row and first column. So this is the code. Now, if I want to extract first column, entire first column, which means all the rows. So 1 is in my 0th row, 1 is in my 0th index, 4 is in my second row, third is in my third row. A of 0, 0, this will not work. This will work. Yes, A of 0, 0 will also work. Jandip. Okay. But this is better syntax because it helps us, it allows us to do slicing. We will talk about slicing just in a minute. So this is the reason the syntax which I am using is correct or better. Yours is also correct, but this is better. Okay, so all the rows, so that's the reason I have mentioned colon over here. This tells I want all the rows and 0th column. So it is extracted 147. Now, if I want second column, which I want to extract 258, what will I change over here? If I want to extract 258, what will I change? After comma, I want to extract row, column. Yes, correct. Yes, now you are getting it. So if I write 1, it will extract 258. So this is called indexing.
Let's have a quick quiz question, guys. And the question is, what is the primary goal of exploratory data analysis? And your options are to build predictive models, to summarize data using statistical measures, to identify patterns and relationships in data, or to validate the accuracy of data. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Now, if I want to extract some middle values, so for example, if I want to, this is my array, 3 by 3 array, okay? And if I want to extract the section which is highlighted in green, this one, this entire section, okay? This entire section highlighted in green, which means in our program, I want to extract these first 2 rows. I want to extract 0th row and first 2 rows. So if I want to extract this first 2 columns, first 2 rows, okay? Yeah, many of you are trying to answer. Let's see. Extract first 2 rows. So rows is our first column, okay? Sorry, rows is our first index before comma. So we want 0 and 1. So from 0 till 1. So if I write this, it will only give me first one. So I will have to write 0 to 2 because the second index, it will not return. It will return 0 and 1. It is always n minus 1. We have seen it. Correct. Yes. So I want to second and first row and all the columns. So I will simply write colon and it will extract the first 2 rows. So see what we wanted to do. We wanted to extract these first 2 rows. So in our indexing or slicing, I will give you the heading as slicing. So if in our slicing code, whatever comes before comma, it is our rows. So how many rows we want to extract? We want to extract first 2 rows. Now we know that if in indexing, when we index, we write like this. So 0:2 means it will extract 0 and first row. It won't extract second row. So that is the reason we want 0:2, the first 2 rows, and we want all the columns. So we want this entire thing, all the columns. So that's the reason we have written like this. Now, just the explain to the extension of this one. If I want to extract second and third row, what will I write? Extract last 2 rows. What will I write? Yes, correct. Now you are talking. Now you are getting it. Okay. If I write this, I will get second and third row. Perfect. Now, if I want to extract first and second column, not row. Extract first two columns. Yes, all the rows and first two columns. Not two, it will be three. Okay, because it won't take the third. Oh, sorry, it is taking everything. 1, 2, 1, 4, 5. Yes, correct. Sorry, yeah, it will be 2 because second index. It will take 0th and first index. Correct. So this is our original matrix, and I wanted to extract this first column, which is 1, 4, 7. I wanted to be wanted output like 1, 4, 7. Sorry, 1, 2, 4, 5, and 7, 8. Okay, this is the output I wanted. This is my original matrix. I wanted to extract these first two columns. So now, how to extract the columns? We want only first and second column, but we want all the rows. So before comma, we will just simply put this colon because it will tell that we want all the rows and we want first two columns. So it will start from 0th position, 0th index, and up until second index. So it will extract 0 and 1. Got it? Perfect. Now we will just do one more sum and we will stop for the day. So if I want to extract middle part of it, okay, so suppose I want to extract this part only, or let's say this part, this dark green color, which means from second column onwards and first and second row, second and third column and first and second row. Are you getting it? Yes, first and second row and second and third column. So in our, exactly, Surpreet. So in our program, we want this output 2, 3, 5, 6. Okay, so extract 2, 3. I'm just writing over here like this, 2, 3 and 5, 6. So how will I write it? Print. Some of you have already got it correctly. Print A. So now how many rows we want? We want first and second row. So which means 0th, 0 to 2, 0 to 2, comma, we want first the second and third column. So it will start from 1 index and it will end at 2. So see if we have got, okay, why it is taking 2. Okay, sorry, 3. I will have to pass 3 because it does 1 n minus 1. Yes, correct, Shilpa. Yes, so it has extracted 2, 3, 5, 6. So this is called as slicing in 3 because indexing end position, it always take n minus 1. So it doesn't take last position. So the index for our third column is 2. So that's the reason we are passing 3. So 3 minus 1 will be 2. Suppose if I have this array 1, 2, 3, 4. Okay, this is my array. Y is equal to this one. So if I want to extract these first two elements 1, 2, what I will write? Y 0, 3. I will write 3 because, sorry, I will write 0, 2 because this is the first index, which is 0th. First position is 0th index. This is first index. So to get until first index, I have to write 0, 2 because this is the syntax of indexing. It takes, this is the starting position and ending position is always n minus 1. So 2 minus 1 is my 1. So it will take 0 and 1. Same concept is applied over here. In order to get my second index, which is this one, second column, I have to pass 3, and that is why and that's how I will get my this second and third columns. If you do y of 0, I will get, if I do y of 0, I will get 1 because it's a one-dimensional array.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
So let's create two arrays. I'm creating one array. So we know first of all we have to import our NumPy because I haven't ran any of the code. Import NumPy as NP. So either you can run the previous code which we have already defined earlier. If you just import it here from here, that is also fine. This is a different way. So I'm writing one more time. So first we have to import. Without importing, nothing will work. So we have imported our NumPy library and the alias is NP. So we can access all the methods in NumPy library using this NP alias. So I'm creating an array called A. So how do we create array? NP.array, NP.array, and inside it we need to give our array. So we can give the values as anything. I'm giving it input as a list. We can give it as a tuple, set, anything. We can even use the arrange function to create the array. So I'm just giving some random values over here. Then I'm creating another array using same method and np.array, and I'm creating some other variable over here by specifying some other values. So I'm just ensuring that both the arrays have similar. So I have created these two arrays. Now, as a part of data manipulation technique, we have some methods available in NumPy, which we can use to merge these two arrays, whether it's a one-dimensional, two-dimensional. So these two arrays we have created. Now we have a function called as concatenate. Okay, so np.concatenate. So as the name suggests, concatenate, this function will merge both these two arrays. Okay, whatever arrays we will be passing as an argument. So remember, we need to pass them as inside this bracket as a tuple. Okay, we need to pass these two arrays as a tuple. So when we when we combine these two arrays, when we have to combine these two arrays, we use this np.concatenate. So what will it do? It will create third array, okay, by combining both array, by combining the elements of both of these arrays. So see, if I run this code, so it has taken all the elements from array A, it has taken all the elements from array B, and it has appended both the arrays and created one more array called so we can assign it to another variable C. So C is my another variable which is used concatenate two arrays. Okay, so basically what it does, okay, so now if I print this C, then I will be able to see the output. Okay, so these are very small things which you need to take care of. So concatenate is the function. Okay, you don't want to duplicate number. Okay. So there is no direct functionality to duplicate numbers. So, but we have seen a data type called set. Okay, so set is the data type which we use to eliminate all the duplicate values. So what you can do is you can concatenate it, then convert this C to set like this, and then you will have only unique numbers, and then maybe you can convert this back to the numpy.array. So if you understand the fundamentals, you can do anything. So it is actually an array, but it is being displayed as a set because we created it from set. So this is how you can do it. You can do anything if you know how to cast the data type from one data type to another data type, typecasting. Okay, data type conversion. All right, so this is how you concatenate two NumPy arrays. Then there is one more function called as h stack. So what if I don't want to create one single array by combining two elements. Rather, I want to create a two-dimensional matrix, a two-dimensional array by using these two single-dimensional arrays. So basically, I want to create a third array which will have this one as a row, this one as a row. So basically, I will be having 5 columns and 2 rows in my data set. Okay, so basically I want to create a NumPy array matrix from these two arrays, which will have, okay, this first array as my first row like this, and then second array, which is B, as my second row. Okay, so this is how I would like to be my third array C. So to create, yes, 2 by 6 matrix. So to do that, we have a function called as h stack. Okay, so stacking means layering one array with another. H stands for horizontal. So here we need to pass our array A, then array B, and if you do that, okay, we have to pass it as a tuple. Okay, remember. So if we do that, why is it not working? Sorry. Okay, h stack works similar to our concatenate. So h stack horizontally stacks the variable, horizontally stacks the our arrays. So to stack them vertically, or to create a two-dimensional matrix, we use a method called as vstack, which stands for virtual stacking. Yeah, for creating our matrix like structure, which is two-dimensional array, we use vstack. So h stack works similar to concatenate because it concatenates horizontally. Okay, and vstacks concatenate vertically. So now you can see the output is printed. H stack is equal to converting 1D horizontal and making 2D, vstack converting and make 2D. So think it from this perspective. Horizontal stacking is basically putting one array and putting array next to second array. Okay, horizontal will stack them horizontally. So I will be putting this array. Okay, so suppose array A, this is my first array. Okay, and this is my second array. So horizontal means I will be putting them next to each other in a horizontal fashion, something like this. So after performing operation, both of them will get merged into one single dimensional array only. But when I stack them vertically, they will be one below another, or one top of another. So they will look like this two-dimensional matrix. Okay, so that is the difference between horizontal stacking and vertical stacking. H stack convert, if I have two-dimensional array, so let's say I have this I will store this vertical stacked array in a variable D. D is my variable, which is a two-dimensional array, and I will create one more variable E with same values. Okay, just to show you how it works. So I have now D and E, both of them are two-dimensional arrays. So now if I use np.hstack and if I pass D and E, again I have to pass it in a tuple. So it will not convert them into one-dimensional array. It is still a two-dimensional array, but the values from first row of my array D will be merged with my values of my first row with the values from array E. Yes, it will layer it. Correct, Shirpa. It will layer it horizontally. Now, same thing if I do vertically, it will create 4 by 6 matrix, because I have added 2 rows on top of 2 rows. In the array D, I had 2 rows. In array E, I had 2 rows. So this is how it will layer it. Okay, perfect. Now, so we have one more function called as column stack. So what it does, it stacks the columns. So for example, what if we wanted to, instead of creating row out of this first array and second row out of this second array, what if we want to convert this first array into first column and second array into second column? So instead of creating rows just like we do in VStack, we want to create columns from our original arrays. So that is where there is a function called as column stack. So here we pass our two arrays A and B, and it will convert them into columns. So see, our first array, which is 1, 3, 4, 5, 6, 5. Now it has got converted to a first column of my resultant array, and second matrix or second array B, this got added as a second column of my second array. So this is how column stacking works. So vertical stacking will add them as a row wise, column stacking will happen column wise. So this is another function. All these functions are useful when we want to do any complex mathematical calculations, like calculating determinants, or calculating the matrix multiplication, dot product. So there we may have to convert one matrix into another matrix, data type, transpose, etc. So that's where we can use these functions. All right, and now one last method that we are going to see, it's called as h-split. Okay, np.h-split. So what h-split does, it splits the array. Splits the array in 2 or 3 or whatever number of arrays that we define. So let me create one array, okay, x, by using arrange function, np.arrange. Basically, why do you even need to pass a single column? We are using these stacking functions, column stack, B stack, H stack, concatenate. We are using these functions to merge two arrays into and converting them to one single array. So the question is, why do I even want to use it on one single array? Okay, so syntactically it is not giving error, but logically it's no use. So just because it works doesn't mean we have to use it for single array, because logically there is no use of using one single array. So let me create one array with, so these are all the basics. Okay, so we are learning how to use NumPy arrays as a part of our exercise. So these functions are used day in and day out when you will be working on real life data analysis projects. So you are working in a banking, you are working in a manufacturing, you are working in a retail. Day in and day out, you will be working with lots and lots of data sets. So on that data set, you will be doing the analysis. So analysis is what you will want to understand how much sales you have generated in last month. So, or how much what was the maximum sales in a particular region. So you may need to convert that to a data frame or NumPy array, and then you take the maximum amount of it. So applications are endless. Right now we are just learning ABCDs of all those things. What are the use cases? Use cases are endless. So everything is used for data analysis. So we are going to start with Pandas. So that is the one of the highly used data library in data science and data analyst domain. So now I am creating a third array called x, and I'm using np.arrange function. So what it will do? Pandas is all about hands-on, and I will also show you where ND arrays are used compared to Pandas. Anything, any mathematical operations, any data analysis, wherever you need to do any mathematical operations, that's where NumPy is used. Okay, so don't be overwhelmed that where is it used, how will I know where to use it. It will come to you automatically when you will start working on it. So we are just understanding now what all what are the tools available to us. Okay, so just think of it like now you have let's say a hammer and nail, and you are just learning to how to hold the hammer and how to struck it on the nail, how hard or how slow you need to struck it on the nail. Now how to use this nail and hammer to create the furniture, that will come to you automatically. Yes, like we did it in Python. But basic Python is not that efficient. Okay, now after this particular part, we will understand why basic Python is not very efficient, and why NumPy array is much more logical, why NumPy array makes sense to use logically. Now I have created this array. Okay, and if I print this, I can see that it is a value from 0 to 15 with the single elements. Now if I reshape it, we have learned the reshape function last time. So if I want to convert this to a 4 by 4 array, okay, the same array will get 16 is the size of number. I want to arrange my numbers from 0 to 16. So now we have used a reshape function, and we have converted this one-dimensional array to two-dimensional array with 4 by 4 matrix. 4 by 4 matrix. Now, what if I want to split this 4 by 4 matrix into two matrices? Okay, I want to create two separate matrices from this 2 by 2 matrix. So that is where we use this hsplit function, np.hsplit, and I pass my matrix x, and I say that convert it to a 2 matrix. So see, it has converted it to a 2 matrix. So this is my first array, which is 4 by 2 columns, and this is my second array, 4 by 2 column. I can even pass it as a 4. It will create a 4 arrays of 4 by 1 values. But you can't pass 3 because it is not in a multiplication of our size of our original array 16. So you need to pass the value which is basically which can equally divide our original array into equal parts. So I can, if I pass 2, it can. So orange is basically creating this one-dimensional array, so with values from 0 to 16 excluded. Yes, we are just creating one array. Okay, so this is how hsplit function works. Now just to understand, Pradeep, hsplit, okay, I will explain hsplit. So just think of it like this. It has to be, we must be able to divide this number of elements into equal parts. So our original array has 16 elements. So that means we can divide it into x comma 4 can also be executed. We just did it some time back. See, it will execute, it will convert it into 4 different arrays. So in every array, it will have 4 elements like we stack. So here it is converting into a horizontal, here splitting into horizontally. So if I print x, so see, our original array was this. So it is converting, splitting it horizontally. So it is taking first 2 columns and creating our first array. It is taking second 2 columns and it is creating the second array. If we use vsplit instead of hsplit, if we use vsplit, it will split it vertically. So it will take first 2 rows and create one array. It will take last 2 rows and it will create last 2 arrays. Yes. So there are many such methods available in NumPy. It is impossible to cover each and every one of them. But now you know how NumPy works, how to call the methods of NumPy, and how to check what values to pass. And wherever you want to see how any method, how to get the help for a particular method, okay, you just type it, open the brackets, and just shift and tab. Just press shift and tab inside this parenthesis. So it will open this window. Just click on this plus and it will show you what this method does and how to call this method, what type of arguments you need to pass. That is how you need to you can check the help of any method. So shift tab, shift plus tab inside the bracket, inside bracket. So basically it has to be in a multiple. So just think of it like it like this. If you have original array 3, 6, 9, so here you have array which has 9 elements. Yes, it has 9 elements. So it can only be divided into 3 equal parts. So your matrix is 3 by 3. So now you cannot divide it into 2 equal parts. Can you divide it into 2 equal parts? 4 by 4.5 and 4.5 will not work. So if you have 18 elements, you cannot reshape it to 3 by 3, because 3 by 3 will only create, no, not even 4 by 4. How many elements you have? 18. So the multiplication of this 3, 3 or whatever number you pass, it should be equal to your original number. So it will be 6 by 3. Okay, 6 by 3 will be 6 by 3 will work, because 6 multiplied by 3 is 18. 9 multiplied by 3 will won't work. 9 by 9 is what is 9 by 9? 81. Do you have 81 elements? It won't work. 9 by 2 will work. Yes, correct. Okay, so these are logical, parts. So just practice it. Practice is the only thing that will make it clear. Okay, now to show you why. So don't bother typing this code. I will anyway share this file with you. This is just to show you why NumPy array is better than using list or inbuilt data types of Python. So if I have just created this list with 1000 elements, okay, using my range function. So we have seen range functions during our list class. So what it will do, it will create a list with 1000 elements starting from 0 to 999. Now what I have done, I am just multiplying this length of this list and getting the size of my list. So basically what I'm doing, I'm just printing the size or the memory which it has taken inside my memory, how much size it is allocating. So I'm creating one list and I'm just printing and using this system library. Don't worry if you don't understand, this is just for your information. So sys.getSize of this method tells me that what is the size of this particular object that it is consuming inside the memory. And then I created an NumPy array with same number of elements using arrange function. So it will also create the values from 0 to 999. And if I check the size of this particular method, this particular NumPy array, see the size which normal list consumes in my memory, it is 28,000, whatever units it is taking, as opposed to my NumPy array, which is only consuming 8,000. So there is almost more than 3 times saving of memory when we use NumPy array over the list. Similarly, if we want to check how much time it takes to process the list versus NumPy, so what we are doing, we are just defining one function over here. Inside that function, I am using this one time library. So what it does, it starts the time .time. So time is just another library like NumPy. So it is used to perform some time operations. Okay. So this time.time will start the time. Okay. It will begin the clock. So it will give me what is the current time when this particular line executes. And I am creating 2 lists X and Y using range function with 10,000 elements. And I am adding the values from X elements and Y elements. And I'm creating third list by using my list comprehension, using my single liner for loop. So adding the values of list A, list X into the and list Y, and creating the third array list Z. And then finally I am returning the time, which is basically what I'm doing. I am subtracting the T1, which is my initial time, which we started before starting this summation, and I'm subtracting it from my current time. So what it will give me, it will tell me how much time it has taken to process this much of data, or process these three lines of code. And same thing I'm doing over in this function using NumPy, but instead of using normal list, I am using my NumPy arrays. So I'm creating NumPy arrays using arrange function, and I'm simply adding A plus B, because that's how we can do using NumPy arrays. We don't need to loop them. Using arrays, we can simply add A plus B, and it will create a it will do the element wise summation, and even it will return. And similarly, I'm calculating the time, how much time it is going to take. So when I use NumPy, when I use list, it takes this much amount of time. When I use array, it takes this much amount of time. So now we are using only 2-3 lines of code and very small amount of data. So this difference is not very significant. But if you check the comparison, arrays take, or list take 7 times more amount of time than the NumPys. So arrays are 7 times faster. NumPy is 7 times faster than our normal lists. So just think about it, when you will be working on a real life data set where you have hundreds of MBs of data set, and then you are processing it. Then if lists are going to take 1 hour of time to process a particular data, process a particular calculation, NumPy arrays can do it in 1/7 of time. So maybe just how much? 5-6 minutes. That's it. So that is why NumPy arrays are more useful. NumPy is much more faster than arrays. NumPy is much more memory saving object than lists or data sets. Okay, when we work with data set, then we use NumPy. Lists are used when we want to do smaller calculations. Let's say looping for writing a for loop. Okay, so for writing a for loop, we might want to loop through multiple elements. So that's where we use lists. List time is equal to using list. This is a very simple basic thing. We have defined our function called using list over here. We have defined our function called using NumPy over here. So we are calling that list and storing the value which is returned by that particular list. Okay, got it. Okay, all right. Okay, so have your basics clear. That's why I before beginning NumPy, I asked you, each and every one you to do the lot of practice on the basics: for loops, if else, data types, everything. That is the kind of, even NumPy arrays are used when you want to make your code faster. So for example, you have written some code to process a particular data, and you have used other data types like pandas or maybe arrays or lists or dictionaries. So that's where it is used. Simple NumPy is used to do the data processing, calculation. That's it. Generally, most of the times you might not even be using NumPy. Very rarely you will be using NumPy. You won't be using even NumPy. Most of the times, 80% of the time, the library that you are going to be using is called Pandas. And that is the library that we are going to start with our next topic, which is Pandas. Yes, we will be creating a new Python file for Pandas, Shilpa. So let's understand what is Pandas. NumPy is very good. Okay, NumPy is faster. NumPy is provides where different types of functions to help us do a lot of calculations, but it is not very user friendly. I mean, if you have seen slicing and dicing and doing calculations also, okay, or visualizing the data set. If you want to see 2 by 2 array, 3 by 3 array, that is fine. But what if your array is 100 by 100? Looking at the values, slicing and dicing, this is little bit complex. It's not that user friendly. Okay. So to solve this challenge and to make analysis much more simpler and much more user friendly, someone developed a library called Pandas. Okay, so we will understand how Pandas is different from NumPy. Okay, when to use Pandas, when to use NumPy. Okay, all those things. So why Pandas? If you are using Python for data science, and you will be, I think many of the students from this class are from the data science class. So just think of Pandas as your go-to library in your day-to-day access. So those who are still working in data analysis fields, I'm sure you are working Excel. Yes, lot of data we handle with Pandas. So like Pandas is the library which provides a very similar environment, similar infrastructure, just like Excel, where in Excel you can do filtering, sorting, and slicing, dicing, then merging, okay, calculating using a lot of functions like aggregating functions, average, sum, max, min, etc. So this Pandas library provides a very similar environment like Excel or even like other databases in a very simplistic manner. It provides us the environment in a tabular structure, just like we have data in our Excel file. In Excel file, we have data in a rows and columns where we can define the names of our rows, where we can understand the data in columns. In the similar way, Pandas provides a data type or data structure called as data frame. And we will understand what is data frame, how to create it. So that is why Pandas is very much more useful, much more better compared to NumPy or any other data structures. 80% of the times you will be using the libraries and you will be solving the business problems. You are not going to write the code, you are not going to write the algorithms like software developers, because we are not developing the softwares. We will be using the Python to perform the data analysis. We are here to solve the business problems. We are problem solvers. Programmers are also problem solvers, but they are solving different kinds of problems. They are writing codes which to create something which is not existed. We are using Python. We will be using different libraries, okay, and we will be using existing functionalities. We are not going. Most of the times, we will not be writing any codes to create a complete new thing. We will be writing, but sometimes you will have to understand how to write a logic, because for writing for loops, for loops, then creating functions there, sometimes you might need to create it, okay, especially when you need to put your code into production. That's when your programming skills comes into the picture. So if you are using Python for data science, then Pandas is a very popular library. You can achieve the result writing 1-2 lines using Pandas compared to native Python. So basically, you don't need to write code, hundreds and hundreds of lines of code to do the simple exercise. In couple of lines of code, you will be able to process your data set. Working with large data sets, okay? So NumPy works better when you have smaller amount of data set, but when you have large data sets, when you will be loading the data set from CSV files or even from the databases like SQL and Oracle, then then Pandas is much more better. So why Pandas is getting popular these days, or since last 10-12 years it is getting popular. It's become very popular because it is accessible to everyone. It is free to use. Nobody is going to pay ask you to pay for it. It is open source. It is flexible. Why? You will see when we will discuss some code about it. It's a powerful tool because it is used in a production level code. Okay, we as a data scientist use this as day in and day out. Without Pandas, we can't do anything. It is very easy to use and also fast at the same time. Okay, so this name Pandas comes from panel data. Okay, panel data is one generic generic jargon used for n-dimensional data set. So, or multi-dimensional data set. That's what panel data is called. So in geography, in a geological field, we have multi-dimensional data set. Means at the same time you need to take care of latitude, longitude, and then temperature and many other factors. Okay, so that's where this panel data set comes into the picture. But for us, we will be using only two-dimensional data set. And when we talk about 2 dimensions, we have rows and columns. That's what we will be using. So the person who created it, maybe he had to work on multi-dimensional data set. We don't need to work on multi-dimensional data set. So the name Pandas comes from panel data. Okay. And this is the guy called Wes McKinney. He created this library Pandas. So basically, he created this library for his own use in the beginning. So then later he realized that this is a very big problem in the industry, and many people must be using it. Many people might need to use such functionalities. So he took the permission of his superiors from his company, and then he finally managed to put this as a open source tool and created a library out of it and open sourced it. And now we can use it without going through all that hassle which he has done. So now how do we use this?
Let's have a quick quiz question, guys. And the question is, which statistical measure provides information about central tendency of a data set? And your options are standard deviation, variance, median, or correlation coefficient. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Pandas library, let's start. So step by step, we will understand how to use this Pandas library. So just like any other library, we first import Pandas as PD. I will just increase the size. So similar to NumPy or any other libraries, we import Pandas as PD. Now, since we have downloaded our Python using Anaconda, just like NumPy, Pandas also comes pre-installed with the Anaconda framework. We don't need to separately install it. So that's the reason we can use it as a Pandas library. We can use it directly without installing it separately. If we had to install it manually, we have seen how to do using pip install in the last lecture. So just like pip install NumPy, we can use pip install Pandas. Now, let me just create one dictionary called person, and I will be creating a you know, nested dictionary where my first key is names, and the values for this dictionary values for this names key would be the names of people. So let's say Ganesh, then Rahul, then let's say Smita. So these are there are three person. Let me write it students. Okay, that will make more sense. Then I will create another key called marks, and Ganesh got, let's say, 70 marks, Rahul got 80 marks, and Smita got 90 marks. So this is the dictionary I have. This is the multi-dimensional nested dictionary, and we have seen how the nested dictionaries works. Now I can convert this dictionary to a pandas data frame by simply calling pd dot data frame. So data frame is a table-like structure in Python or pandas. It's a table-like structure in pandas. So if I print my students dictionary, it looks like this, where my key is the name and marks, and these are the values associated with this key. So when I convert my dictionary to pandas data frame, see how it looks. It gets converted to a table-like structure where my keys becomes the names of the column and the values becomes the rows. So I have my table where my names is my first column, where all the names of my students are like my keys. So students is a dictionary. Now we have converted the dictionary to a something called as a data frame. So I can give it a S. Okay, I can store it in a S. Now my S is my data frame. It's called data frame, table format. So don't call it table. Let's call it a data frame. Okay, what we are going to call it? We are going to call it a data frame. To be specific, pandas data frame. So data frame is a core structure, is a core data structure of pandas, which looks like a table, which is a table actually. It is a table, but we call it as a data frame. Now, this multi-dimensional or two-dimensional data frame, two-dimensional structure, this is called as data frame. But we can also take out this one column out of it. Okay, just don't worry about it. We will be talking about slicing and dicing in detail. But this one column, one individual column from this data frame is called as series. Okay, pandas series. So this names, okay, names is my series. This marks is my series. So one column in data frame is called as series. So from this S, if I take out these names, this becomes my series. Okay, and it looks something like this. So if I print the type of this, say, this series, it will tell me that it is a pandas.core.series. 012 is sequence number. It's a default sequence number. Okay, so we can even create such series, okay, using our other elements, other data types like lists. So suppose if I have a list called names, and inside that I will give names of my students. So Ganesh, Rahul, Smita. So using pd.data frame, we convert our data into two-dimensional data. But this two-dimensional data, which is data frame, has every column which has the data type as series. And we can create a series using our list or our sets or our tuple using a method called as series, pd.series. And inside that, if I pass my list names, it will create a one-dimensional object, a single object, array-like object. In NumPy, we have single-dimensional array. Just like that, we get our one series. Okay, this data structure is called as a series. So consider, for a simple language, series, Pandas series is one column of our data frame. Pandas series is one column of our data frame. So after I type first letter, okay, so PD, after I type PD, I type dot and I write S, okay, because I know I want to type series. So after S, just press tab. So after pressing tab, you will get all the methods which Pandas data frame has, which starts with capital S, and then press C. In Colab, it will not work. It works in local Jupyter notebook. In Colab also, there has to be some way. I never used Colab. I mean, I've used Colabs, but I don't use it on a regular basis. So I will explain Pandas. So Pandas data frame, Richa, is a table-like structure, okay, which we have in a Pandas library. So this is just to give you example. Suppose if you have a dictionary, how can you convert that dictionary into a Pandas data frame? Yes, S of marks is also a series. So S of marks is also a series. So if I, take out marks and then check the type of it. So let me print it first. So see, it is also a series. And if I type print type, it will show me a series. It will tell me that it's a pandas.core.series. All right. So like we have seen, series is a one-dimensional array. Okay. Or in simple word, it's a one column in our Pandas data frame. Data frame is a two-dimensional tabular structure where we have columns and rows. Okay. And panel is some other, there is 1% chance that you will ever be using panel. So let's not waste time discussing about it. Data frame is the bread and butter of data analyst and data scientist. So that is something which we must understand. So we have seen how to create a series from list. We have seen how to create a data frame from dictionary. We will be talking about much more than this. Okay, so now let's get started. We will talk about this later. Let's understand. CSV stands for comma separated value file. So what does comma separated value file means? Although we can see it, we can open it in Excel. Okay, we can open it in Excel. It's not an Excel file. Excel is an application of Microsoft MS Office, whereas CSV files are pure data files. These are pure data files. So these are nothing but values separated by comma. Okay. Now since we are using Excel to open this file, we can see them in a numbers, rows and rows and columns. But in reality, those are just like separate just a text files. Yeah, and separated by commas, not semicolon. Semicolon is also one of the separator which is used, but generally the commas are used. So suppose if I have my data, it will be like something like this. So name separated by comma, marks. Then Ganesh and marks is 20. Then Rahul, marks is 30. Something like this. So these are pure data files which are stored something like this. If you open it in your notepad, your normal notepad, you will see the structure like this. So now what we will be doing, we will be importing this CSV file in our Pandas data frame, and we will be doing a lot of fun activities around it. So in real life, we don't create our data like this. So this was just to give you example how to convert the dictionary into data frame, or how we can convert a data frame from scratch. That's why we took that example. But in real life, we use a data from external sources. So that external source can be CSV, it can be Excel file, it can be from databases. Okay. So what we generally do, we load our data from our external file, and then we load that CSV in our memory, and then we perform all the data activities around it. So let's understand how to load our CSV into a Pandas data frame. So importing dataset import. How to import the dataset. So we have already imported our Pandas library. So we are going to use our PD. I will just write it one more time. Import Pandas as PD, and we will be using PD dot read CSV. So if I see, after typing read, when I enter tab, when I press tab, I can see all the methods related to read. So we can read many different files using our Pandas in Pandas library. We can export it from different sources. So we can read a CSV file, we can read Excel file, we can read HDF is the another database format. Yes, it's kind of importing the data in our memory, basically loading the data from different formats to a Pandas data frame. Then we can load HTML files. Then if you know what is SQL, you can import SQL data. Then you can import XML files. You can import JSON files. All the different kinds of files you can import in Python. Okay, so I will be using read CSV method, and inside that I need to pass the name of my CSV. So the name of my CSV file is emptycars2.csv. Now, if you have stored your file in some other location and your Python file is in some other location, then you have to give the complete path like this. So this is the complete path of this file where I have stored it. In Windows, you can just copy it from address bar. So I will have to pass it something like this. Okay. So if you are using Windows, it will be something like c/folder1/emptycars.csv. And if your Python file and if your data CSV file is in the same location, then you don't need to pass it the complete part. You can just simply do this. And if you load it, see if it will be loaded something like this. And we will be storing this data. We will be loading this CSV file and storing in something called as cars. Okay, I'm creating a variable called cars and storing my CSV in a Pandas data frame called cars. So cars is my data frame. If I print it, it will be something like this. Repeat the import part. Copy path. If your data is stored on some C drive, okay, so how do you copy the path? Now I don't have Windows, so I can't show you, but here in MacBook, I can copy the path from here. In your Windows, you will be having address bar. So c:/folder1/emptycars.csv. So you need to copy that entire path and then paste it over here. Paste your complete path. You need to paste it in quotes. Convert your slashes to backslashes. This one. Okay. So this is one of the caveat of Pandas. Sometimes use this slash, backward slash. Okay. So always use backward slash, because sometimes Python get confused with some Unicode characters. In some of the Unicode characters are written like this, /n, something like this. So Python get confused sometimes. So always use backward slash. So those who are using Colab, you would be having screen which will look something like this, correct? So now, since you are using Colab, it's a cloud-based IDE. It doesn't have access to your local machine. So first what you need to do, you need to upload your data set to your cloud. So how do you do that? It's a simple mechanism. On the left hand side, see this folder icon. Can you see this folder icon? Click on this folder icon. It will open some window like this. It will open something like this. Okay. On the right hand side, once you click on that, okay, once you click on that, see if you will see something like this. Can you see this window on the right hand side? Everyone? So click on this download button, upload button, choose the file and upload it. So this is the file, I'm uploading it. Now it will take some time. Once the file is uploaded, now you don't need to provide any path, just simply provide the name of the file, it will get uploaded. It will get loaded into the Pandas memory. And now check your code if it is working. It should work 100%. So first of all, now we have seen that data frame is one of the data type we have in Python, in Pandas, which looks like the tabular structure. So if when I loaded my CSV file inside my Pandas data frame, so my cars variable is nothing but my Pandas data frame, and it looks something like this. So here we have this is the index 0, 1, 2, 3. So automatically Pandas assigns some index starting from 0 and up until the however many number of rows you have in your data set. Then all the columns which are part of your CSV file or your Excel file or any file, those are by default read as your first columns. So the first line in your CSV file will always be loaded as your column names. Now let's do some analysis around it. So I will just give the heading as analysis. So first of all, just the way we checked the type of our series, we can check the type of our this cars variable. Sorry, spelling mistake. So now if you see, it's a pandas.core.data frame. Now, if we want to see the top 5 rows, first 5 rows, we have this method called as head. Okay, and it will print, sorry, it's cars. It will print our only first 5 rows. See, it has printed only first 5 rows. So head method prints or returns first 5 rows. Now, what if I want to return first 10 rows? So for that, we simply need to pass the parameter 10 inside this head method. So if you print 10, if you write 10, it will print, it will return 10 rows. If we write 2, it will only return 2 rows. If we write 20, it will return 20 rows. So pass the parameter to return n number of rows, n rows. Now, what if I want to return the last 5 rows? So that's where we have a method called as tail. So tail will return the last 5 rows. By default, it will return the last 5 rows. Yes, head and tail, correct. And similarly, if I want to return last 10 rows, I just need to pass 10 inside this parameter, just like head. Okay, so if I want to 10 last rows, just pass this parameter inside this tail. Now we have seen that how many columns we have. If we want middle rows, there is a slicing and dicing mechanism. We will talk about that in detail. Don't worry, Shan. Okay. So now if I want to understand the shape of this data frame, so what is the meaning of shape? How many number of rows and columns I have inside this data frame? Then we have a function called as shape. Just like our NumPy array, we have this method called as shape. So it tells us the shape of our data frame. So it says we have 32 rows and 13 columns. So always first argument, first value or first parameter is always rows and second is always column. Now, the next method is called info. Next method is info. So inside this info, this method tells us how many non-null values we have in our data set. That is the syntax of this shape method. It doesn't need a parenthesis. Okay, so there are some methods in Python, Pandas, and even in NumPy also, where we do not need to pass the parenthesis. So this is the syntax. It's a property, correct? It's a property. It's not a method, it's a property. So this info method tells us, it gives us some information about our data frame. So what is that information? First of all, it will tell us for each column in our data frame, how many non-null values are present. So what is null value? Null value is a missing value in the data set. So for example, in our data set, if instead of this 6, it was blank, there was no value inside this cylinder column. So now it tells us 32 non-null values, and the shape of our data is 32, 13, means we have 32 rows. That means there is no null value. Correct, Shan? We do not have any null values inside our data set. And along with that, it also tells us what is the data type of that particular column. So just check. Integer is integer. Int64 is similar to our NumPy. Float is similar to our NumPy. But instead of string, for string variables or string data type, Pandas has this data type called object. So in Pandas, object data type is nothing but a string values. In machine learning terminologies, in statistics terminologies, we call them as a categorical variables. So these columns, okay, columns are also known as variables. In statistical or machine learning terminology, we also call them as variables. So this info variables, info method tells us, gives us some information about our data set. Here we have 29 non-null values. So it says there are 3 null values in our QSEC column. So let's check our QSEC column over here. So you see over here, you can see NaN. So in Pandas, NaN means null value. NaN stands for not a number. So thanks, Bhavnik, for noticing that. So NaN stands for not a number, and not a number means a null value. So that's why in this info, we can see there are 29 non-null values and only 3 null values. All right, let's move on. So the Pandas is very important, guys. If you if any topic is not clear, please ask. It is very important. Then we have a function called as mean. Just like in NumPy mean, we have a function called as mean that gives us average values for all the numerical parameters. So see, here we do not have categorical or string data type columns. We only have numerical data type column. So what it will give us, this mean function will give us all the average values for each and every column. Mean for numeric columns. Then similarly, there is a function called as median. There is a method called as median. Central value, middle value. So let's say we have our data like this, 24, 25, 20, 34. So this is our data set. Okay. So how median is calculated? First, the data is sorted in a ascending order. So how we will sort this data? So it will be like 23, 34, 40, 45, 45 and 67. Now this 45 is the middle value, exact middle value. So this is the median. Okay, this is how the median is calculated. When we have even values, when you have odd values, you will get the exact middle values. When you have even values, then you will have two middle values. So the average of two middle values is calculated. So 45 plus 31 divided by 2 will be your median. Don't worry, in your statistics class, this will again will be displayed. Now there is something called as standard deviation, which we have seen. So for that we have this STD method, standard deviation STD method. Now I'm not going to explain what is standard deviation because it will take a lot of time. Okay, so similarly you can get standard deviation for all the numeric columns. Then we have something called as max and min, which will give us maximum and minimum value for each of the numeric variable. And for some reason, it is also giving for the object data type, object variable or object column, maybe based on some, I don't know, alphabetically, but doesn't make sense. So in such case, you have this parameter called as numeric only, but still it is showing. Okay, doesn't matter. Okay, for our previous function, standard deviation, mean and max, see, you're getting this warning. Why this is warning? Because we are passing our entire data set. So this says that some of the values which you are in the data frame, some of the columns in our data frame also non-numeric. So if you pass numeric only is equal to none, or numeric only is equal to true, it will calculate only for the numeric values and it will not throw that warning. Yeah, it's going for alphabetical order. Yeah, but doesn't make sense. Minimum value for alphabetical it is taking, for string or object data type it is taking. So this is how you calculate maximum for all the columns. Similarly, you can calculate the minimum using minimum for minimum. Then we have seen that info method also gives us the non-null values. Okay, but it is also giving us data type along with it. But what if we just want to calculate only the non-null values without any other additional information? So that is where this count method comes into the picture. So this count method gives us non-null values in each column. Prabhu, yes, we will see how to do this for only one column. When we will be doing the slicing and dicing, then we will understand how to do that. Okay, or just wait for 2 minutes. We will do that just in a couple of minutes. Now, these are some of the methods which we have done it one by one. Okay, so we have calculated minimum, maximum, mean, median, standard deviation one by one. We have a function or method called as describe. So this function gives us many summary statistics at one go for all the columns. So see, it gives us count, it gives us mean, standard deviation, minimum, maximum, 50th percentile. This is the median value, 25th percentile and 75th percentile. So there are some additional values it is also giving. What is 25th percentile, 75th percentile? You will understand it in your statistics course. Okay, but summary statistics in once. Now, this is how we calculate the mean, median, everything for all the columns at once, And we have also seen how to calculate individual mean, median, standard deviation for all the columns. So now how to do this for individual columns. So first of all, let's understand how to access the one column in our Pandas data frame. So indexing Pandas data frame. So we use these square brackets. Inside these square brackets, we will write the name of our column. So let's say I'm writing MPG. MPG is my column name. Inside quotes. Do remember this, inside quotes. So name of my data frame, square brackets. Inside the square brackets, I'm writing my name of the column inside quotes. Now, if I run this, I will get my Pandas series. Okay, so we have seen one column is basically a one series. So I can use the same function mean, and it will give me the value average for that particular column. Calculate mean for one column. And similarly, I can do this for all the other columns. And similarly, I can do this for all the other aggregate functions. So instead of mean, I will write std. Okay, this is how I access the column in Pandas data frame. I can do there is another way to access the column using this dot operator. So after dot, Pandas data frame dot, then I write my column name MPG without quotes. When we are accessing columns with dot operator, we don't use quotes. When we are accessing column name with square brackets, we have to pass it as a inside quotes. So this is how I can access it. Now I will write dot mean and it will calculate the mean. So another way to access the column. Okay, now coming to the next part, which is cleaning of the data. Let me give the header. Cleaning of our data set. So we may need to do a lot of cleaning. 80% of our job as a data scientist or data analyst will go into the data cleaning. So our data set would not be perfect. It would be having a lot of missing values, some irrelevant values, some column names might be different. So let's see. First of all, we have this property called columns to get the names of the columns. So this columns property of our data frame, this columns property gives us the names of all the columns. Okay, so we don't need to open our data frame, complete data frame every time to understand the column names. So one of the issues with our data could be the improper name of our column. So see, the name of this column is unnamed one. So let's understand what is this column dot head. So this unnamed looks like this is the name of the model of that car. So this cars data set has empty cars data set is the data of different cars. Okay, and it has given different types of information for each of the car. So we have this Mazda car. It has given this is MPG, which is miles per gallon, which is the mileage of this car. Then how many cylinders it has, what is the displacement, what is the horsepower, and similarly, what is the weight of the car. And this kind of information we have in this table or in this data frame. So if you see this name, this model column doesn't have proper name. So we can rename this column with a proper name using a rename method. How do we call our rename method? we write cars dot rename. Inside we pass this parameter columns is equal to, and inside this column we pass the value as our dictionary, where the key is the column which we need to replace inside the quotes, and the value is the new column name which we want to give. So what is the new column name that we want to give? Model. So if I run this, see, my model name has changed. Column name of my unnamed has changed to model. Now it has not assigned to the original data. It has just printed. So now we need to assign this newly created column, renamed column to my original data cars. So if I do this now, my column name has renamed to my original column. Now if I print this, I will be having this cars as a new updated data frame, which is with the new value. Now another challenge with the data could be the data might be having a lot of missing values. So we have seen that using count function, we had seen that there were some missing values. So this is one method. Okay, this is one method of assigning the variable to assigning the changes to our original data frame. There is, okay, so there is one more method without even assigning. If you don't want to do like this, okay, so if I don't want to assign it to my original variable, there is one more method, one more way where you can copy like this, where you can rename, and there is a parameter called in place, where you are write in place is equal to true. So what it will do, it will rename the column and assign to this cars variable by default. So we don't need to separately write it like this. We don't need to separately assign cars is equal to something like this. Okay, so both of them are exactly the same thing. I'm just commenting the in place is equal to true method. So if I run this again, it will throw error because we do not have unnamed column right now. We just have, because we have already replaced it. Okay, so another challenge with our data is that our data might be having missing values. So, okay, I will scroll it up. See this one, okay, inside the comment. There is a space between colon and 1. So that's the reason your column is not changing. Inside your renaming function, you have given without space. That's the reason copy it from here. Yes, we must ensure that the exact same name should be given, otherwise it will throw an error. This will not work if you have already ran the code, this one, because we have already renamed our column. Correct. So there is no column called unnamed word now. We have our model. Yeah. So that's the reason it will not work. So you should run either this or this, or if you want to try this one, then reload the data set and then try it. Run this command once again. Okay, this one pd.read csv, and then it will work. Okay, moving on. So we were talking about our data can have a lot of missing values. So for example, we had seen that QSEC column had some missing values or null values. We call them NaN. Where is QSEC? Yeah, here is one NaN, here is one NaN. So we can't keep them as it is. We must treat them. Okay, it's called missing values treatment, treating the missing values. So there are many ways we can treat the missing values or NaN values. Some people might, put them as a 0, considering it as its default value. Or some people might put them as some other values. So for example, instead of if we had age data set, the age of adult people. So if we had missing values, then by default, we would have put age as 18 because we know it's the data for adult people. It's not for minors. So we can replace those missing values with any type of values. One of the one of the method to replace the missing values is to use the average of that column. So now here inside this QSEC column, we have some missing values. So if I take count, then we know there are only 29 values. So there are 3 missing values. So what we can do is we can calculate the mean of this column, which is 17.6. So I am just storing this mean in another variable called QSEC mean. Now we can use this QSEC mean to fill the values of our QSEC variable, QSEC column. So how do we do that? We use cars. Inside this bracket, we can write our column QSEC because that's what we are going to replace. Okay, is equal to cars bracket QSEC dot fill NA. There is a method called as fill NA. So what we are saying, inside this column QSEC, fill the NAs with this QSEC mean. So inside this fill NA function, you need to pass the values that you need to fill for those missing values or for those NaN values. So if I had to pass some default value 20, I would have passed 20. If I wanted to pass 0, I would have passed 0. But now I want to use this QSEC mean, which we have calculated, which is nothing but the average of this QSEC column. So I will be passing this QSEC mean. So now my QSEC mean is filled with NaN. Now if I count the cars dot count, see, it is for QSEC, it is saying 32. So there are no missing values. Yes, so fill NA is to fill the missing values inside a particular column, or it can fill NA method for filling the NA values slash NaN values or missing values. If you put 0, then instead of filling QSEC, so see, I will tell you. So where did we have those missing values? Somewhere over here. Okay. On 17th row, we had our missing values. So now if I print cars on 17th column, what is 17th row? What is the value that we have filled? 17.67. So if we had used 0, then this, instead of this 17.67, the value would be 0. All the places where we had the missing values. There is a logic behind that, because we take the taking the average values gives us some logical explanation. Instead of filling it with any random value, we are using the mean, which is basically the average of that particular column. Okay, moving on. So now if you have noticed, we have this column called serial number, which is not useful actually. It is just an index position of the number. It was there inside our data frame, so that's why it got loaded. So what if we want to drop it from our data frame? Drop the column. So that's where there is a function or method called as drop. So cars is equal to cars dot drop, and inside that you need to pass the columns. Is equal to inside list passed the name of the column. The name of the column is serial number s.num. So make sure the spelling is exactly the same. Now why we are passing it in a list? Because we can pass multiple columns to be dropped. So if I wanted to specify 4 columns to be dropped, I would have just passed it with the comma separated, and all those columns would have been dropped. So if I print it now, my new data frame is updated without the serial number column. There is no data. Once you drop it, there is no way to get it back. Okay. You will have to reload the data once again. So once you delete it, you delete it. Now next is related to correlation. Now you haven't understood the correlation because I don't know whether your statistics class is completed, but if you haven't, don't worry about it. So in NumPy also we had seen correlation. Yeah, don't worry about it. In your statistics class, it will get covered. I am just showing you how to calculate the correlation. Okay, so correlation is one of the statistical metric where we use to test whether two variables or two columns are related to each other or not. Okay, that's where we use correlation. Okay, so to do that, we have a function called as CORR. Don't worry if you don't understand what is correlation as of now. I will just show you how to calculate it. When you will have your statistics class, you will understand it. Okay. Okay. So first of all, now the correlation is one of the metric which only works on the numeric data. Okay. But in our data set, we also have some categorical or string variables or object variables. So what we will do, we will first slice our data for only numeric variables. So I will create another data called df is equal to how to slice the data. Now let's understand. So when I want to create a new data from my from my existing data frame. So basically I want to create a new data frame by selecting some selective columns from my existing data frame. So I have these columns in my data frame, but I don't want this model. I want all the other columns except this model. So I will just write this inside this list. So just remember, when you want to create a new data frame from existing data frame, you pass the columns inside the list. So 2 square brackets. Okay, 2 square brackets. So now if I print this data frame, see, I have this data frame, new data frame called df without my model column. Now why 2 brackets? Because 2 brackets indicates that you are creating a new data frame. When you specify only 1 bracket, that means you are creating a series and it will accept only 1 column at a time. See, like this mpg, it will take only 1 column and it will print the series. If I specify 2 columns, it will throw an error. Okay, it will throw an error. So if you are passing more than 1 column to slice your data frame, make sure to pass it in a 2 square brackets. Okay, I will just mention it in here. So the 2 square brackets for slicing data frame for more than 1 column. Now that we have sliced our data frame, we have created a data frame df with only numeric columns. Now we can calculate the correlation. So to calculate the correlation, there is a function called as CORR. So this CORR function calculates the correlation matrix. So correlation value lies between -1 and +1. Now we have seen how to do typecasting in NumPy, in list, and all the other parameters. So here cars is our data frame, and we have sliced our data frame by specifying the selective columns. If it is more close to 1, it is more relative. So basically, when it is closer to 1 correlation, that means the 2 variables are highly correlated with each other. When it is close to 0, that means there is no correlation. When it's close to -1, there is a negative correlation. Okay. So I will just give you a simple example. Okay. Just because many of you are interested. So consider the example of advertisement expenditure and the sales. So one company, okay, they have spent lot of money on advertisements for each month, and then they have recorded how much sales they generated for every month last year. So they understood that, they found the correlation which is around 0.9. So what this indicates, more money you spend on advertisement, more the sales will be generated. So that is called as a positive correlation. Yes, more significant. There is a negative correlation, which means when one parameter increases, other decreases. For example, price of the petrol and sales of cars. So we know that when the price of petrol increases, there is a significant decrease in sales of cars, which means when price increases, sales of the cars decreases, and when price decreases, sales of the cars increases. So in such cases, the correlation value would be close to -1, like 0.9, 0.7. So the value in this case would be close to -1. And when the value is close to 0, that means the two variables or two columns are not correlated at all. Okay, that's the high level explanation I can give in 2 minutes. It's a very good topic, interesting topic. You will understand it, okay, when you will talk about. Okay, now we will understand how to do data manipulation in Pandas. Okay, Pandas data frame. So sometimes we don't need the whole data set. Just like now, for calculating the correlation, we just needed some columns. Okay, we didn't need all the columns. So that is one of the use of data manipulation and indexing. So we have seen how to do data indexing using actual column names. How we can do the data indexing using the index position of the column names. So we will understand that. Okay. So indexing by position. Okay. Indexing by position. So we have seen, if I want to access, let me just type head of our data over here so that we will have access to our columns. So now suppose if I needed my first column model, then I can simply write like this, cars and inside bracket model. This is the one way of doing the indexing. Or if I needed my third column cylinder, so I will simply write SYL and I can access the column cyl. But what if I want to access this cylinder column, okay, by position? So that is where I have a method called as ilog. .ilog. So ilog stands for, I stands for indexing, LOC stands for location. So .ilog says index position, slice the data using index location. So how do we do that? Inside this, in NumPy, we have seen this colon parameter. Before this colon, we indicate rows. After this colon, we indicate columns. Just like in NumPy, we slice our data for Pandas data frame also like this. So suppose I want this cylinder column. So which means I want all the rows. So I won't specify anything inside this before my colon because I want all the rows. But I want this cylinder column. So index position always starts from 0. We know that. In Python, index position always starts from 0. So 0, 1 and 2. So if I pass 2, I will get my cylinder column. Okay. So cars.ilog, before colon, it is the position of rows. No, we have specified 2. So it will take only 2. Only one column. So if I want 1 and 2, okay, so what I will do after this comma, I will simply write 1:2. Sorry, and we have seen, okay, we have also seen that when we specify the range, okay, it doesn't take the last value. So if I want MPG and cylinder, which is my first and second index, I will have to pass it till 3. Okay, then I will get my first and second index. Because now we have access two columns, correct? So two columns means it's a data frame. When we were accessing only one column, okay, like this, then it was index. So index doesn't have, sorry, series. Yes, it was series. So series, we don't get header, we get the name of that series at the end. So here, this display is the series name. Okay. So when we specify more than one column, it will take the headers because it converts it into a data frame. So this is for accessing only one column. If I wanted to access more than one column, I will pass the range inside my column columns value. So after comma, before comma, it's for the rows. After commas, it's for the columns. So I will write 1 colon 3. It will give me first and second index. Correct. In NumPy, we have seen if I want to access my first and second index position, I will pass the first position, starting position, which is first index, and ending position, which is 3. So when we put range, it doesn't take the third column, it takes up until the n minus 1. So n minus 1, 3 minus 1 is 2. So that's why it will take first and second index, which is my MPG and cylinder. Now, what if I want to access only the first 3 rows, only the first 3 rows from my third column, which is my cylinder column. So inside this, before comma, this is for before comma, it is everything for rows. So I will write from 0 to 5. I need this 0 to 3. I need 3 rows, 0 to 3 from my cylinder column. So I will get 3 rows for my cylinder column. Slicing the n rows and nth column. Similar way, if I want first 3 rows from 2 columns, I will write like this. Indexing starts from 0. So that's the reason it takes like this. And if I want third row, 3 rows from my first and second index column, which is my MPG and cylinder, sorry, I will have to pass it 3. So I will pass like this. So this is how you can slice and dice the data frame using index position. So, almost similar to a NumPy, okay, but with added advantage. Very similar. So that's the reason if you understand NumPy, understanding pandas is a piece of chocolate. Okay, it's like you don't have to put any additional efforts. It comes to you as a naturally. Pick up these index positions: first index, second index, fifth index, and 31st index. So when we pass it like this, we are passing the range from starting and ending position. Here in this case, you are passing, yes. So good. This is also a good point to explain. So here, instead of, if you wanted a particular number of indexes and particular number of rows, you can pass it like this. So essentially, when you pass like this also creates a list only. Range function. So range function creates a list from 0 to 3. So this is another way to pass it. You can pass it in a list, that how many rows you want, which rows you want, which columns you want, and it will give you the exact same. Yes.
Let's have a quick quiz question, guys. And the question is, which of the following techniques is used to impute missing values in a data set? And your options are regression analysis, principal component analysis, k-means clustering, or data binning. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have help thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
So iLog property is used to do the indexing with the location, index location. So doing the indexing by using the index of our columns. So these are the indexes of our columns, and also using the indexes of our rows. So we can slice and dice our data frame using our index values. So we can also do this slicing and dicing. We can also do this indexing of our data using the labels. So what do we mean by labels? Labels are the names of our columns. So in our data set, which is cars, which we have created, the data frame that we have created is our cars. So if I print the columns, these are all our column names, or also known as the labels. Okay, we call it as a label, or we can call it as a column name. So we can also do the slicing of our data set, or take the subset of our data set with the help of our column names. So we have already seen how to do that without any method. So one way to do is, let's say, suppose if I want to take this model column, okay, out of my data, so I can just simply use this square brackets and say model. So I will have my data extracted as a series, because I am extracting only one column. So if I want to extract multiple columns, if I want to extract the subset or with multiple columns, I need to pass it as a double bracket, or I need to pass it as a list. So suppose I want to extract MPG and model, I can do this. So it will extract two columns. So there is one more way to do this, okay, with the help of method, or with the help of a property called LOC. Okay, so just like iLock, we have property called lock. Okay, lock stands for location. So there is no I here because we are not using indexing, we are using labels. So how do I use iLock? Good way is same indexing. The indexing technique is same as our iLock or NumPy one. So this is how we use our indexing. So suppose if I want to extract all the rows, so I would put colon just, which indicates all the rows, and I want to extract only model column. Okay, so what I will do, I will specify my model as a column name, and I will just comment this particular part so that will be understood clear. So see, when I write the column name as a part of my index, instead as a part of my column value, instead of passing the index, I can still get my data extracted for my particular variable or particular column model. So this is called as indexing by label. Now, what if I want to extract more than one column? Okay, what if I want to extract more than one column? So we can use a range. We can even use a range. So for example, let me print the data head of our data so that it will be little better to understand. So model is my first column, MPG is my second column, cylinder is my third column. So what if I want to extract from model to displacement? These four columns I want to extract. So when I wanted to do this, with the help of indexing, I would have simply written like this. With the help of indexing, I would have written from 0 to till 4. So with the help of this particular method, from 0 to 4, I would have extracted model, MPG, cylinder, and display. Let's print it. Why it is not working? Oh, sorry, iLock. So I would have done it like this because I was using indexing position. So I can extract from model to displacement. So with the help of lock function, and when we want to extract these four columns by label and not by index, we can pass the index. Okay, we can pass the range of my label just like we pass the range of my index. Let me show you how. So we want to extract from model till displacement, DISP. So see what I said, from model till displacement, and it will understand and it will identify all the columns. So if I also wanted HP column, I would just replace it with HP and I would get my HP column also as a part of my subset. So this is indexing by label for range of column labels. Okay, for the range. Okay, instead of passing one columns, we can pass the range. Now, what if I want to I don't want to extract the columns in a sequential order. I want model, I want cylinder, and I want HP. I don't want MPG and displacement. These two columns I don't want. So we can pass that as a list. Okay, we can pass that as a list like this. So instead of passing it as a range, we can convert this to a list like this, just the way we did it using indexing. So what I want model, then I want cylinder and HP. So I will just add a cylinder column over here, and see, I can get only the specific columns required for my location function, for my subset. So this is also possible. You can specify a list of labels for indexing. Now, we also have this first parameter for rows. So here we can specify if we want to extract first 10 rows or last 10 rows or middle rows. How can we do that? We can specify how many number of rows from which location to which location we want. So suppose if I wanted from fifth row onwards, okay, I don't want this first 5 rows. I want this from index 5 and above. So for, let's say, only for these 3 columns. So I can specify from 5th position onwards, get all the columns. So see, from 5th position onwards, we have received all the columns. If I wanted, from 5th till 10th row, the middle 5 rows from 5th index to 10th index, 9th index, basically. So it will give me from 5th index to 10th index. So it is also giving me the 10th index. Why do lock instead of iLock? Lock is used when we want to index the columns using labels. Yes, LOC is equal to column name, iLock is equal to index. That is correct. Okay, Shilpa, are you getting it? So see, when we were using iLock, instead of specifying the column names, we were specifying the index positions like 0, 1, 2, 3 like this. But here we are using lock and we have to specify the column names rather than index position. So that is the difference between lock and iLock. So I in iLock stands for index, location stands. Why to do this? It's a way to extract the data set. So if you want to use column names, labels to extract, are you going to remember the position of your columns? Okay, so for example, you have 100 columns in your data set and you do not know the serial number of all the columns. You do not know the index positions of all the columns. So okay, so that's when by name, exactly. So that's when you can use lock function. So in lock position inside the rows, okay, it is also taking the last position. So these are some of the things which we need to observe and learn. Okay, these are some of the things which we need to observe and learn. So this is one of the slicing and dicing mechanism which we can do. So simple, iLock is used when you want to do the indexing using index values, and lock function or lock method is used when you want to do the indexing with the help of labels or column names. Okay, I will explain you why lock function takes this 10th row also, because we are not actually doing it for the index values. So indexing starts with 0. Okay, in Python, indexing starts with 0. But in this lock function, LOC function, it is not taking the index. It is taking the label of our index. So this is index, but still it is taking it as a label. It is not taking it as an index, as a numeric value. So this index need not be only numbers. It can also be a alphabet. I will show you how. So let me create one small data set, which is cars. Okay. I will call it as a dummy data set, which is basically just taking the head of 10 rows of my cars data set. Okay. So if I print it, if I print my dummy, see, only 10 records have been extracted. Now what I will do, I will change the index from these numbers to some alphabetical values, characters, okay, like ABCD. So how to do that? You can change the index numbers. You can change the index using method called as index or property. This is again a property. So we have 10 records. So I will give some 10 values as a character. So let's say A, B, C, D, E, F, G, H. How many? 1, 2, 3, 4, 5, 6, 7, 8. I, J. 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now what we have done, we are changing the indexing of our this dummy data set, which is just a 10 records from our original data set. So if I print it, see, it has changed the index from 0, 1, 2, 3 to A, B, C, D, E, F, G. So indexing could be anything. You can even change your column name to the index. That is also possible. You just have to simply give the name of your column, okay, as a part of your index. That is also possible. So location function or lock function does not take index. It takes as a label. So here, if we pass label as A to D and column name as from model till displacement. Okay, name A is not defined. It has to be provided in a quotes. Otherwise, it will be throwing error. So see here, we are passing it as a location. It's not index. We are passing it as a labels for our index or label for our rows. And this is our labels for our columns. So index is nothing but a label for our row. So that is the reason when we are using location function, it also takes from first till last because it's a label. It's not index. Indexing starts from 0. Similarly, when we are passing the column names, it is taking first and last column, including the middle ones. So that is the difference between lock and iLock. In lock function, it takes all the rows and columns which you are passing it as a parameters in your method. Okay, getting it? So indexing. So this is changing this is how you can change the index of data frame, and this is the example of slicing the data with labels or row labels. All right. So let's move on to the next concept. So how now if I want to create a new column, so we have in this data set, let's say, let me print our data cars.head. So this is our data set. Suppose if I want to create a new column, okay, I want to create a new column called let's say, what can we create? Or let's do one thing. This in this data set, we have this AM column. And now I don't know what this AM column refers to, but let's say in this AM column, if I print my all the AM, all the records, see, there are some ones, there are some zeros, and there are some ones and zeros. So we have ones and zero values in this our AM record. So what if I want to change the value for the entire column? So I can simply use the indexing using labels without any function also. It is what is possible like this. So what I'm doing, I am selecting a particular record and I'm assigning a value 1. So what it will do, this is just for the example. There is no logical explanation why we are giving one value. We are just for understanding how to assign a new value to the entire column. So if I do like this, it will assign value 1 to my entire column of AM. So if I rerun this data frame, see, all the values for AM got converted to ones. Okay, everything is 1 now. Earlier it was ones and zeros for some other columns. So this is how I can assign value to the existing variable. I can even create a new column in my data frame with the same method. So suppose I don't have any column name BM. Now I don't know what is BM, but just for the example, I'm creating a column called BM, or let's say color. Okay, I'm creating a column called color. So by default, I'm giving color as black to all the cars. So if I run this code and print my cars, see, one more column called color would have been created inside my existing data frames with the default value as black. So this is how we can create new columns. Like the way we create a new key inside our dictionary, similarly, we can create a new column inside our data frame. So creating a new column in a data frame. Now, for creating a new column, do not ever use iloc or lock, because it will not understand what is this column. Lock and iloc is used for indexing, so it won't understand what is the color if it was not already available. So for creating new columns, always use square brackets, the syntax which we use like a dictionary. Like how to add more than one column? So you can keep on adding, one after another. You can also create more than one columns inside this double square brackets. So for example, I want to create ABC and XYZ, these two columns. And here I can pass the values, but I'm not sure how the values will be passed. Let's say 0. Okay, both the values I'm passing at a 0 in the beginning. And if I print it, see, two more columns have been created with the default value as 0. Well, later on, we can change the values based on some condition. We will understand how to do that based on some filtering. Okay, so we will understand that in a minute. Okay, so this is how we can create a new column. Now we have seen a map function, okay, and lambda function in our Python basics class. Okay, so what if we want different value? You want different value, you create separately, or you can assign it like this: 0, 1. Okay, so see the 0. So you need to pass it by comma separated. Okay, so now if we pass it by comma separated, 0 will be assigned to ABC, 1 will be assigned to XYZ. So if I run this, see, ABC have zeros, XYZ has 1. Okay, you can pass any value. All right, so we'll update to work here. Okay, let's check if it has update function. Yes, it has update function. You can create using update also. Let's say TUV is equal to 1. Let's see if it is working. Nope, it is not working. Update will work only to update the values for your existing columns. So update is not working like this. All right. So we have talked about lambda functions. We have understood lambda functions when we were discussing our Python functions. Okay. So let's create one Python lambda function called fun1, and we know how to create lambda function. Lambda x, which is a parameter it will take, and after colon it is an expression. So x multiplied by 2. This is one lambda function. Okay, we can have any lambda function. We can create a square, or we can create a cube, we can create square root, any lambda function. This is just for the example. So what this lambda function does, it takes value and it is multiplying that value by 2. Now, how to apply any function, whether it's a lambda function or whether it's a normal method, a normal function, how to apply that to a pandas data frame, or to be specific, pandas columns. So let me just print the head so that it will be easier to read. So suppose if I wanted to apply this function fun1, now we know when we want to apply this function to any list, what we will do, we will just call that function, we will just use map function, map, and we will pass our list and function inside this map function, and it will that list will get updated. So suppose if I have my list 4, 5, 6, 7, this is my list L. And if I wanted to apply this lambda function on this list, what I will do, I will pass fun1 and I will pass my list L. So it will apply to that function. If I convert it back to the list, it will apply to that list. It will apply that function to that list and it will give me the output. It will give me another list with the updated output. So it is a multiplying this list with our value 2. So this is how we do for a list. So similarly, how do I update? How do I, okay, I will keep it as it is over here just for the reference. So how do I apply my function, okay, to a pandas column? So that is where there is a function called as apply. Okay. So apply function works very similar to the map function on pandas data frame. So for example, this am variable that we have created or we assigned value as 1, if I wanted to multiply this entire column, or if I wanted to apply this lambda function fun1 on this entire column am, let's see how we can do that. So first of all, I will index that function, index that column, so which is the column I want to apply on, am dot apply. So apply is the function which takes the parameter as our function which we want to apply on our column. So fun1 is the function that we want to apply. If I run this, see all the values, it will return as a series. The output will be returned as a series, and all the values now are 2 because we are multiplying it with 2. That lambda function is multiplied by 2. And again, we can store it back into the same column. We can reassign the value to the same column, or maybe if you want to create another column am2, which is basically multiplied by 2, then also we can do that. So for simplicity, I am just reassigning it to the same function. So if I rerun my cars.head, see this am, why it did not, okay, sorry. We are multiplying it over here. We are assigning 1 over here. That's the reason it get. Let's print our cars.head over here once again. And see, now the am column has value 2 because we have applied our fun1 function which multiplies it by 2. So this is how you can apply function. Okay. So now you might have user defined functions like your normal function, which you define using def keyword. So this function will work. This apply function will also work exactly the same manner. Okay. And it will give you the output like that. There are some inbuilt functions in Python. Those functions can also be applied on this particular variable. Now this is how we can use apply function. Similar way, map function also works in the similar way. Okay, map function also works in the similar way. So instead of using apply, suppose if I use map, let's see what happens. And let's say I'm creating another function fun2 called another lambda function called fun2, where I will create the square of our variable. So, and I will assign it to another column called am2. So now let's print the cars.head and see how it works. So see, am2 has created the square of our am. So am is already multiplied by 2, and for on top of it we are taking the square of it. Where is am? It's fun2, correct. Yeah, right. Yes. So now this value is so big because we have multiplied it at so many times. Okay, so say the same function got multiplied so many times, so this is why it is so big. Okay, more you run it, more it will get bigger and bigger. Okay, but this is how you can use uh, apply and map function. So map and apply works more or less the same way. The next topic is sorting. Okay, in Excel we have functions called as sorting, and I believe you guys have completed your SQL. Okay, so that most of the concept which you have studied as a part of your SQL, many of the concepts would come in handy in our pandas also. So in SQL you have order by function to last command not clear. Which one? This one, Kirti. So similar to apply, okay, the way we use apply function, the map function is also similar way works. Okay, so we have map function, we have seen how map function works in list. So the way apply function works, map function also works in the same way. So just to show you how it is, how map and apply are similar, I created one more function called as fun2, which is taking the square of our x, and I applied it on our series or column AM, and I created another column AM2 and assigned the values. All right. So in your SQL, you have order by function to sort your tables. Okay. Similar way, what if we want to sort our data set, this cars data frame, okay, with by any particular column. Okay, so that's where we have a function called as sort value. Now see, all the data is random. Okay, inside this data frame, cars data frame, this data is random. So what if I wanted to sort my data, also I wanted to sort my data frame by horsepower? So the cars with smallest horsepower, the least horsepower would be at the beginning of the data, and the cars with the highest horsepower will be at the end of the data frame. So for that we have a function called as sort values. Okay, please mind sort values and not sort index. Okay, so sort values function sorts our data frame by the value that we will be passing. So inside that there is a parameter called by, and this by parameter we have to pass on which column we want to sort this value. So I wanted to sort this based on my horsepower column. So if I run this, see, the data frame is sorted. Now the smaller the cars with smaller horsepowers are at the beginning, and the cars with the higher horsepowers are at the end. So this is for sorting the data frame in ascending order. Yes, default is ascending. By default, it takes ascending order. Now, what if I want to sort this by descending order? So I am copying this and I'm pasting it again. So again, you can create a new data frame to store this sorted data frame like this, cars 2, like this, cars 2, and you can assign the value to the new data frame. That is also possible. And you can have this new data frame, and on top of it we can do the task. Okay, so I'm not storing it, I'm just showing you how to do that. Now what if I want to sort my data using in a descending order? So for that I have a parameter called as ascending. Okay, so in your Jupyter notebook, even if you press ASC and press tab, the complete spelling will be populated automatically. So this ascending parameter, I have to set it to false. So ascending is equal to false. That means we want to sort it in a descending order. So it will sort my data frame in a descending order. So see, HP, the first rows are with the highest horsepower, and the last rows would be with the lowest horsepower. So this is how you can sort the data frame by descending order. Now, what if you want to sort it based on multiple columns? Okay, so first you want to sort by cylinders, and then you want to sort by horsepower. Okay, so we can sort by multiple columns also. In Excel also you can sort it by multiple column. In SQL also you can sort it by multiple column. So there you just need to pass the names of the columns inside this list in this by parameter, by argument. So let's say first I want to by cylinder and then HP. It will sort first by cylinder. So basically all the cylinders with the highest order, because we are sorting it in a descending order. First it will sort on this cylinder, and then once all the so the first priority will be given to the cylinder, and then second priority will be given to the HP. So this is how you can sort your data by multiple columns. Ascending, descending, it's the same. Syntax is more or less same. Just you need to set this ascending is equal to false parameter, and it will be sorted in a descending order. So sort by index will sort your data using index. So now if you see after, so our original data was already sorted in a using index. So if I print sort, if I print cars, see our data is already printed in a sorted. So for example, I will create another data frame called cars2, which will be sorted based on the cylinder and HP in a descending order. So if I print my cars2, see my index position is now. So if I want to, so if my now this cars data frame, the index position is now not in the serial order. Okay, not in the serial order, it is jumbled up. So if I by ascending, by default it is ascending. Cars dot sort index. Okay, if I use this sort index method, see the data frame will now be sorted using the index values. So suppose now I have sorted my cylinder, sorted my data frame using cylinder and HP column in a descending order. If I sort it back using index position like I was doing earlier, so I will just give sorting using index. So now my data frame is sorted using cylinder and HP, but my index position is jumbled up. So what if I want to ensure that my index position is also in a correct sequence, but I don't want to mess up with my cylinders and HP. So that is where we have, function called as reset underscore index. It's a property called as, it's a method called as reset underscore index. So what this function reset underscore index will do, it will reset the index of our data frame without doing any harm to our original data set. So notice our cylinder and HP values before doing the reset index. 8, it starts with 8, HP starts with 335. So I will do the resetting of the index. Now my cylinder and HP values are exactly the same, meaning my data frame is unharmed, but my index position is changed. So now what happens when you reset the index, the values which were part of your index, okay, those values will be converted to a new column called index, and it will become a new column of your index as a part of your data frame. Okay. Resetting the index creates a new column called index. Okay. So, but what if I don't want these index columns? Because this is useless. I don't want this column. So there you have a parameter inside this reset index function. Okay. Called drop is equal to true. So when you specify drop is equal to true inside this reset and index method, it will not create that index column. Okay, so see, if I am specifying it, it has not created that index column. It has resetted the index. Okay, so drop is equal to true will not create new column. When I don't pass this drop is equal to true, if I do the resetting of my index, the original See, notice over here. So this is my data frame when I was sorting using cylinder and HP. Now, when I sorted, my index position got jumbled up. So it starts from 30, 28, any middle values. So to rectify that, to correct this index position, I use reset underscore index function. So when I use this reset underscore index function, what happens? It resets the index, but the previous index, which was this 30, 28, these index values are converted to the column of new column in my existing data frame. So this index column is getting created in my existing data frame. So if I don't want these index columns to be created after resetting the index, okay, because this index column is of no use. Okay, this is just a index value getting converted to a new column. So that is where I have this parameter called drop is equal to true. So if I pass this and if I run this, now that new column called index is not here. Okay, got it. Perfect. All right. So next concept is filtering. How to filter our data frame. So, so syntax is very simple for filtering. So suppose I want to filter this data frame. Okay, cars. I will print the head of cars over here once again. If I want to filter the data on this cylinder column, so basically the car, I want to select only the cars which have cylinders greater than or equal to 6, or let's say just greater than 6. I want to filter only those cars who have cylinders greater than 6. So how do I create a filter? So let's say I'm creating a variable called filter 1. Okay, so before even creating the variable, what I want to do, I want to filter it based on the cylinder. So I will first of all select my column called cylinder, cars of cylinder. This is the way I select my column. Now, what is the condition that I want to put? I want to select cars which are greater than 6. So I will write greater than 6. Now, if I run this, see, it checks for each value inside our data frame for this particular column, and it checks the condition whether that value, whether individual value is greater than 6 or not. So if it is greater than 6, it will return true. In this case, in the fourth index, the value is greater than 6, it's 8. So it has returned true. If it is not satisfying this criteria, it is not greater than 6, then it will return false. So this is how this filtering works. It gives us true and false values because we are using this conditional statement to check whether that condition is satisfying or not. So how to apply this condition, how to apply this filter on our data frame? So simple way is either you can store this filter in a new variable called filter 1. Let's say I'm creating this filter 1 variable, which is basically checking for this condition whether my cylinders are greater than 6 or not. Now, how do I apply this filter on my data frame? I will select my data frame cars. Inside that, I will simply write this filter 1 because we have already created this filter 1. So if I write this, it will filter my entire data, okay, based on my condition. So see, this entire data set is filtered only for cylinders with 8 cylinders, all the cars with 8 cylinders. So we don't need to create this filter, and we don't even need to store the values of this filter inside the variable filter 1. We can straight away filter our data set and we can write our filter inside the square brackets directly like this. So cars of cylinder greater than 6. So it will also work with the same way. So here what we did, we stored this filter inside our one variable filter 1 and then use that filter inside our indexing. Okay. So this is also again part of indexing, but using a filter. We are indexing based on some filters. So it is taking the it is taking this condition and it is filtering our data set based on that condition. So we can now create a new data frame called, let's say, new df, and we can store the data of new df, let's say cylinder greater than 6. Okay, such a big name. Okay, cylinder greater 6. So this is a new data frame which will have cars with cylinders more than 6. This is how we use filtering. Can we filter between the two values on cylinder? Yes, we can. So yes. No, so there is no between keyword in Python, but we can use our and or operators, okay, to use the values on two filters. So for example, I want to filter my data. That was actually our second topic, next topic. Okay, I will come to that in just a minute. But before that, just let me know if you have understood this particular concept, the filtering with just one value. What if I want to filter it on two values? So for example, I want to filter. So let me just give the heading over here, that filter based on one column. Now, what if I want to filter it based on two values on the same column or two columns? Okay, we will take both the examples. So I'm copying this and I'm pasting it in a next cell. So let's say I want to filter. Before that, let's see what are the cylinders values. So we have 4, 6, and 4, 6, and 8. So let's say I want to select the cylinders which are greater than 4 but less than 8. Okay, between. So I have my AND operator where for greater than 4. So this is my one condition. And my second condition is cars cylinder less than 8. But make sure when you write more than one condition using AND operator, each and every condition, each and every filter should be inside this round brackets. Otherwise, it will give you one error called as truth values confusion, something like that, ambiguity. So see, now all the entire data frame has been filtered based on these two conditions. So only 6 cylinders we have, greater than 4 and less than 8. Yeah. So okay, Shilpa, Menaz, I will answer your question. Okay, how to we can't initialize while creating the column, but we can change the values based on some conditions. So we will look at that. So now this here in this case, we use only one column, but more than one conditions. So similar way we can use to put the filter on more than one columns as well. Okay, so I'm just copying this. Okay, so I wanted to put filter on two conditions, which is I wanted to filter which is greater than 6, cylinders having greater than 6, and horsepower greater than let's say 200, horsepower greater than 200. So I will get the data based on this condition. So we can filter based on multiple columns also, like this. Now, so see, with this particular method, okay, when we filter our data set, it gets filtered on the entire data frame. Now from this data frame, what if I want to select a particular column? So for example, this variable that we created XYZ. Now I want to change the XYZ value, or let's say color value. Okay, I want to change the color value. So we initialize this color column with black initially. So by some logic, I know that the cars having cylinders, the cars with cylinders is equal to 4 are black color. The cars with cylinders is equal to 6 are red color, and cars with cylinders is equal to 8 are white color. Okay, this is the condition I want to apply. and I want to change the values of my column color. So how will I do this? So first of all, I have my color column already created, so I will not create it once again. So cars, I will put a filter that cars of cylinder greater than, or sorry, is equal to 4. Those are black, not like this. So see, if I do this, it will filter out the data for all the entire data frame. Now what I want, I just want my color column. So this is nothing but a data frame. If I store it in a new data set called cars2, it will get stored, the filter data set will get stored. So I can select my cars column, cars2, from this cars2 data frame, I can select my color column and assign the value white. This is how it will work. But this will only apply for this cars2 data frame, which is selected data frame. So this is just to give you example that how it will work. Okay. So we don't need to create this separate variable. We can combine these both commands like Shilpa is asking. So this will print the entire data frame. This will return the entire data frame. We just want our column color. So this will select color column, and this will just select the color column. So I will assign the value to this colored column as black, which is already black. Now, same I will copy this 2 times because I know the conditions. So the cylinders with value 6, I want to assign color as a white, and cylinders with value as 8, I want to assign the color as red. So if I do this, the values, these are some warnings. Okay, you can neglect them. And if I print my cars now, if I print the data frame cars, see, okay, we haven't assigned it to assign, but we did. Why is it not reflecting? Okay, it is. So see, this is asking us to use, this is asking us to use lock function. No, this, it's not because of that Vaibhav. Okay, it is asking us to use this lock method. So I think this is with the updates from Pandas. In earlier versions, this code would have ran without using LOC function. So ideally it should have worked, but okay, it is asking us to use raw LOC function. So this is filter dot LOC. Let's see if this works. Dot LOC colon comma. It is working. So dot LOC colon comma. Dot LOC colon comma. Okay. Still it is not printing. I'm not sure why. It should have worked ideally. Okay, we will maybe we will come back to this tomorrow. Okay, for now we will continue, but this is how filtering works. Okay, so Python versions keeps on changing, and because of that syntaxes also changes. So these are some things which will keep on happening because it's an open source programming language. The updates will be keep on coming. So but this syntax is actually exactly correct. There is nothing wrong with this syntax. Now why it is not working, that's another question. Okay. All right, okay, we will figure this out and we'll come back later. But just say we have understood the concept of filtering. Okay, filtering based on 1 column, filtering based on 2 columns. Okay, there is a community. Okay, so there is a PyPy is the library, okay, where all the Python libraries are stored. Okay, so there every library would have their creators. So Pandas is created by one person, sklearn is created by another person. Okay, so whenever someone makes the changes, it has to be submitted to that owner. Then that owner will check that the new updates, and then he will approve it, and then it will be uploaded on the dataset. So the owner or the creator who has created that library, those are the people who approves it. Yeah, it's a very long and tedious process. It's not like that anyone will come and contribute to the. There is a lot of testing goes before uploading it, but still even after multiple tests, there would be some bugs that might be coming as a part of new release. But on the GitHub community, people talk about those bugs, and then finally the creators take care of those bugs. It's nothing new that you haven't done yet. Only thing is the concepts you already know. We will just understand how to do that in a pandas. So this is the cars data. Now you know the concept of group by. How many of you know the concepts of group by? In Excel, it is called as pivot table. So same group by you can also apply on your pandas data frame. So let's create one. Let's create one small data in this current data set. We do not have any columns to group by on. So let's create one data frame called df1. Let's say cricket. Okay, cricket. So I'm just creating one couple of columns. So first column is, let's say, player name. So I hope you guys watch cricket. So let's say Sachin, then Dhoni, of course. Yeah, I think many of us are watching IPL. Yeah, let's say Kaif. Okay, Kaif is not playing these days, but we can include the name. Then let's say Yuvraj. Okay, maybe some foreigners. Okay, Kohli. Perfect. Okay, maybe let's say Ricky Ponting. Ricky. Okay, I think this is enough. Then, okay. So player name is the key, and all these names are there, the values for that key. Yes, correct, Balaji. We have to put them in a list. Yes, good observation. So I just did that. Now, second, okay. Then second, is the team. Let's say team. So I hope all of you are watching IPL. So I will use some references for IPL. So Sachin plays for Mumbai. Okay. Or used to play for Mumbai. MI. Then Dhoni plays for CSK. Okay. I'm trying to use the original names. Kaif, I don't know which team he used to play for. So I will just write KKR default. Yuvraj Singh, I think he used to play for Kings 11 Punjab. Kings Punjab Kings. Okay. And Kohli plays for RCB. And Ricky Ponting, I don't know. I think he's part of Delhi, coach of Delhi. So I will just write DL. What is the king? Delhi Capitals, right? DC. Okay. Okay. So these are the yeah. So these are the team names. Okay. Now in front of each player, I will also write the how many times they won the IPL. Or let's say score. Okay, how much score each player has scored. Runs, basically, how much runs each player has scored. So, and these are some random values I'm entering. Okay, so don't be offended if your favorite player gets low number of score. Just for the fun. Okay. How many players we have? 1, 2, 3, 4, 5, 6. We have 6. players. So I will enter 6 values. Okay, without looking at the names of the player, I have entered the value. So say this is our data frame. Cricket is our one dictionary. Okay, and now we can convert this to a data frame using our pd.dataframe method. And if I print this cricket data frame, it will be looking something like this. So assume we have a big data with hundreds of columns and hundreds of rows and tens of columns. So now, what if I want to group? What if I want to calculate the average score of each team? Average score of each team. Now, for simplicity, what I will do, I will repeat the names of team, because here all the teams are becoming unique. We do not have repeated team. Group by function will not be, any helpful. So I'm just repeating instead of, I will put KF to MI, okay, and I will put Tricky Ponting to RCB, okay, and this is just for simplicity. So now we see there are 2 players from RCB, 2 players from MI, 1 from CSK and 1 from Punjab. So now, what if I want to calculate the average score by each team, or I want to calculate a total score by each team? So that is where group by comes into the picture. So you know the concept of group by, so I will not waste time on explaining the concept of group by. I will just show you how to do that in a Pandas. So we have a function called group by. So cricket, which is our data frame, dot group by. And on the basis of what we want to do the group by, we want to do it based on team. So this group by function will create a group by based on the column that we have specified. Now, after that, we can specify what aggregate function we want to put it as a part of this group by. So if we want to calculate its total score, total runs by each team, then we can just pass it as a sum. So see, when we use sum of runs by teams. So for each team, we will get the total score. So MI has total 2 players, so 200 plus 250, 450. And RCB has 2 players, 400 plus 300, so 700. Similarly, we can calculate the average score. Like SQL aggregate function can be used, exactly, yes. So there are, for average, we can use mean. It will calculate the average score. You can also use, you can also calculate the count, okay? If you just want to simply count how many number of players or how many number of records we have for each team, so we can use count. So it will tell us that for CSK we have 1 player, MI we have 2 players, RCB we have 2 players. So these are some of the aggregate functions we can use in our group by. Okay, so basically the column on which you are applying the group by, that becomes the index. So this, see, the teams is the column that we used as our group by. So now team column becomes the index when you create the group by. Okay, so map function, okay, so if you have understood what is apply, it is similar to apply function. So what map function does, it maps the function, okay, or applies this function on a list. So for example, I have this list L. Now what I want to do, I want to multiply this every value inside this list by 2. So for that, I have created a function called as fun1, lambda function called as fun1. Now, if I want to apply this function on this list, one way to do that is I can run this list L1 through for loop, like for I in L, and then I can apply this fun1 function and pass this I value, and then again I can store it back into some other list L2, like this, correct? This is one way, but there is a simpler method to do this. Instead of writing multiple lines of code and using for loops, so for loops are very slow. Actually, it slows down your code. So to make it faster and make it easier, we have this function called as map. So instead of writing this function, instead of looping this through in a for loop, what we can do is we can use this map function. So syntax of this map function is like this. It takes the function as a first parameter, and second parameter is the list on which you want to apply. So what it will do, it will take this entire list and it will apply this function fun1 on each and every item inside this list, and it will give the output. So this map function returns the output in some other format. It's a generator. It's called as a generator. So it will return the output in other format. And if we, if we convert that generator to list, we can get our output back into the list format. So like this. Yes, so map is kind of a replacement for loop. Okay, to apply any function on a so exactly. So map function is a function which is used to map the values of a list on a function. So last topic is joining, and join, merge, and concatenate. So let's understand these three functions. So we have created this data frame with this course. I am just copying it once again. So I'll just give the name cricket1 to this data frame, where we have three columns: player name, team, and runs. Now I have another data frame. I will create another data frame. Inside that, I will replace these runs with wickets. And in wickets, I will just write the number of wickets each player has taken. Okay. So some of you might agree that some players do not even bowl. So this is just a hypothetical number. So don't stress on that much. So now in this second data frame, we do not have this teams column. We just have the player name and the wickets. Okay. And I will give this data frame as data frame cricket2, cricket1 and cricket2. So now you know that we have the same players inside our data frame 1 and same players inside our data frame 2. But there is one new column in our data frame 2. Okay, let me print the columns also, data frame also. So this is our data frame 1 and this is our data frame 2, cricket2. Okay. So in our player cricket1 data frame, we have columns called player name, team, and runs. In our cricket2 column, we have columns called player name and wickets. Now what I want to do is I want to create a third data frame, cricket3, which will have all the columns in the single data frame. Meaning I want to join this data frame 2, cricket2. I want to have this wickets column also as a part of this first data frame. So that is where the concept of merge, join, and concatenate comes into the picture. So let's understand how to do that. So let me add a few more cells. So these are the two data frames I have. So syntax is very simple. Which are the... So first we will understand the merge function. Okay. So pd.merge. Syntax is pd.merge. Then we need to pass our two data frames. So left hand side data frames, cricket1, right hand side data frame, cricket2. So this is similar to the join in your SQL. So in SQL, you must have learned inner join, outer inner join, left join, right join, okay, outer join. So all those kinds of joins are available in this pandas also. So how to do that? Suppose I want to apply the join, which is inner join, okay, on these two data frames. So the first parameter is cricket1, which is my first data frame. Second parameter is second data frame. And now I want to use my merge. I want to join this using this merge. So how do I do that? I pass the third parameter, which is how, or third is on. So on is basically on which parameter you want to apply, on which column you want to join. So we want to join on this player name column because this is the same column which we have. Okay. We want to join on the player names column. So I will just pass player underscore. Yes, exactly like you did it in SQL. Syntax is different. Yes, concept is exactly the same. Just the syntax is, you need to understand the syntax. That's it. So if you run this, see, it is joining the table. By default, it applies the inner join. By default, it applies the inner join. So see, now this new column wicket is getting merged with our, so we are getting our third data frame with both the columns joined. Okay. Now, if you want to specify explicitly what type of join you want to use, so for that, there is a parameter called how. So how says, how do you want to join? So if you say inner join, by default, it's an inner join. If you say left, it will perform the left join. If you say right, it will perform the right join. If you say outer, it will perform the outer join, full outer join. Okay. So now we have same number of rows in both the columns. So that's the reason the output for inner join, outer join, and left join is same. But if you had different columns, okay. So for example, if I write, if I create a few more records in my second data frame, let's say if I add one more player, okay, Faf Duplessis, and one more player, let's say Gambhir, okay, Gambhir. Okay, and I will add their wickets also, 4 and 5. So now I have in my second data frame, I have two additional columns. So see, two additional rows. I have 7 rows in second data frame, 5 rows in first data frame. So in here, if I do my left join, I will have all the records only from my left table, which is 5 records. That's the reason we are getting only 4 joins, and those 2 records are omitted because we do not want to join on the, we have joined on our first data frame. If I do right, I will get all the 7 records from right data frame. And for these 2 records, Faf and Gambhir, I do not have values in my first data frame. Okay, so those will be those values will be given as NANs. And if I do outer join, the same values you will be seeing. So it will take the data from both the columns, and wherever there is a missing value, it will be replaced by NAN. So this is how merge function works. So you know how inner join works, right? What inner join does? Inner join takes the common records from yes, from both the tables. So now in first data frame, I have 5 records. In second data frame, I have 7 records. So if I perform inner join, it will take the common records. So there are 5 common records. So it will give the result as a common records. Okay. So inner join does the looks for the common. Left join will take the data from left table, okay, left data frame, and it will find the values from the second table. So only the records which are available in your left table, only those records will be identified, and the values for those columns will be identified. And when you look for right, the values from right table will be identified, and it will look for the values in the left table. So wherever it will not find the values, so for example, for Faf and Gambhir, we do not have the values in our first table. So it will place NAN in front of those values. Okay. You know, now in this case, the name of our column on which we were joining was same, player name. But what if the name was different? So I will copy these 2 data frames once again to just show you. So in our data frame 1, in data frame 1, the column name is player name, but in our data frame 2, our column name is just player. Okay. So what should we do in this case? So everything remains same, just one parameter will change. So on this on, so what we want to do is we want to use left on, this one parameter left on. So we need to specify the name of the column from our left table, which is player name, correct? Player name. And then right on is equal to the column from our right table, which is player, and it will work now. Okay, so this is how merge function works. Now, same way we can use join also, pd dot join. So it is exactly the same. Just copy this merge exactly, and instead of merge, just use join. It will work exactly the same. It is throwing error. Pandas has no attribute join. Why it is? Okay, the syntax is little bit different. Okay, sorry, yeah, this left on, right on, these functions are not part of yeah, so we need to specify on. So I'm just changing back my name of my column to here name. Okay, both the tables have my player name. Okay, right on. Okay, so this right on, left on, these parameters are not part of the join. Cricket1 dot join cricket2 on player name, how is equal to left. Am I missing something? Time likes must match exactly. Value error. Dot concat. Okay, I don't know. Okay, but this is another method that join is also another method that works more or less same. I don't know why it is not working right now. Okay, now we will talk about third function, which is concat. Now, so we have cricket1 and cricket2, these three, where we had same number of same players, or even in the third in second data frame we had two more players. Okay, now what if I have third? I have third data frame. Okay, I will create a third data frame where I will have the whole new players. So I have, let's say, new players from other team. Let's say, why I'm not getting the names of player. Can you please suggest some player names? I'm kind of blanked out. Okay, Rahul, and then someone said Pandya. Okay. Balaji says Taibu. Okay. Taibu and okay, all right. Good enough. Yeah, fine. More. So we have 4 players, so we will add 4. So suppose we have this third data frame where we have 3 new players and wickets column. So we have the same columns. So in cricket 3 we have 2 columns and 3 rows, and cricket 2 we have 2 columns and 7 rows with the same column names. Now I want to concatenate these 2 data frames, meaning I want to add these 3 rows from cricket 3 below this cricket 2 column. Okay, so I want to concatenate these 2 data frames. So that's where we use a method called as concat, pd dot concat. Okay, pd dot concat. So where you need to pass your data frame 1, which is cricket 2, and data frame 2, which is cricket 3. So yeah, so see, it will now append the rows from both the data frames, one below another. So now in concatenate, you can add as many data frames as you want. So if you have 10 data frames and you wanted to add, you can do that. You can even add the third cricket 1 data frame. It will concatenate, and wherever we did not have values from in cricket 2 and 3, we did not have column called teams and runs. So it will, and even not even player 1. So it will create those columns, but it will fill those values with NAMs. Okay, concat data frames. Now last thing that I want to show you, how we can export this data set. So let's say this data frame which we have created, merge data set. Okay. So for example, if I have merged this data set, okay, or this concatenated data set, I have stored it in a new variable data 1. I have stored it in this data 1 variable. Now data 1 is my data frame. I can do many more things as a part of exporting. So if you press dot and place tab, you will see there are many methods that Pandas data frame has. One of them is to_CSV. So read_CSV reads the CSV file into a data frame, Pandas data frame. To_CSV will write the data frame into your hard drive, into your computer. So you can give the name of your data frame, let's say sample.csv. And wherever your current working location is, that file will be written, this file sample.csv will be written on that current location. Or other way around, you can provide the complete path of your location and this file will be saved. So if I write data.csv and if I show you my current location, which is this one only. So see, this sample.csv is exported into my hard drive. If I wanted to store it in some other location, I can just pass it like C:/folder1 and then sample1.csv. This will save the data in this particular folder. To export the data to a CSV format, simply use this function called as to_CSV. So data 1 is our data frame. To_CSV is our function which we use to store. It will be stored inside your current working directory. So if I say import OS is the module which is OS is a library which is operating system. So using this module, I can get current dir is the function. Okay, so it is saying that my current dir is some base location. It is not working in Mac, I don't know, but it should work in your local dir. So where it will get stored, wherever your Python file is located. So if you want to store it on a particular location, you can specify the entire path. Okay, C:/folder1. Okay, so it will get stored in this particular location. By default, it will, if you don't specify path, it will get stored on the location where your Python file is located. Now this is one example. You can export this data into a dictionary. If you want to convert this data frame back to the dictionary, you use to_dict function, and see your Pandas data frame will be converted back to a dictionary. Then you can convert it to data 1. Then you can export it in many other formats. Excel, HTML, okay. Then Xarray is basically NumPy array. Then you can, so these are various formats in which you can export your data. All right. So just go ahead and in the coming week, explore all the functions that Pandas has. Okay. Just data frame, type, tab, and see the different functions. Okay. So there are many functions which nobody uses all the functions, but there are many functions which we have as a part of available. Check some random functions and see what they do, and play around with it. You will understand. To filter this, okay, we have to use our LOC function. So how do we use LOC function? We pass LOC, cars.loc. Inside our LOC, we have to pass rows and columns. Okay, so for rows, we will filter out our rows and we will take out the index. What we are doing, As a rows, we need to pass our rows. So when we filter our data, okay, like this, it gives us all the table. Now we want these index values because these are the row values which we need to pass. These are the labels of our index that we need to pass to our location function. So we simply use dot index. So this will give us index values for all the filtered data. So that's where we have passed index before this column as a part of our rows. Okay, so after applying filter, we simply call this index dot index. So it will specify all the labels for our index. And then we also have to pass the index value for our column. On which column we have to apply this. So that we are passing as a part of our columns as a label. So if I run this, my cars, if I print this, my cars, see, some of the columns, some of the values are converted to white. So which columns are white? Wherever the cylinders is equal to 8. Now similarly, I will do this for other two filters, which is equal to 6. So for 6, I want it to be red, and for 4, I want to be black. If I run this, so see, all the filter values have been changed. So now, what is visualization and why do we need it? Okay, now why data visualization is important as a part of data science, as a part of a data scientist, as a part of being a data scientist. Now, you must have heard the term that a picture says more than 1,000 words. Okay, picture can explain things which words cannot even explain. The same concept applies to the data also. Data is good, okay, but looking at a table and looking at a chart, we have to analyze table thoroughly, then we might be able to get some insights out of it. But if we convert those tables to a charts, we can understand things in a matter of seconds. We can get the insights, we can get the pictorial representation of our information in a matter of seconds. And that is the reason visualization is very important in a data science. Now, simple example of visualization, that if you need to understand whether saber-toothed cat and mammoth, out of them, which one is fastest? Okay, by looking at the data, you can say mammoth speed is 25 km/h and saber-toothed cat can run at 75 km/h. Okay, so if you visualize this, okay, based on some chart, it will be much more clearer. If we had more than 5, 6 or 10 animals here, graph will tell us visually. Correct, Shilpa. So we can understand things which we can, graph can tell us things which normal tables may not be able to explain in a simplistic manners. So why visualization is important? We can view changes over time seamlessly using a visual rather just plain data. So for example, if you have monthly sales for last 12 months, okay, so we can understand, if we plot it, we can understand which month were having least sales and which months were having highest sales. We can easily discover correlations between two or more variables. Identifying correlations with the help of tables is very difficult, but graph can tell us much better. Using proper visualizing, we can simplify complex information into user-friendly formats. Generally, we can tell better story with bunch of pictures over time. So just having data is good, but having data converted into some visual charts is much more better. So now why should we visualize data? Let's take one example. Okay. So there was one mathematician, one statistician called Francis Anscombe. So now he developed Anscombe's quartet and showed the importance of visualization. Now, what is this Anscombe's tortoise? Let's understand. So what he did, he created 4 data set, okay, with 11 rows. Like this, 4 data set 1, data set 2, data set 3, and data set 4. So in each data set, he has 2 columns, X and Y. And he recorded the values for those X and Y columns. Now, on a higher level, he created summary statistics for all those 4 data sets. So if you look at the summary statistics for all those 4 data sets, you can say he created 3 summary statistics: sum, average, and standard deviation. So if you look at those summary statistics, the values for all the 4 data sets are exactly same. Exactly same. See, so sum is 99 for X column, and for Y column is 82.5. Average is 9, and for X column, and for Y it is 7.5. Standard deviation is 3.2 and 2.03. 3.32 and 2.03. So if we, if someone looks at this data, he will observe and he will understand. So if one has to look at this data, if someone look at the summary statistics, he will understand all the 4 data set represents the same values, same data set, same data. All the 4 observations are the same thing, because I can see the sum, average, standard deviation, everything is same. So there is a possibility that all the 4 data sets are representing the same sample or same set of observations. But he plotted all the 4 data sets individually like this using a scatter plot. This is called as a scatter plot. We will understand differently. When he plotted it, he understood that each data set follows a different distribution. So in first data set, it was kind of a linear distribution. In second data set, it was kind of a, this curvilinear distribution, curve, yes. The third one has linear, but there was one outlier. And fourth one was scatter plot is used for correlation. Yes, Koshi, you're absolutely right. To find out the correlation between 2 variables. So the point that I'm trying to make over here is graphical representation is very important, because it can tell us things which normal statistics cannot tell us. It can give us some insights which are not usually understood by looking at the summary statistics or just the tables inside the data set. And that is why the visualization is very important. So in Python, there are many libraries available to us to convert our tables or convert our data frames or convert our arrays or lists to the visual data sets. So some of the libraries are like Altair, Matplotlib, Plotly, ggplot2, Seaborn. These are some of the most commonly used libraries which we use in Python, or which are available in Python. Out of these, as a part of this course, we are going to talk about Matplotlib and Seaborn. These are the 2 libraries that we are going to learn as a part of this syllabus. Okay. So let's understand. So what is Matplotlib? Matplotlib is one of the Python library which is available as a part of open source module for data visualization to create 2-dimensional plots. Okay, so there are various plots that we can create using Python, okay, and using this Matplotlib library. Okay. So how to import the Matplotlib? So similar to all the other libraries like NumPy and Pandas, we can import Matplotlib like this: Matplotlib dot pyplot as plt. Now, why pyplot? So in Matplotlib, there is a sub module called pyplot, which helps to create the graphs, create the charts using different methods. We have different functions, methods, and properties in this pyplot submodule. That's the reason we import matplotlib.pyplot. We import pyplot submodule from matplotlib, and we are given alias as a PLT. So PLT is the most commonly used alias in the community, in the industry, which data scientists use. We will also import NumPy, okay, to create some arrays, and we will use those arrays to plot our data set, NumPy as NP. And there is this magic command, okay, matplotlib inline. So what this command does, this is a magic command, percentage matplotlib inline. What this does, what it does, it basically helps to print the graphs in your cells. So in your earlier versions of Matplotlib, you had to write this command manually so that you can have your graphs inside your cells. But the latest versions of Python do not require this. So even if you don't write this, that is also fine. If you write this, that is also fine. Okay. So now what I will do using this NumPy, I will create one array. Okay, I will create one array X np.arrange. Using np.arrange, I will create one array. So from 0 to 10, I will create some values. Okay, from 0 to 10, separated by 0.1. So this is the that interval, correct? Interval between 0 to 1. So if I print X, you will see there are 100 values. There would be 100 values from 0 to 10, from 0.1, 0.2, something like that. Okay. So if I check the length of this X, you can see it's 100 values. And I will also create a Y variable. Okay, another array Y, which is basically, let's say 2x, 2 multiplied by x. So which is just a double of y. I'm just creating these two arrays. Now we can plot these two arrays, okay, in a line chart. How do we do that? We have imported this PLT module. So we will use PLT, and this PLT module, pyplot module, has function called as plot, method as plot. So there we will pass our both arrays x comma y, and it will plot a line chart like this. So on x-axis, we have our x values. On y-axis, we have y values. So just the way we used to, plot our in our mathematics subject in schools, we had let me open that. What is the name of that application? Board. Let me open that board. Yes, yeah, in cell you can see. So suppose this x is 2. So we have pairs, correct? We have pairs. If my x is 2 and y is 4, then if I want to plot it on my graph, how will I do it? Suppose this is 1, this is 2, 3, and 4. So this is 1, 2, 3, and 4 respectively. So if I want to plot this 2, 4, so x is 2, 4, y is 4. So I will have point somewhere over here. Then if I want to plot 1, comma 2. 1, comma 2. So x is here, y is here. So it will be somewhere right there. Okay. Sorry, 2, comma 4 would be somewhere around here. So if I want to plot middle value, which will be somewhere around here. So if I join this, I will get my line chart. Correct? I will get my line plot. So similar way, we have created our line chart in a Python. Okay. So this is how you can create a line chart. And so this plt.py plot, okay, will plot the graph just like this inside the line. And there is a function called plt.show, which will plot this graph like this. Okay. So this plt.plot will plot it, but it will not show if we run it as a, if we, after that, if we had some other variable. Okay. So plt.show is a method which is used to show. So this plot method will also show the graph, but it will be printed something like this. So see, you are seeing this some additional information. So we don't want that additional information. We want only graph. So plt.show method will plot the graph. So by default, this plot method will take the two values and it will create a line chart. So by default, this plot method creates a line chart. So this is the simplest way of creating plot in a Matplotlib. Now we can even use, now we have used arrays over here. We can use list. We can even use pandas column names. So in cars dataset, we had HP and horsepower column. So we can use those column names as a series and we can plot it. That will also work. So now let's see how to customize these plots. Okay, how to customize these plots. So I'm copying this code once again up until creating the data set. Okay, data set we have created. Now we will understand the sophisticated way of creating graphs using Matplotlib. Okay, step-by-step method using creating the graphs in Matplotlib. How to customize the graphs. So there is a method called as plt.figure. plt.figure, this one. What this method does, it creates an empty canvas. And inside that canvas, we can start drawing our graphs. We can start writing our code to draw the graphs. So this plt.figure takes many arguments. One of them is called fig size, which is the figure size. So this figure size argument takes tuple of our size of our canvas. So how much length and width you want for your figure size. So see, if you write this, it will show you that some information. So but what it does basically, it creates an empty canvas with figure size of 10 by 5. So now this by default, it takes some default figure size. Okay, by default, it takes some default figure size, which is in terms of some unit, whatever unit it has for it. So we can custom. Now we also need to store this variable. We need to store this empty canvas in some variable. So we are using a variable called figure. Now we can start plotting. So let me just write over here that creating a figure with custom size. Now we can start plotting on this empty canvas, plotting the graph. So how do we plot? We use our plt.plot method. So plt.plot, and we will pass our x comma y, and then we will show plt.show. So see, our graph is now bigger. With default parameters, we were getting a smaller graph. Now that we have passed 10, 5, our graph is bigger because we have passed a figure as 10, 5. If I change it to 5, 5, we will get it as a squared ones. So it may not look like exact square by visually, but believe me, it is a square. So if I pass 10, 5, we will have a bigger width and smaller height. Now we can do much more customizations while plotting the graph. So what if I wanted to specify the width of this line? I wanted a bigger width for this line. So for that, we have a parameter called line width. Line width. Line width. So I can specify the line as a float value. So if I specify 2, see the line has got bigger, little bit bigger. If I specify it as 6, it will be much more big. Very thick. Thickness of the line. Correct. Yes. Graph. Okay. So if you see the graph, it is the same graph, but with customization. We have changed the width of our line. Okay. And the graph size is also increases because we have 10 by 5 figure size. Now so I will just change it to 2.0 once again. Before line width, did you use any other function? No. Line width is the parameter, okay, of our plot function, plt.plot. Line width is one parameter, okay. So how do we customize our graphs? We use different parameters of our plot method, okay. So we are going to see all the various parameters of our plot method. Then we have another method called as line style. Now by default, line style, by default, it takes this dot, this line kind of, style it takes by default like this. There are various styles we can use as a part of line. So if I specify colon, it will create dotted line like this. So there are some various styles available, some limited styles available, which you can find in a documentation. So inside this function, if I press Shift and Tab, and if I click on this plus icon, okay, if I click on this plus icon, I will just shift it over here for time being. So it will tell me what are the different parameters and options I have available. So for the line style, I'll just go to the line style. Where is line style? If you see, see line style, we have these options available. So for solid line, this is the one which we were already using. For dashed line, you have to specify 2 underscores. Sorry, 2 dashes. So for dotted line, we can use this one. So you can check your documentation like this. So if I want to convert it to dashed lines, I will get it like this. If I want dotted dashed lines, I will specify like this. So I will get dotted dash line. So I can change the style of my line like this. Okay. Now by default, it is giving a blue line color. We can change the color to any other color. Okay. Suppose if I want to change it to red, it will be red. If I want blue, it will be blue. If I want green, it will be green. So this is how you can change the color of your graph, color of your dotted line. Then the next parameter is called as marker. So marker is a parameter. Suppose if I say, oh, see what it is doing. So on every point of you on your data, it is creating that marker. So we had 100 points in our data set. So for each point, it is creating this marker. So if we had just 5 points, we would be having a data set with 5 points only. Correct? We would be having a data set with 5 points. So, but still we would be getting a bigger line. So to check where exactly all those points are located, we can space point markers, and 1 point would be here, 1 point would be here, something like that. So marker is used to understand where exactly our points are located. Now we can give title to our graph by calling the title method of our PLT function. So inside that I can give any title. So I will say, let's say line plot. Using title method, we can give the title to our name, title to our plot. So here on my plot, the line plot title is appearing. Then I can give the labels to my x-axis and y-axis also. If I want to understand what is I have plotted on x-axis and what is I have plotted on y-axis. Suppose if we are plotting average, if we are plotting revenue on x-axis and profit on y-axis. So we want to give the names to our axis. So there we can use plt dot x label for giving the label to x-axis. So let's say I'm just giving x-axis. So see, the label for x-axis is appearing over here. And same thing I can do for y-axis. So plt dot y-axis. Sorry, y label. And I will just give y-axis. So we will be having label for our y-axis as well. Now we can also have the legend for our graph. Okay, we can also have the legend for our graph. So for that, we have a function called as legend or method called as legend. Inside that function, we need to specify what is the name that we want to give to the legend. So I'm just giving as line 1. And we also need to specify the location for our legend, where exactly you want it to be present. So if we specify best, it will identify the best location. So legend is, for this graph, legend is not making any sense, but just say you have a bar chart, okay, bar chart. So in bar chart, you will be having multiple charts. So what color represents to what bar, or so for that legends are used. Okay, so we will understand legends when it will make more sense when we will be having the legend, when we'll be talking about other bar charts. Okay, so that's what I said. For line charts, legend is not making any sense. Okay, but this is just a method to understand to how to create a legend. There is a method called as grid. You need to specify it as a true, and if you call it, it will create a grid inside your plot. Okay, so this is how you can create and customize your graph or line chart inside Python, inside Matplotlib.
Just a quick info, guys. Intellipaat offers state of the art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
So let me come through this problem statement. So people charm, a growing company, is facing a iteration rate, high iteration rate. High iteration in the sense people are leaving. So people charm is a company name, and that company is facing the high iteration rate in the sense people are leaving among their employees, which in turn affects their business due to lack of expertise and experience. So if the people are leaving, if the employees are leaving or who are about to leave, don't you think that it is directly or indirectly it is affecting with the business as well? And if the experienced people, now say the person who is leaving is having 5 to 6 years experience in the same company, don't you think that the experienced person, if he is leaving, it is also one of the major drawback, and it is gonna affect the business as well, to the company as well? Yes. So considering all these, their HR department is assigned with the task. What is the task? To reduce the iteration rate by retaining employees who are about to churn out. Okay. So HR department has been assigned with a task to reduce this iteration rate. So people whoever are leaving, so to reduce the number of employees who are leaving, they're trying to assign some task, okay, to retain the employees who are about to leave. So they need to recommend special plans or strategies which will help them to retain their employees, which in turn will help them to grow bigger as a company. So as the HR department has been assigned with the task, so they have to be recommending some special plans or strategy which will help them to get their employees back. Okay, so which will help them to grow bigger as a company. Obviously, okay, now you guys tell me, let us replicate this scenario to our real world life, right? Fine. So let us come and check with a variable. So if we are looking, see, from one person to another person or from one employee to another employee, there will be the difference of opinions. For some employees, it might be with a salary, and some of them it might be with the promotion, and some of them with it will be with the satisfactory level, right? So opinions to opinion, it will differ. Okay, so we are having these variables, in the sense these are some of the data. Based on this variables only, will be predicting. Okay, so in this case study, okay, so in HR analytics case study, what happens, guys, we are gonna do some prediction, some analyzation over here. Okay, based on the prediction or analyzation, will we be able to get the accurate output or the accurate result? Is it possible? No, it is just the outlook of why the things are happening and how you will be able to recover it. Okay, some assumption you'll do, some predictions you'll do, and based on that, some strategies also you'll be able to do it. So let us check with these variables. Satisfactory level, the very first one is the satisfactory level. Scores given by the employee, scaling 0 to 1. Okay, now if the employee is satisfied, he'll be giving 1, okay, or with between 0 to 1. If he is not satisfied, he'll be giving with the 0. Okay, 1 is true, 0 is false. Okay, yes, satisfactory level, it is also one of the major factor, guys. Now say if the employee is not satisfied with the company, whether it might be the work culture or with the manager, anything, okay, related to that, it is nothing but the satisfactory level. So there are many factors, okay, these are just the limited. Okay, there will be multiple variables, guys, but as of now we have taken a simple data over here. Okay, see, basically satisfactory in the sense whether he is satisfied. Okay, now as an employee, you put yourself into the shoes of that employee who is about to churn out. Okay, what might be the reason? Yes, satisfactory in the sense he is not satisfied. Why he is not satisfied? We do have some multiple variables that we come across. Okay, as of now we can just take that employee is not satisfied. It might be because of the work culture, because of the location that he is working on to, it might be with the job role, position, all these. Okay, maybe the learning opportunities, yes, it might be very less. Okay, so he might be trying to switch his domain to somewhere else. Now say many people from the non-technical, they'll be switching to technical, if you observe, right? So that might be one of the reason. Yes, if he is not satisfied, definitely he'll be on a notice period, right? Churn out in the sense, attrition rate in the sense, people who are leaving, okay, who are about to leave, they might be serving notice period, right? Who are about to leave the company, yes. So why is on notice period? Definitely it will be with his satisfactory level, in the sense he's not satisfied. Maybe it might be because of his salary or anything else, but yes, satisfactory will include all those. Okay, last evaluation, what do you mean by this last evaluation? Last evaluation in the sense, the review of the manager or the feedback from the manager is nothing but the last evaluation. Okay, so yes, last evaluation in the IT sector, in the corporate sector, okay, we call it as a manager's review or the feedback of the manager. So it might be from the team leader who might be giving the review or with the manager. Now say, do you consider this last evaluation? Is it appropriate to be considering with the last evaluation, guys? Because now say I don't have that good relationship with my manager or with my team leader, okay, whosoever is gonna evaluate, so that I don't have a good relation or a good bonding with that person. So even though I'm putting my 100% of effort, even though I'm involved in all the projects that has been taking place, but still if he's not satisfied with me, definitely he might not give that expected points, right? So satisfactory level is for the employee benefit, okay, whether he's satisfied or not, that will consider. But last evaluation, we are going to check, not only we cannot only consider with the scores or the review or the feedback of the manager, okay, we'll come across the other points as well, okay, in the last evaluation. Okay, directly we cannot consider with the output of what the higher authorities are going to give about the employee. Okay, check with the whatever the projects that he was involved and what was his promotion in the last 5 years, like since how many years he has been working, or what is his contribution in the company, and which department he's working on, to what is the salary. Okay, is he contributing something to the company? So everything he's gonna be evaluated. Okay, not only based on the last evaluation. Okay. Yes. Next is the number of the projects. So we're going to check with the number of the projects that the employee was involved, right? Now say you guys tell me if the person is given more number of projects or the person is given the less number of projects. Okay. So whom do you think that, okay, it is benefited? Whether the person who is given more project is gonna leave, or the person who is given less number of the projects he's gonna leave. Two less project, if it is given, okay, to the employee, he might feel that he's not that much engaged enough into the projects. Okay, it is like demotivating him, right? And too many projects given to him, in the sense he's burdened, right? If the person is giving the stable amount of projects to work on to, definitely he'll be happy to work and he'll be engaging himself in a good amount of the timings, right, with good projects. Okay, so he will be contributing his own things to the company, right, based on the projects. Now if he is given very less number of the projects, in the sense maybe he might be not much involved in the projects, okay, so he might be demotivated and there is no things to learn, right, if he's not involved in much of the projects. So this might also be the major reasons, whether he's given only the less number of projects, whether he's given the very more number of projects. Okay. Yes. Average monthly hours. What do you mean by this average monthly hours? The time that the employee is spending on the project. Okay, that is nothing but it comes under the average monthly hours. Okay, what is the time that he has spent, okay, in the project, in the office? Okay, that will come under the average monthly hours. So time spent in the company, in the sense what is the duration, since how many years he's been working in the company, that will come under the time spent in the company. Work accident, in the sense whether he or she had some conflict. Okay, let me tell you guys. So basically, so is work accident in the sense not physically that you're injured. Okay, so work accident in the sense, now say you don't like some of your colleagues. Okay, now say you're working on to some project and I do have some two colleagues which I don't whom I don't like and whom I don't trust also. Okay, there might be some internal cold war that might be happening. Okay, there will be some conflict between you and that person, but still, don't you think that this conflict between you two people, personal problems, okay, it is going to affect with the project as well? Yes, bullying in the workplace or harassment, that can be some kind of a work accident, guys. Okay, so basically accident in the sense not physically, but yes, you might have some conflict. Okay, so basically work accident can also be considered in this way also. Okay, that you do have some misunderstanding between your team lead and you, or with your manager, you might have a mouth to mouth talk, okay, regarding this. So this is just a work accident that you're not having a healthy environment around you. Yes, next let us come to the part of left. So what do you mean by this left? If the employee is about to leave or not, okay, about to leave in the sense serving notice period. Okay, if he's serving notice period 1, if not 0. Okay, so yes, next is promotion in the last 5 years. So many of you mentioned that point also, that if the person is not given promotion, now say there is some person who has been working in that company for more than 5 to 6 years, and we are going to check whether he's given with the promotion or not. If he's not given, if that is the one of the reason if that is one of the reason that he might be about to leave, then yes, we are going to check based on his performance, he'll be given the promotion. Okay, then we're going to check with the department whether he or she belongs to, okay, whether he's looking to change his domain. Okay, we can also look into that, and we can also change his department as well. Okay, next we're going to check with the salary. Department in the sense, now say in the company there'll be various department, right? Now say there'll be one kind of, now say a person from the operation wants to go with the some other team where like technical team. Okay, from the operation team, some person wants to move into the technical team. So if he's looking in that kind of a transition from one domain to another domain, yes, we're going to look into it, we're going to check with that, and also based on his performance, he'll be switched to the other department as well. And another thing is the salary. Okay, salary plays a very major role in here. Okay, if so, in some particular field, if there is demand as such, yes, with a good package, obviously competitors also will be more for that. So people who are trying to switch their domain, basically they will go with the market demand. What is the market value for which domain there is high salary or scope? Okay, based on that only they'll be switching. So yes, salary plays a very major role in here. Okay, salary plays a very major in here. So if he is paid very less, okay, so yes, we will go with the yes. So we're going to check with that whether he has been given appraisal in the previous year, like for previously was he given hike. So these factors they'll be considering, and yes, they will be checking on to that as well. Okay, see, as of now, people whosoever are working in some companies or some under some corporation, definitely they will move out from the company if they are not given, if there is no much demand for their domain. Okay, they're going to check with the reviews, obviously they'll try to move out, right? So yes, understood with this entire problem statement what we are going to do. Yes, now we're going to compare with this left. Okay, we're going to check with this left, in the sense people who are about to leave. Okay, we're going to consider with this and with the other major factors. So based on left, that is people who are about to leave, we're going to consider. So first, let me show you how you will be doing with the analyzation first. Okay, so what and all the approaches that you gave directly with the visualization, it is right. Okay, it is right. But as it is a case study, we cannot directly jump into the solution part. We have to do some analyzation. We have to go with the EDA, step-by-step procedure, right? So what we will do? So I hope you guys know how to upload your data set. Go with the upload option. Just select your data set. Now say this is my data set. Click on to open and upload it. Okay, after uploading, go with the new file. Yes, so the very first thing that you guys will be doing is importing the required libraries. Okay, let us import the required libraries. Why is NumPy required? Why do you require NumPy, guys, in our case study that we're doing? What is the use of NumPy? You guys tell me. For numerical analyzation or with a calculation, I can say. Okay, yes, Hindol, I can see that you have been raising your hand. Let me know what is it. Next, let us import pandas as PD. Why pandas is used? For data set, I'll mention. Okay, so already you guys know all these. Okay, but still it will be like a revision for you. Okay, now why Matplotlib is used? What is the use of Matplotlib? For visualization, exactly for the data visualization and plotting the graph, we make use of this Matplotlib. So I will just pass with Seaborn as well. Why Seaborn is used, guys? Why Seaborn is used? Second visualization, is that so? See, basically it is also a second visualization, but Matplotlib, it will just plot the graph. Okay, it will just provide you the graphical representation, but to make it more presentable in the sense with more colors, to make it colorful, I can say. Okay, with colors and with more highlights, we make use of Seaborn. Okay, I can just mention it for better visualization. It's not like it is compulsory. Okay, it is just a kind of advancement, because only if you want the graphical representation, just to fetch the data directly, you can go with the Matplotlib. But if you want the customized visualization, okay, anything like bright with colors and more presentable, we make use of this Seaborn as well. Okay, now we have imported the required libraries. What is the next step? What is the next step that we're supposed to be doing, guys? Reading of the data, right? Let us load our data set. Okay, let us load our data set. I'll pass the variable data. So I will be storing my data set in this particular variable. So as it is a CSV file, let us mention that. Okay, yes. So let us read our file, that is CSV, and as I have imported with the people.csv, that is my data set, right? So I'll just mention the name. Already it is been uploaded in the Jupyter, so I can just call with the name and I can make use of the data set. Okay, we have loaded with our data set. Now if I just pass with data, can you see this data set? Okay, and here you can see with the number of rows and column that we are having, that is 14,999 rows and 10 columns, right? Yes. And you can see multiple columns. These are the variables, if you remember: satisfactory level, last evaluation, number of projects, average monthly hours. Okay, these are our variables, isn't it? Now let us start exploring our data. Okay, so let us come with our EDA. So what do you mean by EDA, guys?
Let's have a quick quiz question, guys. And the question is, in a classification problem, what does the precision metric measure? And your options are the proportion of true positive out of all positive predictions, the proportion of true negative out of all negative predictions, or the accuracy of positive predictions, or the accuracy of negative predictions. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Exactly, it is exploratory data analysis. In the sense, you're going to explore the data set in here. Okay. Data set first. Okay. Now, if we go with the data and with the head, what will it give? Yes, if we go with the data and with the head function, what will it give, guys? See, why data variable? Because you can see my file. Okay, the data set, it is in this variable data. In this particular variable only, my data set is present. Okay, so that is the reason I'm calling that. See, if you observe over here, data.head function, okay, it is going to return the top 5 records, right? Now, same thing if I do with the data.tail, okay, what will it give? It is going to give the last 5 data. Returns the lower 5 records. Okay, you can see 14,990. So in total, we did have 14,999 rows, right? In the sense, the very first index number will be from 0. So from 0 to the 14,998 count will give you 14,999. Okay, so don't get confused with that. So clear with this? Now let us go with the shape. Yes, you can see 14,999 rows and columns. So shape, attribute. And if you remember, these are the function, guys. If there is brackets present in the sense, these are the functions. But here, we are not providing the brackets. Why so? Because if there is no bracket in the sense, it is a attribute, not the functions. Okay, this is the difference between when you provide the brackets, which means it is a function. If there is no presence of the brackets, in the sense it is an attribute. So shape of the data set, rows and columns. Okay, so what is the number of rows? 14,999 rows and 10 columns, right? Okay, don't get confused, guys, why there is no bracket, because now say if I provide bracket, can you see we don't have any function called as shape. Okay, it is an attribute, so don't get confused. Yes, now let us come to the info. Okay, it is going to give you the information whether we do have a null values in here or not. Okay, now yes, so what does this info function does? So it is going to provide the entire information about the data set, exactly understanding the structure of the data set. Okay, it will provide you the data type, okay, whether it is float, object, or integer. Okay, as these details will be able to explore in info function and with the size, yes. Now, okay, we do have something called as description. What do you mean by this description? Okay, if I pass with our describe, okay, you can see this. Yes. So what does this describe function does? It's going to return the description of the data in the data set. And if you observe over here, okay, the count, okay, that we are having is 14,999. Yes, statistical values, I can say, to be more specific, a numerical analyzation this is, which is for numeric fields only. Okay. Yes, so we are done till our describe function, right? Now next is our data pre-processing. Okay, so what we do in this data pre-processing in the sense, yes, we'll try to find out the impurities and remove them. Okay, so we'll be finding out the null values. Okay, first, so let us find out the null values. Data dot is null, we can go. Okay, do you have any null values? It says all false. Okay, if not, by this you can also go with is any. Okay, someone had mentioned dot is any. Okay, you can go with is null or is any, both works fine. Can you see? Yes, either of it you guys can opt and you can do it. Now if I want the count of this, okay, you can see we don't have any null values. Okay, it's going to give the count of the null values from every column. As of now, we don't have any null values. Guys, this is just data pre-processing. Okay, directly we cannot jump into the conclusion. Okay. So let us start working with some duplicate records. Okay, now say if we had some null values, so that time what you're supposed to do? As of now, we don't have any null values in our data, right? So in case if you had, okay, this is without statistic I'm speaking about. Okay, you can go with the drop any, which will drop or remove, I can say, missing values. Okay, if, okay, this is with the numerical data. Okay, now if you have the categorical data, you go with the mode for categorical data. Okay, just remember it, okay, for your future reference. Very good, Syed. Yes. Now let us check. We do have any duplicate? Do we have any duplicate records or not? Okay, let us check with the duplicate records. Okay, so let us check with the function that is duplicated. Okay, let us check with this function whether we do have some duplicate records or not. Okay, spelling. Okay. Yes, we do have some duplicate data, that is 3008 rows and 10 columns. Okay, so 3008 rows are duplicate. In the sense, what do you mean by duplicate records? Redundant data, identical data, yes, exact same content in 2 rows. Yes, Sudhir. Okay, 2 or multiple rows. Yes, Angelo. Okay. Yes. Now, say we do have these many records, right? Which is duplicate. Now, let us remove these. Okay. So, it is not good or ethical way to keep this duplicate records. Okay. Because we will miss out some of the exact data over here. Okay. So, let us remove the duplicate data. So, data is equal to data dot, I'll make use of drop underscore duplicate. So I'll just keep is equal to first. So why we are passing this first in the sense, okay, if I'm giving this keep is equal to first in the sense, okay, it removes and keep the first record. So what we are going to do over here, if we provide keep is equal to first in the sense, it is going to keep the very first. Now say example, guys. Okay, let us take an example. Okay, in these three records, we do have the same data, same columns data. Okay, so yes, if you are having the same columns data, now say 0.37, 0.37, here also 0.37. If you are having the same data over here, that time what we can do, we can say this is a duplicate data. In the sense, employees data is reflected again and again. So what I'll do, I'll go with this keep first. Keep first in the sense, this very first record will be present. This will be deleted. Okay, getting the point? If you mean keep first in the sense, yes. Now, in place of this first, if I mention to be last, okay, if I mention it to be having last record in the sense, if you're having these three records, this first two will not be considered. The recent in the sense last data, always remember the last data in the sense the recent data that is uploaded. Always in the real world, last data is only the recent data. Okay, so we will just keep the last data. Clear? But if it is duplicate, whichever you keep, it will be the same itself, right? Okay, if you want specifically to be mentioning something, yes, you can go ahead and mention that. Clear, guys? Now, we have successfully deleted with the duplicate records. Okay, now if I go and check with the shape attribute. Okay, previously, what was the count, guys? What was the number of rows that we had? I'm not speaking of the duplicate, the actual data. So 14,999 minus 3,008. Okay, it is 11,991, right? Now we have deleted with our duplicate rows. Now we can see we are having exact 11,991, right? Clear now? Is it clear? Got it? Yes, good. Now we'll go with the correlation. Okay, what is the function that you use for the correlation? You guys tell me. CORR. Okay, we are getting this warnings. Okay, for warnings, what we will do? We do have to import the warnings. Okay, let us import here only. Okay, just ignore the warning, guys. But if you want that not to be reflected, you can just import warnings and warnings dot simple filter to ignore. Okay, remember, if you're getting any warnings like these, guys, okay, which is negligible, but still, if you don't want these kind of warnings, what you can do, you can just import this warnings, provide warnings dot simple filter ignore. Okay, now just run this particular shell. Is the spelling correct? Okay, filter spelling is wrong. Okay. Okay, now it is done. Okay, simple filter also works fine. Even the filter warnings also works just fine. Just run that particular shell. Now come back over here where you was getting the error. Just run this particular cell also. Okay. Yes. So you can see the data that we are able to see here. Yes, satisfied. Okay. What do you mean by correlation? Yes. Now if you observe over here, okay, satisfactory and satisfactory, we do have 1. Yes. Last evaluation is 1, and same goes with the other diagonal data. Okay, it is all 1 over here, right? And remaining you do have negative correlation and positive correlation, right? Yes, heat map also works with the same. Okay, I'll come to heat map. Okay, now do you want to mark this by heat map? Yes. Now let us go and mark it, comma. I will give the color of this to be in the greens. Can you see we are getting this correlation through heat map, right? Yes, and larger the number, the brighter the color is. Okay, if you see over here, 1 is the maximum number, right? The diagonal number that is reflected is 1. So in here you can see the dark shade, that is 1, right? Okay, the larger the number, the brighter the color shade, that's it. Now here you can see there is no numbers present in here, right? The markings of the values. Yes, you don't have the values, right? And not very good, Pratyush. Yes, very good, Vapita. So what we do, we make use of a not function over here, a not attribute, sorry. So a not is equal to true. Now can you see the labelings or the markings in this particular heat map? Clear with this? Now before going with the visualization, let us visualize some or analyze some data. Okay, directly most of you had provided direct visualization. See, now we are coming to the visualization. Basically, why the previous process directly, why didn't we jump into this process? In the sense, we might have some data, okay, with duplicate records or values. So to find out that, we are supposed to do some task, okay, some limited number of tasks. So that is the reason we went with the EDA concept, then we came here. Okay, yes. Now data visualization, in the sense, we are going to analyze different feature. So basically, if we are not going with this data cleaning procedure, in the sense, it will mislead our whatever the predictions that we are doing, interpretations more specifically. Yes. Okay, so let me go with the variable FTR. Okay, what are the features that we can majorly take up in here? Okay, now say for my understanding, just a minute, which might be the very first factor. So can I consider that number of projects? Okay, based on these factors, I will plot with my graph. Okay, my predictions I will do with number of projects, because that plays a very major role, right? Don't you think so? Satisfactory level last evaluation is not that important, because until and unless employee is having a good contribution to the company, he's an asset, a very good asset, right? Whether he's having a good connection with his manager or with the TLs, that is the secondary. Okay, if he is having a more knowledge and if he is a very good asset, if he's contributing something to the company, that is very more important, right? Don't you think so? So I won't be considering, see, as per my assumption, I don't think so satisfactory and last evaluation is that important. Okay, so I'll go with the number of projects. Next, should we consider with average monthly hours? No, right? Because see, average monthly hours, if you're taking, it might vary from person to person. Now say some employee has met with some accident, major accident, and he's supposed to take some off, okay, some leaves for some certain duration until he recovers, right? So we cannot consider with average monthly hours. Ethically, it is not right. No, right? Average monthly hours I'm speaking about, because it is not the right way to do the proper predictions. Okay, as I mentioned, this might be the reason. Okay, now time spent in the company, is it important to take the time spent in the company? You guys tell me, is it important time spent in the company? Yes, we are gonna go with the left only with respect to, yes, average monthly hours is important. But now say due to some personal reasons, okay, the employee might have taken a long duration of leave, right? A very minor, yeah, small number, but still, yes, as it is related to retention, I don't think that we should be considering with this average monthly hours. Okay, yes. Now I will go with the time spent in the company, because it is very important, okay, to check like what is the duration that the employee was present in that company. Okay, what is his contribution in those many years? Next, work accident. Okay, we'll consider with a work accident this time. Let me take 6 datas. Okay, now say work accident, because if he is not happy with that particular team, definitely he might be willing to switch. Okay, that might be the issues. Okay, then we'll go with the promotion in the last 5 years, whether he's been given with any promotions or not. So we'll check with that. Then why is not other data reflect? Yes, then we go with the department and with the salary. Okay, whether he wants to switch to the other departments, and with the salary, whether he want any appraisal or something. We'll just look into that. So I'll just take 6 data, guys. Any 6 data if you are looking for, you can just go ahead with that. But based on my predictions, okay, I consider this 6 variables to be the major factor. Okay, if you want, you can go with the other variables also. Okay, I'll just take as of now with the 6 variables. Is it clear? Don't be confused. If you want to go ahead, you can take other variables as well. So this is my major variables or the factors. We'll go with the subplots. Okay, let me type the entire code, then I'll explain with that. Will that be okay? Because if I start explaining now, I might miss out something. So let me type entirely. Yes, guys. So here what we are doing, yes, Pratyush and Poonam. Okay, yeah, with the spelling. See, I'm very bad at spellings. Okay, I might miss out. So yeah. So yes, we are going to plot the subplots. Okay, why subplots is used? Because we're going to plot multiple plots. Okay, you can see over here we do have 6 graphs. Okay, 6 plots. So that is the reason we make use of the subplot function. So when you are studying in this document, you will get this doubt. Okay, why subplots is used? To plot multiple plots, we make use of the subplots in here. Okay, yes. Now what is this enumerate? Okay, figure size, you can mention anything. I have just mentioned with 20, 25. If you want, you can go with even more larger number also, but this is the standard one. Okay, if you want to increase or decrease, you can go ahead with that. Yes, Anita, I'll come to that. So why enumerate function is used over here? Okay, if you see in the for loop for the iteration, usually we go with the only one variable, right? Yes, for I in range or for I in so and so, right? Have you observed that in the iteration we always provide one variable? Yes or okay? What do you mean by enumerate function? Now say I'm having a is equal to 10, 11, 12, 13 and 14. Okay, now for I comma j in enumerate, in the sense we are going to have some index value for the values that are present here. So print I comma j. Can you see we are having this index value for the data that we are having here, right? Yes, enumerate function in the sense when we are making use of 2 variables where one will be with my data and another will be holding with the index values. Okay, we go ahead with the enumerate function. So don't be confused why we are using enumerate function over here. Okay, clear now? Yes. Now we're going to plot 3,2. Okay, why we're going to go with 3,2? Because we are having, if you see over here, okay, this will be 1 graph, 2 graph, 3, 4, 5 and 6. Total 6 graph. 3 rows we are having, that is, this is 1 row, this is 1 row and this is 1 row, and 2 columns, right? Exactly. Okay, can you see 3 rows and 2 columns? So that is the reason 3,2. Why p plus 1? Because we are going to plot 1 by 1. Okay, after one plot is done, it should iterate and go to the next. Okay, 1 by 1 the graph should be plotted. Now, adjust horizontal spacing. Anita, you want me to explain with enumerate? Enumerate in the sense with the index value. Now say whenever we are passing with the two variables, I have provided this data, okay, and this data will be stored in the J. And in I, what we'll be having? We'll be having the index value. Can you see the index values from 0, 1 to, right? Understanding? Whenever you're making use of enumerate function, in the sense, one variable will be containing the index value and another with your data. Got it? Okay, Anita. Okay, now horizontal spacing. What do you mean by this horizontal spacing? Okay, the space that you're having between these two graphs. Now, what is the difference? Now, this is the difference, right? Okay, now what I will do? Here, I'll mention with something like 3. Can you see the difference between the two graphs? Yes. And the graph size is also decreased because the space, horizontal space has increased, right? Let us come back with 0.5, okay, which is the good size. Can you see? Yes. This is just the spacing between the graphs from the different rows. Okay, got it? Don't get confused. Whenever you're studying, you'll get this doubt. Why we are using this head space in the sense horizontal space? Why so? Because that is the difference or the gap between the other graphs. Like in the first row, whatever the graphs you're having, the space after first row's graph, okay, for the second row, the gap is nothing but the head space you're providing over here. Okay. Yes, you're going to plot the graph with respect to the left, right? Yes. Left in the sense people who are leaving or about to leave, right? So I'll go with the with respect to left over here. Okay. And what is this? X-axis rotation is equal to 90 degree. Let me remove this. Can you see the data that is in the horizontal, in a vertical way, right? Yes. Can you observe this? Now I have removed this. I'll run this. Okay. Now, can you see it is in a horizontal line in the same line? And can you see it is congested, right? It is overwriting as well. So that is the reason I'll mention that to be turning that plot that is in the x-axis, whatever we are having, okay, to be rotating that to a 90-degree angle in the sense in a vertical way. Can you see now it is more presentable, right? Yes, now the labels are in the 90-degree.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Today, what we are going to see is understand the usages of Excel, what can be done in Excel, and see the important metrics and get started. Excel is a spreadsheet application. Basically, spreadsheet application is simply nothing but handling tables. It's an application that can help us to handle tables very efficiently. Now you can ask me, why do I have to know a spreadsheet application? I can use database, I can use different other tools to process data. But the point is, there is no tool that is as flexible as Excel when it comes to perform data cleansing, data analysis, data visualization, even automation at times. So it is one-stop shop for all the data related activities in real-time world. There is a very common saying in IT that Excel is the most underrated tool, but Excel is actually the most widely used tool as well, because it can do a lot of activities. In general, what happens? A company runs a business. Through business, we generate data. Once we generate data, what we need to do? We need to do two tasks with the data. First, we need to store the data and we need to perform calculations to understand the data. Correct? Excel lets us to do both of them very efficiently. Okay. So that is another main advantage of using Excel. After storing data, if I want to perform calculations in the form of visualizations, in the form of formulas and functions, in the form of automation, everything is feasible with Excel. So what we will do is we will see how does the spreadsheet application look like. Let's connect to some data tables. Let's perform some sort of activities and understand how efficient it is to answer it. So I have launched and spread the Excel. This is 2019's Excel. You can just go to File ribbon here and then choose the account option. It will tell you what type of software you're using. I'm using Microsoft Office Home and Student 2019. Any version less than 2013 may not support all the functions that I'm going to show you today. Please ensure that you use anything above 2013 of Microsoft product to perform all the tasks that I'm going to show you. Now, let me walk you through the interface first before directly jumping into tasks. Here, these are all ribbons. The top one are the ribbons, and this is called the spreadsheet. And these are column headers, A, B, C, all the way till something is there. And these are the row values, row numbers basically. And we have the sheet name. And yeah, I guess this is good enough for now. Okay, maybe this one is required. Formula bar and basically our cell editor. Let me choose a different color. So this is our spreadsheet. We are going to store data in the form of matrix. What is matrix? Matrix is simply nothing but rows into columns, right? In school, we have seen this, right? 1, 2, 3, 4. We have row 1, row 2, column 1, and column 2, correct? In Excel, if you see the entire spreadsheet, it is in the form of a matrix only. Only 2-dimensional data can be stored in Excel. You cannot store 3-dimensional data or more dimensional data. Only in rows and columns we can store it. Now, if I store something, the next important question is, how do I access it? Now, if I have cash, how do I spend it? How do I access it? Correct? If I'm going to save my cash in a bank, how do I access it? Through debit cards, through credit cards, through multiple channels, right? Similarly, if I store data in Excel, how do I access it? It becomes very complicated when we have large volume of data. That's why the indexing of columns and rows is provided to us. So these are column headers. The column headers are always denoted in alphabets. It has 16,600 change columns. That is the total number of columns available in Excel. In terms of rows, it can handle only 1 million records, 10 lakh, 64,000 some change rows. Only these many rows are available in one sheet at a time. So everything is stored in the format of spreadsheet only. Okay, it is just important to understand that. So if I want to access anything, suppose say for an example, I am writing a value in this particular intersection of column I 11th row. So this is called as a cell. The intersection of row and column is called as a cell. Okay, there are plenty of cells here. I'll just show you the number of columns that are there here and the number of rows as well. Now, if you see the number of rows, there are 10,48,000 rows it can handle. Basically, only 1 million record can be handled or stored in one sheet. But in an Excel file, we can create and store data in as many sheets as possible. Okay, we can store it in multiple sheets. In terms of columns, let me show you the number of columns as well. You see here, 16,384 columns are there. So if you take 16,384 columns with 10,48,056 rows, the number of data points that can be stored is these many. I guess this is more than 1 trillion data points that can be stored in one single sheet. But this is just theoretical. Okay, Excel says that it can handle all the way till 16,000 rows, 16,000 columns, and 1 million records. But in real time, what happens is, this is actually the only drawback of Excel. There is no other drawback for Excel. The only drawback is it becomes very slower as we start storing more amount of data, huge volume of data. That is the only drawback. But we do have several work around to handle that as well. But apart from that, it is the best tool for storing data and performing calculations. So now let's do some activities, some sort of exercises. What I'm going to do is I'm going to open some sort of data set. I have kept 3 data sets. So I'm just going to take, say for an example, property order product might be, and perform some sort of activities for you. If you see this Excel file, it contains 3 sheets in it: property info, products, and order details. In products table, we have product related information. In orders table, we have order related information. And in property info table, we have property related information. But in a business, so if I assume that, I wanted to retrieve the product name for this particular order. If you see in this table, I don't have product name. I just know that the order ID is 1. It got sold on a particular date on a particular property ID. I do not know what location it is. The proper product ID is also there, but I do not know the product name. Quantity is there. I do not even know the price of the product. If I wanted to retrieve the missing information, it is there in the mapping table, products mapping table. I have the ID to which I have the name, category, and price. What if I wanted to, retrieve these informations in the first table? So in this table, I want to know what is the name, category, and price for every single product that have been placed orders. There are 5,000 orders that have been placed. All these activities are really critical in real time. The most important function is VLOOKUP. Okay. There are plenty of functions in Excel. Excel is super familiar for allowing us to do a lot of calculations. You see here, I can perform different automatic aggregation functions, the recently used functions, financial functions, logical functions, text-based functions, even engineering-based functions, cube-based function. There are plenty of functions that we can actually use to retrieve or generate a value. Here, to retrieve a value, product name for a particular product ID that is present in a different table, I can use a simple lookup function, which is VLOOKUP. I say, for this particular product ID, I want to know what are the names and the category of it. So see here, that's it. As soon as I'm done writing the formula, it gives me the product name for every single order. Now I don't have the category, right? So I'll simply retrieve the category by just tweaking the formula a little. That's it. That's all I have to do. It retrieves me the product categories. And again, if I tweak the formula a little, I can retrieve the value of each and every product as well. So for every single order, I was able to retrieve the product name, the product category, and the price of that product from the product mapping table. Okay, using a simple function. Now I have all the information here. But see here, there is one information that is missing. In this business table, I have the quantities, the number of quantities that I've sold in business on a particular order. And I also have the price for that particular product. I do not have a sales column, the revenue column basically. Okay. If I wanted to generate a revenue column, it is simply priced into quantity, right? So the number of products that I've sold for a particular price gives me my revenue. So I was able to retrieve that, calculate that as well, just by multiplying price into quantity. It cannot be more simpler at all. Again, this is not to help you understand the function. It is just to show you the capabilities of Excel. Okay, so just don't try to try to understand the logic behind the function. All I'm trying to show is how easily a problem can be solved using Excel. Okay. Next, now in this case the data is present in vertical axis, so it was easy for me to retrieve information using VLOOKUP. What if I wanted to retrieve data that is horizontally present from top to bottom, right? I can use a simple HLOOKUP. I can use match index. I can use XLOOKUP, dget. There are plenty of lookup functions that we can actually use to look up information. Okay, XLOOKUP, index and match, VLOOKUP, and HLOOKUP. So for HLOOKUP also I can give you some sort of example. Okay, the data is very good here. Let me do one thing. I have an Excel file where there are 100 exercises. So I guess I can take that to walk you through HLOOKUP as well. Now this is not 100. Just a minute. This is VLOOKUP. I don't have an exercise for HLOOKUP, I guess. Maybe we can take this VLOOKUP exercise and perform HLOOKUP in it. It's not a big deal. Let me just copy it. and put it in our existing table, just copy pasting it. And I have the commission values. So this is VLOOKUP because the data is present vertically. Now, if it is present horizontally, what will happen? Now I have sorted data in horizontal axis. Let me do the same thing here as well. Perfect. Okay. Now let's remove this. If the data is present horizontally, how will we retrieve the values? For that, we can use HLOOKUP. But trust me, in real time, we will not use HLOOKUP. It's always VLOOKUP because the data is never present horizontally. It is always present vertically only. Now see here, the example here is I wanted to provide commission percentage for commission dollars for every single sales representative based on the number of customers that they have served. If the number of customers that they have served is between 0 to 60 customers, then we'll have to provide them nothing. If it is more than 60 customers that they have serviced, we'll have to give them $50 as an incentive. So I have to retrieve this information, incentive or bonus, I would say, for every single sales representative. Since the data is present horizontally, we will use a simple HLOOKUP. So the value that I'm looking for is this, and it is present in my second row, and I have an approximate match only, not an exact match. So see here, it has retrieved me the values. Now see here, Align have serviced more than 60 customers. If a particular sales representative have serviced more than 60 customers, they must be given $50. See here, so the bonus for Align is $50. Carol, on the other hand, have serviced only 22 customers. Between 0 to 60, they will get nothing. So see here, there is nothing for Carol. If it is more than 90, it should be 75. Gianna has serviced more than 90, so she gets $75 as bonus. So the idea is, even if the data is present vertically or horizontally or in any other position, we will still be able to perform the task just like that. That is the agenda here, not to help you understand the problem, the logic behind the functions here. Okay, it is just to show you how easily things can be achieved. So VLOOKUP, HLOOKUP, index match, and all those things. The next, apart from functions and formulas, the other important aspect of Excel is pivot tables. So pivot tables are very, very critical in helping us understand the granular level data just by summarizing it at a particular level. Now, what am I saying is, see here, there are 5,000 orders that have happened in the business. Assume you are running a business. In a month, you have generated 5,000 orders. Now, how will you understand what happened in your business? Well, the only way is going through every single line item and see what has happened. But as human beings, we will not be able to remember every single information around this 5,000 orders, right? So the easiest way to understand the data is to summarize it, to aggregate it at a particular level. To perform pivot table, we can go to insert and choose pivot table, or we can use Alt+V. Alt+V is a shortcut to do it. Now see here, this is the range. I'll just create a new sheet where I can show you the summarized information. This is pivot table fields. See, for an example, I wanted to know under every single category, how much sales have I made? Okay. So I'll simply drag product category into rows and simply drag revenue into values. That's it. That's all I've done. Just drag category into rows, revenue into values. Automatically it gives me the sum of revenue in furnishings is this much. Housekeeping is this much. Maintenance is this much. Office supplies is this much. Public areas is this much. And this is the overall revenue that we have earned so far in the business by selling in 5 different categories. If I wanted to know what is the date in which these orders have been made, I can drag and drop it in rows or columns as well. But again, it is too granular, right? The idea is, if you see this table, if you see the order details table, we cannot tell what was the total revenue under every single product category by ourselves, except that we can put it into a calculation and generate it. Maybe just to show you the power of pivot table, what I'll do is, here I can retrieve the same information from the table without using a pivot table also. But see, for that, what I have to do, I have to write a little complicated formula. I have to use sum ifs, then I have to say my first criteria is product category, and this is the one. Okay, that's it. I have to write such a lengthy formula in order to retrieve the same values as I have retrieved in a pivot table. 533479, 533479 is what we have. So we can retrieve the summarized information as well at a particular aggregated level using formulas, or without even writing formulas, we can achieve them through pivot table. We can change this in multiple ways. If you see the value field settings here, I can just see the total number of orders that have been placed under every category. Maybe I'll just show you one more information. I'll just add one more thing. The first one, I'll change the value field settings. I'll count it, and then I'll simply say number of orders. Then the second one is, I'll just keep sum of revenue only, total revenue. I'll just change it into total revenue. Then I'll say, what is the percentage share as well? I'll simply say percentage of row total. And I'll simply say percentage share. Let me quickly change this into column values. Perfect. Now see here, by selling 1,368 orders out of the 5,000 orders, furnishings category was able to generate 2,26,000 as revenue, which is 42% of the overall business share, right? So it is very simple. All we did was, from the granular level data, build a simple pivot and understand the entire business. Now, even if you think this is a little complicated, what we can do is, we can retrieve only select information and put it into a chart. Even better, right? We can put it into a pivot chart. Maybe I'll put it into an what is our pie chart? Okay, since there are plenty of information, just going to copy this, paste it as values, and the same thing, place as values. Okay, now let's chart this. Now let's visualize this. It becomes even better. We don't want grand total. We just want a title to the visual. I'll say category, and then let me go to insert charts. Let's build a donut chart or a pie chart. Donut chart is my personal favorite, so I'm simply going with it. So see here, we'll just add the data labels also. Just by seeing the visual, I can clearly tell public areas is generating more business. Sorry, furnishings is generating me more business than any other categories of business. Looks like 6 and 9. What are 6 and 9? Office supplies and housekeeping are actually not generating a lot of business to my, lot of revenue to my business. So all we did was, we cannot understand the granular level data all by ourselves. So we built a simple pivot and was able to visualize the information and understand the business. This is the overall idea. Not just we can perform calculations and visualizations, we can also cleanse the data in Excel. Data cleansing is the most important part in any project. So data cleansing can also be done very efficiently in Excel, right? So I'm just going to keep this sheet as it is. Okay, for data cleansing, let me do one thing. Save this file. So this particular file will have a lot of errors in it. Might be, see here, there are a lot of nulls in it.
Let's have a quick quiz question, guys. And the question is, what is the purpose of A/B testing in data analytics? And your options are to compare the performance of two different statistical models, or to determine the statistical significance of a hypothesis, or to assess the impact of change or intervention on user behavior, or to validate the accuracy of data before analysis. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Maybe I'll just zoom this in a little. So let's write some sort of values here. I'm just writing this. Say for an example, I wanted to remove extra white spaces. I can use a simple trim function to remove the extra spaces. If I wanted to split this into two columns, I can split it just like that. Maybe I'll split it here. So all sorts of data cleansing is feasible in Excel just by using certain techniques. So almost all sorts of data cleansing techniques can be applied in Excel just like that. So data cleansing, data analysis, data visualization, everything can be done in a very efficient manner using Excel. And these are very, the general tasks that we do in real time. Apart from this, it is also known for its capabilities in helping you to perform automation. Automation can be done in two ways in Excel. Say for an example, you are performing data cleansing. Again, every month you might receive new data. You don't want to manually redo the same data cleansing every now and then, right? So what we can do is we can use Power Query, which is a component of Excel, through which we can automate the data cleansing completely. It is more or less like your proper ETL tool. Okay, ETL tools are simply nothing but tools that are helpful for performing data cleansing and automate it. Okay, say for an example, okay, let's take the same data set and perform data cleansing in Power Query. So I'll just say under data, I'll choose from table or range. Just say okay. It opens a new tool window. Okay, this is called as Power Query. It is a part of Excel only. Knowing Power Query will help you a lot because you can learn Power BI through it. Power BI contains Power Query as an ETL tool. Say for an example, I don't want order ID column anymore. This column is useless. If I remove this column in this month, next month data also, it should be removed automatically, right? So I'll simply right click and remove it. See in the applied steps section, we see that there is a step called removed columns is captured. So what happens is anytime new data comes in, these steps, the source, change type, remove columns, all these steps will get applied on the new data set, and the new data set will also be cleansed before it is given to you for performing data analysis. Here, if you see order date column, it contains time also. I don't want time, I just want the date. So I'll change the data type into date. It is captured here. It says that it is changed data type. Again, I may not want what I would say. I don't want product ID, property ID, only two IDs, right? I don't want these ID columns anymore. I'll just remove it. And I'll rename the sales column in capital sales, or say I would like to keep it as revenue, price, quantity, order date. Perfect. So we have all the required information. What if I wanted to give a serial number to every order? I can do that as well. Add column, index column. Let me just quickly remove that and then say it should start from 1. And then I'll quickly pull it to whatever action that I did here gets captured in the form of steps. So automatically when a new data set comes, all these steps will be applied on top of it so that you don't have to do the manual work of data cleansing. Once you are done, what I'll do is I'll simply close and load. So automatically it loads the updated data in your Excel only. It doesn't load it anywhere else. So we have the latest data, cleansed data from Power Query that is generated into Excel. So performing automation of ETL workflows can be done using Power Query, or it can be done using VBA as well. Okay, VBA and macros. So this visual basic application is something that is very helpful in performing redundant tasks. Okay, so whenever you are doing the same task again and again, if you feel like automating it, we can actually use VBA. It's a programming language. Okay, VBA is a programming language that we will use to automate certain tasks. Okay, those automated scripts are called as macros. Okay, macros is basically the script of VBA. Now it is a traditional programming language. The disadvantages, it's a traditional programming language. What do I mean by that is it is not very easy to understand, but it can be learned. It is not that easy as Python, but it can be always learned. Okay, it's a traditional programming language, so we have to write a lot of syntaxes to achieve certain tasks. I'll just give you the overview of it. You have to choose developer ribbon. This may not be available to you by default, so you have to go to file and then choose options. And if you see the customize ribbon option, this might be deselected by default, the developer ribbon. Just select and say okay. Automatically the developer ribbon will open. Here you can write programming, the macro script, the VBA script, or you can ask the machine to record an action. So what you can do is you can just click on record macro and then perform a task. Once the macro is saved, if you run the macro again, it will redo the same task without even you scripting anything. For an example, let's do one thing. I'll create a new file. So here in developer ribbon, I'll just say use relative references means on what cell what action is done. So in cell A1, I'm going to perform an action. It will remember the cell position also. Okay. So I'll say record a macro. The shortcut is Control plus E. I'm just giving a shortcut. Just saying okay. Here I'll say name marks. Okay. So what I'll do is 65, 66. I'm just writing some sort of formula. I'm intentionally doing this. Then I'll generate some random marks between 10 to 100. This is randomly generated. Now see what I'll do. I'll do some sort of formatting. I'm using a lot of shortcuts to do that. Now I have created a table, right? Now assume in every sheet I wanted to create a similar table. All I have to do is, since the macro is getting recorded, I'll simply say stop. That's it. All I have done is stop. Now see here, I'll go to new sheet. Look at the sheet. The sheet is not as formatted as my first sheet. But however, if I simply go to macros and run the macro that we have already recorded, it will create a very similar table to what we have. In A1, I just say run this macro. See here, it has created a macro, but the formatting didn't work as properly as planned in the first sheet. Once we work on proper formatting, it will work as well. So the point is, you don't even have to write a macro or know the programming language. You can perform a task and ask the machine to capture the steps. Automatically, those steps can be retrieved here. Looks like there is some sort of issue in the sheet. Just remove this. I'll create a new sheet. The shortcut is Control E. I'll press Control E. See here, I guess there is some sort of issue with the way that it got captured as well. If you want to tweak the macro, you can do that as well. Click on macro and just say edit. It will open the editor for you where you can edit the VBA. Here it is filling down and end with selection borders inside horizontal. Okay, here it is. Okay. See here, this is what VBA is. This is a programming language of VBA, and whatever action that we did, it got automatically captured and converted as a programming language. To open the VBA editor, you can press Alt F11. It will open the editor, and you can just close it. In that, we can write a program as well. Maybe I'll write a simple program for you. Manually to write a program, I can just say in this sheet, let's create a program. So the subject is hello. I just wanted to run a message box that will say hello world, welcome to Intellipaat Excel webinar. That's it. All I have to do is save it. Like I don't even have to save it, just close it. Now if I run the macro, so let me run the macro. Macros start. If I run, it will simply print a message for me. It says, hello world, welcome to Intellipaat Excel webinar, right? See here, hello world, welcome to Intellipaat Excel. So the point is, we can automate a task, we can perform an activity all through macros so that we don't have to redo it again and again. This is about the introduction to webinar and the formulas and functions. We can also build excellent dashboards using Excel. Most of the companies, even today, use Excel reporting very vividly for understanding their business. Okay, I happen to have built a very good dashboard using Excel. I can walk you through that as well. I can just walk you through the features as well. They're very interactive. Excel module dashboard. Yeah. So this particular Excel file will show you the process, complete process. Let me don't save it. Yeah, perfect. Now this is exactly what will happen in your real time. See here, you have huge number of columns. If you see the bottom here, it says 22 columns are there in this table, and there are 10,000 rows of record. Okay, if I have so much of data, how can I understand what happened in my business? So it is the most important question. As we can see the data here, it is very clean and properly formatted. So I have done this from collecting data from 3 different sources. Okay, 3 different Excel file. I collated it as one Excel file to create one large table for me. But the problem here is I cannot understand the information here. So what we will always do is, okay, this is our source data. We will always pivot it to see the high level information. If you see the second sheet, it is basically called as data analysis, simple data analysis only. I can see how much sales have been generated by each and every shipment mode. Again, in each and every category, how much sales have been made within each and every segment, how much sales have been made are generated within each and every region, how much sales have been generated. Again, by subcategories, we are just saying the sales. Even though the data is at a very high level, okay, it's aggregated at a particular level, it is still too much for us to understand, correct? It is still too much for the business people to sit and understand every single data point. So the easiest way is to build a dashboard, is to build a report. We will call it as a dashboard or a report. Just by seeing the report, anybody can understand what happened in the business, right? If you see your consumer products are actually, consumer segments are actually generating more revenue than the other two segments in business. Technology categories outperforming the other two categories in terms of sales. In terms of region, all the region seems to perform better except for South. Here, the South region is not generating so much of sales, but apart from that, all the other regions seems to generate good amount of sales. In shipment mode, standard class delivery is what people prefer than the other class deliveries. First day, same day delivery, second class delivery, and first class delivery. People don't prefer a lot. People generally prefer standard class deliveries in a business. In terms of subcategories, I can clearly see chairs and phones are actually generating more revenue than majority of the products. Whereas fasteners, envelopes, art, supplies, labels are generating, are producing very poor revenue in the business. And the good thing is we can also see the same information by applying slicers. Say for an example, I just wanted to see what happened in Kansas state. Only in Kansas, I wanted to see what is my business. I can click on Kansas. See here in Kansas, home office is performing better than the other two categories. The standard class shipment mode are much more in Kansas than in other things. In terms of category also, office supplies is performing than technology. But if I deselect it, I can search for a different state. Say for an example, I would like to see what is happening in Washington. Just click on Washington. The entire table talks only about Washington. So it is super easy and cool for the users to understand what happens in the business if it can be visualized and filters can be provided. For certain customers, we can see the customers starting with A, how much sales have they generated, what is the overall trend and all those things. So this is how it will be in real time. You will collate data from multiple sources. You will clean the data, create the final table, or you can keep it in multiple tables as well, and perform data analysis. Here I've just performed the basic analysis of just seeing sum of sales for all the different categories and then reporting it. Okay, these are basically the steps that we will do in real time. For data cleansing, we will use Power Query or VBA to perform automation so that we don't have to redo the same task again and again. And the macros are simply a technique that we will use in Excel to simply ensure that we don't do the same task again and again. Maybe, I guess I have a proper file for that as well. Just give me a second. I have month, I'll simply say date, and I have sales. Okay, 1 April. Okay, here I'll just say +1. Now allow me to demonstrate the importance of macros. Okay, I guess it's fine. Okay, this is for April. Okay, I'm just going to keep another file for March, another file for January. I'm just creating 3 different files. And this is how in your real time also your data works. 1st Jan. Okay, I'm just going to save everything. Excel module. So this is Jan sales. I have Jan sales. I just want to keep it somewhere. And I also have, this is for Feb. Okay, I'm just going to keep it for. Okay, I'm just going to keep it as Feb. So Jan sales I have, we're going to say Feb sales. Then I also had March sales. Sorry, sorry, what is this? This is for April. Fine, anything is fine, I guess, as long as I have 3 months of data. Perfect. Now, since I have 3 months of data, I wanted to perform, these are all simply business data, right? The business is going to produce you the same files again and again. But every month you're generating a new file. What if you wanted to perform a task on all the 3 files? In real time, you will have more than 10-20 files. Do you really want to do the same task in every single file? Obviously no, right? Say for an example, here I wanted to see, okay, the percentage of sales for every single day. Percentage of sales is what I need to calculate. This is what I need to calculate. So what I have to do, I have to divide this by sum of this, correct? For every single value, I have to do it. So I have calculated or performed this logic in one Excel file, but I have 2 more of the same files where I have to generate exactly the same task. I don't want to manually go there, create percentage of sales, and then generate these values one by one. Rather, what I would do is I'll create a macro. See here, I'll go to my developer. I'll simply say relative reference macro, and then I'll simply say it can be accessed by Control E. Then I'll say okay. I'll say percentage of sales, and then I'll say divide this by sum of, and then convert this into percentage. So I have done this in one file, right? I'll stop recording this. I'll go to the next file that I have. In Feb file, I come here and press Control E. See here, automatically it has generated me percentage of sales. All I did was press Control E. It will help us, the macro, the capability of VBA is to simply help us to perform redundant tasks without redoing it again and again. All I did was press Control E in this Excel file. I'll go to January file. In January file, we have it, right? Okay, I'll go to April file. In April, it is there. In Feb, it is there. In Jan file, did I do it? Okay, let me remove it from Jan, Feb. Okay, why Jan file is not coming up? Okay, see here. I'll press Control E, it works here. The Jan file is in the next screen. I was wondering what happened to it. See here also we don't have a third column, right? But see what happens if I press Control E here. That's it. Automatically it performs the same calculation here as well. So it is super simple to use macros and VBA so that a task, redundant task can be automated. But there are certain limitations using macros. It can work only in Microsoft products. You cannot automate all the tasks. There are certain limitations, but it solves majority of the data redundancy tasks that we will do in real time. Okay, could you please explain tools like Solver? Okay, so I'm not an application developer. It is used only for application development within Excel. So for data analysis and for handling data, you can ask any questions associated. It's good to see the overall capabilities in regard to possible ways to approach different problems. What are the tools generally used for data analytics? Depends on, there are plenty of types of analytics. It depends on what is the requirement that the tools will be chosen. For ETL, the general processing is data cleansing. For data cleansing, we will call it a process called ETL. For ETL, we'll generally use Alteryx. I personally use Alteryx Designer. We can use Informatica. We can use Power Query. I also use Power Query. It's very, very efficient and easy. We can use a Talend. So there are plenty of, and if you know SQL, that is enough. To be honest, if you don't have to know any of these tools, if you know SQL, we can perform ETL very efficiently. Okay, that is for data cleansing. For data analysis, what are the tools that we can use? We can use any type of SQL. We can also use Excel, pivot, and all those things. And most importantly, we can use Python for data analysis. And for data visualization, we can actually use Tableau or Power BI or ClickView, something of your choice. I guess this should work. If you know SPSS, these are all added advantages in data analysis, but I guess if you know either one in this, that is more than enough. Irvin asks a very important question. Where does Excel end and Power BI begin? Very, very good question, Irvin. See, even though I walked you through data visualization in Excel, it is not very interactive. It is not very dynamic. So in order to perform better reporting, Power BI comes into picture. But the good thing is, if you know Excel, Power BI is just walk in the park. If you go to the data ribbon, there is this component called Power Query. Okay, this queries and connections. You just need to know Power Query, and there is another concept called Power Pivot in Excel. Okay, Power Pivot and Power Query. If you know these two components, Power BI is nothing. Okay, Power BI is basically an extended version of these two things only. We will use Power Pivot to relate multiple tables. We will call it as data modeling, and we will use Power Query for ETL tool. Using Power BI desktop, we can perform visualization. It is super simple. But the advantages of learning Power Pivot and Power Query is that it can handle more than 1,000,000 records. Excel cannot handle it, but Power Pivot and Power Query can handle more than 1,000,000 records. That is the main advantage of using these two things. So whenever you have large data, and if you want to perform, build efficient reporting, blindly go with Power BI or a data visualization. And companies use all sorts of software. SAS is there, SPS is used, SPSS is used, R is used, Python is used, Julia is used, Scala is used. There are plenty of things. SQL, can you show demo? It's not part of this webinar, Hemant. I guess there will be a different webinar arranged for SQL. The idea is to show you the capabilities of Excel and help you understand that it is a very efficient tool for you to, it is a very important tool. I just cannot emphasize enough on the importance of Excel.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Okay, basically EDA stands for exploratory data analysis. That's correct. So it is a crucial step in the data analysis process where any analytics or data scientist, whatever profile you are choosing, is examine and summarize the main characteristics, pattern, and insights of the data set. So EDA help in understanding the data, identifying pattern detection, anomalies, and we can say that formulating hypothesis. Okay, I can tell you some objectives and benefits of EDA as well. Guys, if I'm talking about objective, data familiarization. Data familiarization means EDA allow analysts to get a sense of the data set. They are working with it. So it helps in the understanding the structure, format, organization of data, everything. Understand? Second, like we can say that data quality assessment. It is like EDA helps to identify missing values, outliers, and inconsistency in the data set. So it's enable the cleaning and processing, which essentially for the accurate analysis. Then data distribution. Guys, data distribution is like, okay, I can explain you about data. Like EDA provides insights into the distribution of variable. So it helps to identify the central tendency, spread, shape of data. So allowing analysts to choose appropriate statistical technique. Okay, like that number of methods we can find it from the EDA. Right? So like if you see any data sets, it's very difficult for you to find all the insights, right? So whenever you are finding the insights, so EDA is the best part. EDA is the best way to do. Importing the libraries and first look of the data. The necessary libraries are Pandas for manipulation, NumPy for mathematical computation, and Seaborn for Matplotlib and Seaborn, guys, for the visualization purpose. Okay, very good. So now, guys, now time to load the data set. So like I'm taking a variable named data. So data is equals to pd.read_csv. In this CSV, I'm going to my, wait, I will do one thing. I'm sharing my complete screen so you can visible all these things. So I'm searching, I'm downloading one of the games data set, VG Sales. VG Sales data set, load it here. And here I'm using R. So this is my data set. How to use Pandas? If it means till now you are only clearing, we are making a fundamental. right? This is the another step which we are taking it. If I'm giving you any new data set, how to find the insights. Tomorrow I will guide you one more step, like how to select the features. After that we start machine learning, because before machine learning we need to make one particular fundamental. So on that time it's very easy for all of you how the things are going in the machine learning. That's why EDA is very necessary. EDA is like the Python basics. Without Python basics, you miss NumPy, Pandas is very hard for all of you. Like that, without EDA, machine learning is almost impossible for all of you, because this is the first step of machine learning. So guys, now this is my data set. So first of all, if you are aware about your data set, then it's very helpful for all of you know how to proceed. So whenever this is the data set, the first column is rank. Rank means, guys, it represents the ranking of the video game. This is the video game data set. So ranking of the video game. So the column contain integer values, right? Then name. Guys, name is denoted the name of the video game, like Y Sport, Super Mario, Mario Kart, Pokemon, right? So it denotes the name of the video game. And this column is an object column, correct? Third is platform. So platform, it indicates the gaming platform or console on which the video game was released. So like Y, NES, GB. Then year. So guys, it represents the year when the video game was released. So this column is the float column. Then genre. So it specifies the genre or category of the video game. Then publisher. So it denotes that like the publisher or company responsible for the publishing this video game. Okay. Then NA sales. So it represents the sales of the video game in North America, like in millions of copies. NA means North America. EU sales. So guys, it represents the sales of video game in Europe. Okay, in Europe. Then JP sales. So guys, JP sales means in Japan. It denotes the sales of video games in Japan. Japan sales. First North America, second is Europe sale, third is Japan sale. After that, other sales. Right? In others, it represents the sales of video game in regions other than North America, Europe, and Japan. Right? And at last, global sales. So it indicates the total global sales of the video game. Data type, null values, column name, find the number of null values in each column. Guys, I can tell you, line by line, if you see it here from starting, first, how many rows, how many columns, correct? Name of columns, number of columns, right? Data type of columns. So 1, 2, 3, 4, 5. Then how many null values present in your data set with the help of not null values. How we know that? Like total 16598. So 16598 not null values are there. That means here if you see it 16540. So 16540 are not null, but total values are 16598. Correct? So if we subtract this, so we know that how many null values are present. Okay, so like this is 6. Sorry, 0, 0. This is 0. So 8 is there, right? 4. 9 minus 4 is then. So total 58 null values are there, correct? In this column. Like that, we know that how many null values are there. Again, how many float columns? So 6 are float columns, 1 integer column, 4 object columns, right? And the memory of your data. How much memory the data consume that. Because guys, whenever we are working with any of the programming language or anything, always remember time complexity and space complexity always matter. Okay, like example, if I'm giving you one of the task, tell me one thing like either you are getting the accuracy of any model or the time complexity. Which one you are choosing it? Accuracy or time complexity? Of course, we want both. Both are not possible in real life, guys. Like example, we need to compromise with one of them. So on that time, maybe some of you are compromised with the time complexity, some of with you compromise with the accuracy. Guys, it's totally depend on the client requirement, or we can say that to totally means as a student, if I told you, means as a working professional, I say totally depend on the client requirement. As a student, totally depend on the problem statement. Why I'm saying this, like example, time complexity and accuracy both are equally important. Example, I think all of you are aware about that when the in our phone, face recognition system will introduce, I think in 2013 or 14, face recognition system will introduce in our phones. So whenever we have, means on that time, guys, if you remember, if you show your photo to your phone, on that time also phone will unlock, right? Phone was unlocked. That means engineer compromise with the accuracy, but not compromise with the time complexity, because no one hold our phone in a front of face for 20 seconds, 30 seconds waiting for unlock the phone. Correct? If anyone play any of the game. So guys, you have seen it on that time. Sometimes like in PUBG, I think in the PUBG or any other games as well, if you see WCC3, one game is, I will see it. So on that is a cricket game. Sometimes it's clearly look it's 4 or 6, right? But it's showing different thing. But it's not compromised with the time. The way you respond, suddenly he must do some action. So on that time complexity is always matter, but accuracy is also equally important. Like example, I can give you the example of accuracy. Okay, on that particular platform, we are compromised with the time complexity. That is the payment gateway. Sometimes we are scan the picture and payment, like any payment we are giving. So it's showing ki wait for 30 seconds. In 30 seconds, your payment will confirm. Everyone patiently wait for 30 seconds, waiting for confirmation. On that time, what we want? Accuracy. Agreed, na guys? So whenever someone asking you these type of hypothetical questions, on that time, directly the best solution is to totally depend on the problem statement or client requirement. What actually client want. Now, so we know that how many null values, how many things are there. So then what to do after that? If in your data set, numerical values are there, we use mean or median to replace the object. Or in object, if objects are there, we use mode. That's totally correct. I agreed. But how we decide that we are using mean or median in the numerical data? Anything. I think if we are using anything, that's not correct, na? Guys, okay, I can tell you something. Now think it logically. Like if in your data set, like this is your data set, correct? So only 271 and 58 values are null. And your size of data set is 16598. 16,598 entries are there. So 271 and 58 are very nominal. If I want, I can directly remove it. Agreed, na? But the question on that time when I'm asking na mean or median. So guys, on that time, I personally prefer median instead of mean. Why? Because I want to tell you something. Like tell me one thing, like in your data set, like null values are there. So I can create one scenario here. Like 1, 2, 3, then null values, then 4, then null values, then 7, then null values, then 2, then null values, then 5. Like this is the data set, right? So how many null values we have? 1, 2, 3, 4. 4 null values. Total size is 3, 4, 5, 6, 7, 8, 9, 10, 11. Correct? If I'll add all of this column, 1 plus 2 plus 3 plus 4 plus 7 plus 2 plus 5. It's so 1, 2, 3, 3, 6, 6, 6, 4, 10, 17, 19, 24. Right? 24 by 11. No. Correct. 24 by 11, no? But it is correct because 1, 2, 3, 4. 4 values are not present. Akash, but 4 values are not present, no? So maybe logically, the way of finding the average is not correct. Instead of that, if I'm divided by 4, 7, on that time it's correct. But we are dividing from 11 for finding the average. So maybe it's biased, na? Shilpa, listen. Like total 1, 2, 3, blank, null value, null value, null value, null value, right? How to find the average? The formula of average is sum of all the numbers divided by the total number. Total number is 11, correct? But 4 are null values, na? Here in the time of on the time of adding, we don't have any value to add. But on the time of divide, we have considered this columns. So logically, it's not correct now to choose. So if we take 0 as well, right? We are taking 0, but average is misleading, na? Understand? So maybe means it's my personal choice. It's on you. If you want, you can consider average also, because most of the data analysts are using average as well. But if you are using here median, correct, on that time it's give you the more accurate result. Median. Why I am saying median? The way of finding the median is first sort your data. Then count 1, 2, 3, 4, 5, 6, 7. So 7 means this 3, this 3. 3 is the median. So we can take 3. And guys, and if I'm divide by this number as well, it's also giving me almost 3, 2 point something 18 almost, right? Because I'm taking from 11, that's why it's not that much accurate. If I divide the same number by 7, on that time the same result, the same thing is giving me 3.4. If you want, you can calculate it randomly. I'm choosing it, right? Means I can tell you logically, like if someone asks you, because whenever we are working on any of the project, we need to make one project report at last, right? So on that project report, we need to write it everything, why we are doing this particular thing and what inference I can find it out after this graph, after this thing. We need to create one particular report and submit it to the project manager or whoever is the lead on that time. Here, so right now, I think we directly drop it, correct? So here we're directly using drop NA, data dot drop NA. And one more thing, guys, if I'm talking about null values, so always remember, like if the values in any particular column, more than 60% values are there, no? More than 60% in any one particular column, we can directly drop that particular column. Or we can ask the client to give me the data, 60% values are null. Because if we replace the values on that time, we can manipulate our data. I'm not saying no need to use mean ever. Like if we have only 1 or 2 null values on that time, maybe if you consider it's not true back, it's almost the correct answer, right? But if you instead of mean, if you are using median, if you see the skewness, so on that time, majorly try to prefer median instead of mean. But it's totally on depend person to person, right? Now, so guys, if any column have more than 60% null values, you can directly drop the column or you can ask the client to give me the data. Because if you replace the values on that time, because we cannot drop 60% values, because we have lost a lot of data, and we cannot replace as well, because if we replace that data, that means we are manipulating the data. So we cannot replace it. Clear? Now, after that, guys, I'm dropping the null values in data. I'll store it. Data dot drop NA. So now 16291 rows and 11 columns. And if I'm checking the null values now, so 0 null values in my data set. No null values are present. So guys, but here if you see it in this data set, only integer columns are taking it. What about object column inferences? What is the descriptive statistics of object column? Of course, if you drop any null value, so of course that particular rows are removed, na? So it's changed in your original data set. Correct. Like if you drop majorly 271 plus 58 values are dropped. So that's why your data set shape is like this. It's directly dropped from your main data. Guys, what about the rest of inferences? What about the inferences of object column? Because I think Pandas is over, Matplotlib is over, and one time before, once your particular case study is also done. But if whenever you are finding the inferences, So we have all the objects, all the numeric and float columns are there, right? We have never, what about the object columns? 6 object columns are there, maybe, I think, if I'm correct. 4 object columns are there. 6 plus 7 columns are there here. 1, 2, 3, 4, 5, 6, 7. What about the object column, guys? No, a describe function is working from object as well. You need to only use one parameter inside it. Include object. So here, if you see it, count, mean, standard deviation. Guys, I will do one thing. I will transform it so it's easy to look. Now easily find. Like rank column, count of rank column, mean, standard deviation, minimum value, 25%, 50%, 75%. Correct? And the maximum value of the data set. Then here, minimum value, standard deviation, minimum, 25%, 50%, 75%, and maximum value of that particular column. Correct? Same here in the object column. We have 4 object columns.
Let's have a quick quiz question, guys. And the question is, which algorithm is commonly used for association rule mining? And your options are linear regression, k-nearest neighbors, a priori, or random forest. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
So see it. Name. Total count is 16291 and 11325 are unique. Clear? Like total how many unique names are there? 11325. And most repeated game is need for speed. Need for speed. Need for speed. Most wanted. Frequency is 12. Means 12 times this game will repeat it. Then platform. Total 31 platforms are there. And top are DS. DS is the frequency of DS is 2131. What is the major use of this? Whenever we are seeing this particular thing, how much inferences you can find it out? What descriptive statistics you have find it from here? Okay, whenever you are seeing this describe function, right? So see it first of all, you know that what is the count of rank function, right? Average and standard deviation, minimum, maximum, everything. Now, whenever in a box plot, like this is the box plot example. I'm making one box plot. So guys, this is your minimum value, right? Quantile 1, quantile 2, quantile 3, and this is the maximum value. This is your maximum value. Minimum, quantile 1, quantile 2, quantile 3, and maximum value. And this particular range, the range of this whisker is called as IQR. Correct? IQR. The formula which we are using it here to find the IQR is quantile 3 minus quantile 1. Without graph also it's visible here. We can find it. But my first I'm asking one of the question to all of you. Now tell me, most of the time in interview I'm asking the same question. Like this is your minimum value. This is your maximum value. Correct? So data set is in front of you. Like this is the rank column. Or like I'm taking year column. Any of the column, tell me. I'm taking that particular column. Whatever column you want. Like we are choosing North America sales column. Okay. 25% means 0, 0. Correct. So here I'm writing 0. 50% means 0 0.08. 0 0.08. 75% is 0 0.24. 0 0.24. Correct. Now, what is the minimum and maximum value here? In outlier, I'm asking. In this box plot. To find the minimum value, first we need to find the IQR. First, we need to find the IQR. So, to find the IQR, quantile 3 minus quantile 1. Correct? Quantile 3 minus quantile 1. So, guys, the quantile of North America is, quantile 3 is 0.24 minus 0.00. That is 0.24, correct? Now, to find the minimum value, whatever the value it is showing in your describe, that minimum value is your data minimum value, right? But your box plot minimum value, whenever you need to find it, na, quantile 3 minus 1.5 times IQR. This is the formula which we use to find the maximum value. Quantile 3 plus 1.5 times IQR. So what is the minimum value? Guys, 0.24 into 1.5 is 0.36. Correct? Correct, na guys? And 0.24 minus 0.36 is minus 0.12 minus 0.12. That means here outliers are there. Sorry, that means 0.02 is the minimum value. This one minus 0.12 minus 0.12. That means the minimum value is 0.00. That means, and here the value is 0.2. That means no outliers in the minimum column. Now time to check the maximum column. So 0.24 plus 0.36, that is 0.6. Correct, na? 0.24 plus 0.36, that is 0.6. So maximum value is 0.6. Understand? The maximum value is 0.6. And here the maximum value is in this data 41 point something. So of course outliers are there in this particular column. Understand, na? If you plot this particular column, definitely you're getting the outliers. Like here we can do that. Minimum, to find the minimum value, I can write it here, guys. To find the minimum value, right? Quantile 3 minus 1.5 times IQR, right? Wait, first I'll write it here. What is your quantile 3? Quantile 3 is Q3 is Q3 of this column is 0.24. Q1 is 0.00. And to find the IQR, quantile 3 minus quantile 1. Correct? So your IQR value is 0.24. Right? So now time to find the minimum value. To find the minimum value, quantile 3 minus 1.5 times IQR. The minimum value is minus 1.2. If to find the maximum value, quantile 3 plus 1.5 times IQR. Wait. 0.6. Correct? Till here is clear for all of you. So now if I'm making any box plot here, so guys, I'm roughly making it instead of, this is your 25% quantile, right? First quantile, third quantile, second quantile. Like it is defined value. Sometimes we can raise this value, but in Python, this value is previously defined. It is 0.5, 1.5. Okay, it's a predefined value. Actually, okay, I can tell you in more detail. Like the use of 1.5 as a multiplier in an interquantile range, right? Is a method for detecting outliers in a common practice of statistical computation. right? To find the lower bound, like minimum value we called as, here is a lower bound. Okay, lower bound and upper bound, right? So sometimes we can change it to 1.5 to 2.5 or anything, but it depends. This is the threshold which is predefined, like Z score. Like such as Z score is predefined, no? Same as here. Okay, so now here the minimum value is minus 0.12. 0.12. First quantile is 0.00. Second quantile is, whatever the value, third quantile is, we have decided the value, no? And this is your IQR, whatever the value. And IQR is 0.24. Means quantile 3 minus quantile 1. And your maximum value is 0.6. Maximum value is 0.6. Clear na guys? Now check the minimum maximum value here. Minimum value is 0.00, right? That means, and my minimum value is 0.12. Like that means in below lower bound, no outliers are there. Correct? But now time to check the outliers of upper bound. So the maximum value is 41.49 and my value is 0.6. That means there are a lot of outliers are present, right? In the upper bound. Okay, I will do one thing, guys. If all of you allowed me, or if all of you want, with the help of box plot, we need to check it, right? What is the actual value? Then it's clear for all of you, I hope. These are my answers. And if you see the same answers are coming box plot, then it's, guys, I can show you 2 box plot today. And the new one, I think I need to introduce in the front of all of you. First, whatever you are using till now, using the Seaborn. Box plot, data is equals to data, comma y is equals to my column name, NA, sales, right? My column name, PLT dot title, and here I'm giving title like box plot. Like guys, it's on you if you want to give. If don't want, no need. Of NA sales, Miss North America sales. Correct? Now PLT dot show. There are a lot of outliers, but in the lower bound, no outliers are there. But now it's not defined like it is 0.6 or anything else. Right? So one more graph is there, guys. I think no one knows about that. But if all of you allow, so I can introduce one more library is there, guys. The name of library is Plotly. So on that one, if you directly show it anywhere, normal library is there, guys. But you are getting more interactive graphs. You can see it here. I think I'm not aware, means I think it's not part of your content, but I can show you. It's a normal library. It's normal visualization and simple code, same like that. I mean, only try to import one more library name plotly dot express as px. Now figure is equals to, I'm using px dot box because I want to plot a box plot. Inside it, everything is same. Data frame is data and the column name is, guys, same column. No, so I am copy pasting it. Okay, now same here. Before that, I'm using title. Here instead of title, update layout. Update layout. Spelling is not correct. So here I'm using update layout. Title is equals to same. Same title, guys. I'm copy pasting it. Right, and here figure dot show, because here my variable is figure. This is the graph. Then all of you are saying this is same as previous one, but now see the difference. Quintile 1 is 0, upper fence is 0.6, right? 0.24 is the, and if you want to see the graph, no, so you know that the values, whatever the values are present in the same thing, all the values, each and everything is directly showing to all of you. Shilpa, range for what? Means the for showing the graph, no, like this. So it's depend on you. You can see it. I can increase or decrease the range, anything, whatever you want. It is the possible in this library. So zoom, you can see it now. I'll zoom it this in this. Before that's not visible, na. Now the range we can set it less than -0 also. Between 0 to 0.5. Directly with the help of a scroll, you can do that. Scroll up, scroll down. No, in SNS it's not possible. In Plotly it is. So SNS is normal picture. You cannot do anything. You can see it. SNS you can see it. This is normal like a picture, and here you can see the difference. Guys, every time we are not depending on the box plot, na. So now how to whenever means when how I know that in this particular column outliers are there? Why I'm choosing this particular column? So guys, there are some small tricks are there to choose that one. Okay, choosing the outliers or identifying the outliers. So it's seen in this graph, in the described one. So look the potential outliers based on the statistics. This is statistics. If the minimum or 25 percentile is significantly different from mean or median value, mean matlab average mean value, whatever the mean value is mentioned, median means 50% values. So if the minimum or 25 percentile is significantly different from the mean or median, it may indicate the presence of outliers on the lower end of the distribution. Then if the maximum of or 75 percentile is significantly different from the mean or median, it may indicate the presence of outliers on the upper end. And additionally, you can examine the standard deviation and interquartile range to identify the data points that are far from the mean or quantiles. So by comparing these statistics, you can get a rough idea about whether there are outliers in a data set or not.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
So now, coming to the first question, what are the steps involved in data analysis? There are several steps involved in data analysis. So now, talking about the first step in data analysis process is to define your objective. And in data analytics, this is sometimes called the problem statement. Now let's move to the second step, that is collecting the data. Once you have established your objective, you will need to create a strategy for collecting and aggregating the appropriate data. A key part of this is determining which data you need. This might be quantitative data or qualitative data. Moving ahead, the third step is data cleaning or pre-processing. Once you have collected your data, the next step is to get ready for analysis. This means cleaning or scrubbing it, and it is crucial in making sure that you are working with high quality data. Key data cleaning tasks include removing major errors, duplicates, and outliers. Also, it is used to remove unwanted data points and bring structure to your data. So now, moving ahead, we are having next step as data exploration. Data exploration is used to explore and visualize data, to uncover insights from the start or identify areas or patterns to dig into more. Next, we are having data modeling. Data modeling is the process of analyzing and defining all the different data your business collects and produces, as well as the relationship between those bits of data. The next step is data validation. Data validation is the practice of checking the integrity, accuracy, and structure of data before it is used for a business operation. And last, we are having implementation. So in this, we're going to implement our business operation. So these are the important steps for data analysis. So now, let's jump into the second question. What are the key differences between data analysis and data mining? Talking about data analysis, it involves the process of cleaning, organizing, and using data to produce meaningful insights, whereas data mining is used to search for hidden patterns in the data. Also, data analysis produces results that are far more comprehensible by a variety of audiences than the results from data mining. So this was the difference between data analysis and data mining. Now moving to the question number 3, what is data profiling? Data profiling is a methodology that involves analyzing all entities present in data to a greater depth. The goal here is to provide high accurate information based on the data and its attributes such as the data type, frequency of occurrence, and more. So this is all about data profiling. So now, moving to the question number 4, what are the top tools used to perform data analysis? So there is a wide spectrum of tools that can be used in the field of data analysis. Here are some of the tools. The first one is the Microsoft Excel. As we know that Microsoft Excel is used in major companies for the data analysis. Along with that, we are having Power BI, Tableau, RapidMiner, and many more. So these are the top tools that are used to perform data analysis. So now, let's check out the next question. What is an outlier? Outliers are the data points or observations that are significantly different from other data points because of their abnormal distance from the rest. Here you can see that in this graph, we are having the outlier present that is marked with an orange color, right? So as I told you the formal definition that outliers are the data points that are significantly different from the other data points. Here you can see that the data points are having some pattern, right? But this is an outlier that is significantly different from other data points. Now talking about the outliers, there are two types of outliers. The first one is univariate and the other one is multivariate. So this is the basic idea about an outlier. Now moving ahead, what are some of the popular tools used in big data? There are multiple tools that are used to handle big data. Some of the most popular ones are as follows. The first one is Apache Hadoop. Moving ahead, we are having Apache Spark, Apache Storm, Flink. You can also use MongoDB and RapidMiner. So these are the popular tools that are used in big data. Moving to the next interview question. What is the use of pivot table? So this is a question of Excel, right? So talking about pivot tables are one of the key features of Excel. They allow a user to view and summarize the entirety of large data sets simply. Most of the operations with pivot tables include drag and drop operations that aid in the quick creation of reports. So this is the idea about pivot tables. So now let's move to the question number 8. Explain different types of data validation techniques used in data analysis. There are many types of data validation techniques that are used today. Some of them are field level validation. Talking about the field level validation, it is done across each of the fields to ensure that there are no errors in the data entered by the user. The next one is form level validation. Here, validation is done when the user completes working with the form but before the information is saved. The third one is data saving validation. This form of validation takes place when the file or the database record is being saved. And the last, we are having search criteria validation. This kind of validation is used to check whether valid results are returned when the user is looking for something. So this is the basic idea about different types of data validation techniques. Moving to the next question, we are having what are the top Apache frameworks used in a distributed computing environment. So we already know that Hadoop and MapReduce are considered to be the top Apache frameworks when the situation calls for working with a huge dataset in a distributed working environment. So we are using here Hadoop and MapReduce for the distributed computing environment. Moving to the next question, what are the ideal situations in which t-test or z-test can be used? It is a standard practice that a t-test is used when there is a sample size less than 30. Now, Coming to the z-test, it is considered when the sample size exceeds 30 in most cases. So this is the situation in which we use t-test or z-test. When the sample size is less than 30, we use t-test, and when it is greater than 30, we use z-test. Now moving to the question number 11, what are the disadvantages of data analytics? Compared to the plethora of advantages, there are few disadvantages while doing data analytics. Some of the disadvantages are listed below. The first one is data analytics can cause a breach in customer privacy and their information such as transactions, purchases, and subscriptions. Moving ahead, some of the tools are complex and require prior training. So this is the biggest disadvantage of data analytics. And the last point, it takes a lot of skills and expertise to select the right analytics tool every time. Alright guys, it's time to move to the next question. Moving ahead, how can one handle suspicious or missing data in a dataset while performing analysis? So let's suppose if there are any discrepancies in the data, a user can go on to use any of the following methods. The first one is applying several strategies together to find missing values and using approximation if needed. Moving to the second point, user can replace the invalid data with the corresponding valid and up-to-date data. Moving ahead, it can create a validation report with details about the data in discussion. And the last point is that escalating the same to an experienced data analyst to look at it and take a call. So this is a way to handle missing data. Also, you can replace the value with mean, median, and mode. So these are the ways to handle missing data. Moving to the next question, what is the difference between the concept of recall and the true positive rate? So let me clarify you. Recall and the true positive rate are totally the same. Talking about the recall, recall is a metric that quantifies the number of correct positive predictions made out of all positive predictions that could have been made. So when somebody is asking you the formal definition of recall, you can say that out of the total positive, what percentage are predicted positive. Now talking about the formula of recall, it is true positive upon true positive plus false negative. Now moving to the question number 14. What is the simple difference between standardized and unstandardized coefficients? In the case of standardized coefficients, they are interpreted based on their standard deviation values, whereas the unstandardized coefficient is measured based on the actual value present in the dataset. So this is the difference between standardized and unstandardized coefficients. So basically, it is asking what are the ways or techniques that are used to detect outliers. So the first one is box plot. So we know that while using box plot, we can easily find outliers, right? The second technique is z-score, and the last one is interquartile range. So these are the techniques to detect outliers. Moving to the next question, what are z-test, chi-square test, f-test, and t-test? As I already told you about the t-test is used when your sample size is small, basically when the sample size is less than 30. Alright guys, so now after understanding what is t-test, now let's see what is z-test. So z-test is used for large sample. Basically when your size of the sample exceeds more than 30, we are using z-test. Now coming to the chi-square test, people used to pronounce it chi-square test also. This kind of hypothesis testing is used when there is a requirement to find out the level of association between the categorical variables in a sample. The test of significance is to determine the difference between observed and expected frequencies of certain observations. Now, moving ahead, we are having f-test. So in f-test, hypotheses of interest are about the differences between population means. So this is the idea about z-test, chi-square test, f-test, and t-test. Moving ahead, we are having what are the advantages of using version control. There are numerous benefits of using version control. Now let's see. The first one is it establishes an easy way to compare files, identify differences, and merge if any changes are done. Moving ahead, it creates an easy way to track the life cycle of an application build, including every stage in it such as development, production, testing, etc. It also brings a good way to establish a collaborative work culture. Along with that, it may ensure that every version and variant of code is kept safe and secure. So these are the numerous benefits of using version control. Moving to the next question, what is collaborative filtering? Collaborative filtering is an algorithm used to create recommendation systems mainly considering the behavioral data of a customer or a user. For example, when browsing the e-commerce sites, a section called recommended for you is present, right? This is done using the browsing history alongside analyzing the previous purchases and collaborative filtering. So this is the idea about collaborative filtering. Moving ahead, the next question is, what are the properties of clustering algorithms? Any clustering algorithm, when implemented, will have the following properties. The first one is hierarchical or flat. Moving ahead, we are having iterative, and the last one is disjunctive. So these are the properties of clustering algorithms. Now, moving to the question number 20, explain the term normal distribution. Normal distribution is also known as Gaussian distribution. It is a type of probability distribution that is symmetric about the mean. It shows that the data is closer to the mean and the frequency of occurrences in data are far from the mean. In normal distribution, mean, median, mode are equal. So this is the basic idea about normal distribution. Now, moving to the next question, that is question number 21. What is the difference between overfitting versus underfitting? Overfitting and underfitting are the two main problems that occur in machine learning and degrade the performance of the machine learning models. Now, talking about overfitting, it occurs when our machine learning model tries to cover all data points or more than the required data points present in the given dataset. Because of this, the model starts catching noise and inaccurate values present in the dataset, and all these factors reduce the efficiency and accuracy of the model. The overfitted model has low bias and high variance. The chances of occurrence of overfitting increases as much we provide training to our model. The more chances of occurring the overfitted model. For example, the concept of overfitting can be understood by the above graph of linear regression output. For example, you can see this graph. In this graph, the model is trying to covering all the data points. Hence, it results in the overfitting. Now, after understanding overfitting, let's see how to avoid overfitting in the model. So there are several ways by which we can reduce the occurrence of overfitting in our model. The first one is cross-validation. The second one is you can train with more data. And the last one is removing features. And there are some other techniques such as ensembling, regularization, and many more. So after understanding overfitting, it's time to understand what is underfitting. It occurs when our machine learning model is not able to capture the underlying trend of the data. To avoid the overfitting in the model, the fed of the training data can be stopped at an early stage, due to which the model may not learn enough from the training data. As a result, it may fail to find the best fit of the dominant trend in this data. In the case of underfitting, the model is not able to learn enough from the training data, and hence it reduces the accuracy and produces unreliable predictions. An underfitted model has high bias and low variance. For example, in this graph, you can see that the model is unable to capture the data points present in the plot. So this is the basic idea about underfitting. Now let's see how we can avoid underfitting. So we can increase the model's training time, and also we have to increase the number of features to avoid underfitting. So this is the basic idea about overfitting and underfitting. Now moving to the question number 22, what is RMSE in a linear regression model? RMSE stands for root mean square error. It is computed by taking the square root of MSE. The lower the RMSE, the better the model and its predictions. So this is the basic idea about root mean square error. Moving ahead, we are having the question number 23, what is naive Bayes? Naive Bayes classifiers are a collection of classification algorithms based on Bayes' theorem. It is not a single algorithm, but a family of algorithms where all of them share a common principle. That is, every pair of features being classified is independent of each other. The fundamental naive Bayes assumption is that each feature makes an independent and equal. So this is the basic idea about naive Bayes. Moving ahead, we are having the question number 24, that is, explain univariate, bivariate and multivariate analysis. So now, talking about the univariate analysis involves analyzing data with only one variable, or in other words, a single column or a vector of the data. This analysis allows us to understand the data and extract patterns and trends out of it. For example, analyzing the weight of a group of people. Now, let's move to the bivariate analysis. Bivariate analysis involves analyzing the data with exactly two variables, or in other words, the data can be put into a two-column table. This kind of analysis allows us to figure out the relationship between the variables. For example, analyzing the data that contains temperature and altitude. Now moving to the last one, that is multivariate analysis. Multivariate analysis involves analyzing the data with more than two variables. The number of columns of the data can be anything more than 2. This kind of analysis allows us to figure out the effects of all other variables on a single variable. For example, if you want to analyze data about house prices, which contains information about the houses such as locality, crime rate, area, the number of floors, etc. So this is the basic idea about univariate, bivariate and multivariate analysis. Now, moving to the next question, what are the different statistical techniques used in data analysis? The first one is the correlation. It establishes and measures relationship between different variables. For example, let's suppose if you are having a data set, so in that data sets you will be having features as well as the output variable. So basically the correlation will establish the relationship between the features and the output variables. Now talking about the regression, it allows identifying if the evolution of one variable affects the other. So we are having different types of regression such as linear regression, multiple regression, right? So in linear regression we can see that one variable can affect the other dependent variable. For example, you can consider experience versus salary. So as the experience will increase, your salary will also increase. So this is an example of linear regression. Now, the last one is time series. It predicts future values by analyzing sequence of past values. So basically, you can use the time series for the forecasting, right, based on the past data. So this is a basic idea about the different types of statistical techniques used by data analysts. Moving next, we are having type 1 and type 2 error. So the question is, what is type 1 and type 2 error? Talking about the type 1 error,
Let's have a quick quiz question, guys. And the question is, what does the term big data refer to? And your options are data sets that are too large to fit into computer memory, data that is difficult to analyze due to its complexity, or data that is collected from various sources and in large volumes, or statistical techniques used for analyzing complex data sets. Please mention your answers in the comment section below.
so type 1 error is also known as false positive. Basically, it occurs when a null hypothesis is rejected based on the statistical findings, even if it is true. For example, if a person is having a symptoms of COVID and he knows that he is COVID positive, but in the end the results come negative. So this is a type of false positive case, right? That is type 1 error. Now talking about the type 2 error, it is also known as false negative. It occurs when the null hypothesis is not rejected based on the statistical finding, even it is false. So this is the basic idea about type 1 and type 2 error. Now moving to the question number 27, what is the difference between where and having? So the first difference that I will tell you about where, that in where you are not allowed to work with the aggregate functions, whereas talking about the having, you can work with the aggregate functions. Now where is a clause which is used to filter records prior to grouping, whereas having clause is used to filter values within a group. Also, where is implemented in row operations, whereas having is implemented in column operations. So now talking about the last point of where clause, this clause can be used with the select, update and delete statements, whereas having clause can only be used with the select statement. So this is the difference between where and having. So now let's move to the next question. Next question is, what are the different types of methods to create a data frame? Now you can create a data frame with the dictionary, with the list. Also you can create a data frame by uploading the CSV file or Excel file. So now let's see the first way, that is dictionary. So here I will create a dictionary with the variable name as dict1, right? So as you know that dictionary will have key as well as value pair, right? So this is the key. So the key is here as student and the value is here Gaurav, Nilesh, Rishabh, Vaseem and Priyansi. So the another key that we are having as marks. So this is a key and the values are here, right? Now if you want to create a data frame, then I have to upload the library, right? So I will just simply write here import pandas as PD. Okay, so here I am writing here as PD. So PD is an alias. So I'll just simply write here PD dot data frame function. Make sure that D and F are capital. And inside that I will put the dictionary, right? So this is the dictionary variable name dict1, right? So when I'm just writing this, you can see that the output will be displayed with the student and marks as the column, right? And here the value of the key will be displayed. That is nothing but Gaurav, Nilesh, Rishabh, Vaseem and Priyansi. And so as the marks. Okay, so this is the way to create a data frame via dictionary. Now if you want to create with the list, so what I will do here simply, I'll just create a list with list1 and here I will simply write Gaurav and 82, right? And then I will just simply write the another name with the marks. So you can see that when I'm writing here PD dot data frame list1, So there will be no column. Since I'm just writing here the records. So now if you want to print the column, so I'll just simply write pd.dataframe, and inside that I will pass the list, and I will just pass another parameter with the name columns, and inside that I will just write student and marks. So what will happen when you are executing it, you will see that student and marks are the columns, right? And these are the records. So this is a way to create via list. Now, another way, as I already told you, that you can upload a CSV or Excel files to create a data frame. So for that, let's suppose if you are having a CSV file, so you have to write pd.read_CSV, and inside that the file name. And for the Excel file, you have to write pd.read_Excel. So in this way, you can create a data frame even through the CSV or Excel files. So these are the ways to create a data frame. So this is the basic idea about how to create a data frame. Now moving to the next question, that is question number 29, extract, store and type columns from the data frame. So here you can see that this was our data frame, right? And from this data frame, I want to only extract, store and type, right? So our data frame variable name was df. So I'll just simply write here df, and inside that I'll just create a list, and I will just write the column name, that is store and type. So you can see that this is a way to extract, store and type columns from the data frame. So now coming to the question number 30, is telling that fetch the records where size is greater than 50,000 and type is B. So you can see that it's basically a condition based statement, right? You have to write here condition. So first I have to write here the data frame, and our data frame is having the variable name as df. So inside that df, I will just write the column name as df size and greater than 50,000, and here I will use the AND operator. And what is the type here? Type here is B, right? So simply I will write here df type is equal to B. And when you are writing this code, you can see that here we will get the type that is of B type and size is greater than 50,000. So this is a way to fetch the records where size is greater than 50,000 and type is B. Now moving to the question number 31, is telling that add a new column with an address. So in our data frame, let's suppose if you want to add any new column. So the data frame variable name is df. So I'll just simply write here df, and inside that I will just write here address. So our new column has been generated. Now I have to put the value there. So I'll just simply write random values. Let's suppose Bangalore, Chennai, Gurugram, Mumbai and Delhi. So when you are writing df.head, then it will display the new column also along with the records inserted in it. So this is a way to create a new column. Now, moving to the question number 32, what are the different types of sampling techniques? So there are different types of sampling. So now let's see the first one, that is simple random sampling. In a simple random sample, every member of the population has an equal chance of being selected. Your sampling frame should include the whole population here. To conduct this type of sampling, you can use tools like random number generators or other techniques that are based entirely on your choice, right? So this is the basic idea about simple random sampling. Now, let's see what is systematic sampling. Systematic sampling is similar to simple random sampling, but it is usually slightly easier to conduct. Here, every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals, right? Moving ahead, we are having the cluster sampling. Cluster sampling also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. So this is the idea about cluster sampling. The next one is the stratified sampling. It involves dividing the population into subpopulations that may differ in important ways. It allows you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. Alright guys, after that we are having the purposive sampling. Purposive sampling refers to a group of non-probability sampling techniques in which units are selected because they have characteristics that you need in your sample. So these are the different types of sampling techniques. Now coming to the question number 33, what are the different types of charts that Tableau provides? So there are several charts that Tableau used to provide, starting from bar chart, line chart, pie chart, maps, Gantt chart, scatter plot, tree map, box plot, density maps and many more. Okay, let's move ahead. Now coming to the question number 34, explain hypothesis testing. Now let me give you an idea about the hypothesis testing. Talking about the hypothesis testing, it is the process of testing assumptions for a population parameter on a sample of data. The process involves different hypotheses and statistical proof to accept or reject the hypothesis. Here, the null hypothesis is represented by H0, whereas alternate hypothesis is denoted by H1. Now, let's see the steps involved in hypothesis testing. The first one is stating the hypothesis. Moving ahead, we are having the collect data. Then we will see the evidence to fail or accept the hypothesis. Then we will test the hypothesis, and according to that, we'll make the decisions. For example, let's suppose there is a student with height more than 5 feet have BMI more than 20. So this will considered as a null hypothesis. Now, what will be the alternate hypothesis? The students with height more than 5 feet do not have BMI more than 20. So this is our alternate hypothesis. Now, what we'll do, we'll apply here statistical test to support the hypothesis, whether we have to accept null hypothesis or reject null hypothesis, right? And at last, we'll make our decisions. So this is how hypothesis testing works. Moving to the next question, what do you mean by the term data wrangling? Data wrangling, also called data cleaning, data remediation, or data munging, it refers to a variety of processes designed to transform raw data into more readily used formats. The exact methods differ from project to project depending on the data you are leveraging and the goal you are trying to achieve. Now let's see some examples of data wrangling. It is used to merge multiple data sources into a single dataset for analysis. It also identifies gaps in data and either filling or deleting them. It deletes data that's either unnecessary or irrelevant to the project you are working on. Data wrangling can be manual or automated process. In scenarios where datasets are exceptionally large, automated data cleaning becomes a necessity. That being said, this is the basic idea about the data wrangling. Now, moving to the question number 36, what is the difference between count, count blank, and countf in Excel? The count function in Excel is used to count cells that contains numbers. Talking about the count blank, it is used to count cells that are blank. Now what about the countf? Countf is used to count the cells that meets a specified criteria. Now moving ahead to the next question, we are having what is the difference between correlation and covariance? Talking about the covariance, it indicates the direction of the linear relationship between variables, whereas correlation is a statistical measure that indicates how strongly two variables are related. For example, in a dataset, we are having the feature and the dependent variable. So what will correlation do here? It will see how much a variable. So here, the correlation will tell the collinearity between the two variables. Now, next point is covariance range from minus infinity to infinity, whereas correlation ranges from -1 to 1, right? Now talking about the covariance, it is affected by scale of a variable, whereas correlation is not affected by a scale. So this is the difference between correlation and covariance. So now let's see when do we use normalization and standardization. So first I will discuss about the normalization. Normalization is used when features are of different scales. Also, it scales values between 0 to 1 or -1 to 1, depends. Along with that, the important point is note here, it is really affected by outliers. Now, if you want to implement normalization, then there is a library known as scikit-learn. So using scikit-learn, you can apply a transformer called min-max scalar. Now, it is useful when we don't know about the distribution. So now, after understanding what is normalization, let's see standardization. So the most important point of standardization is that it is useful when the feature distribution is normal or Gaussian. Talking about the standardization, it is used when we want to ensure zero mean and unit standard deviation. Also, it is not bounded to a certain range like normalization. In normalization, the range was from 0 to 1 or -1 to 1. But here, it is not bounded to a certain range. Along with that, it is much less affected by outliers. So here also there is a scikit-learn library that provides a transformer called standard scalar. So if you want to standardize your data, you can apply this library. So this is the basic idea about normalization and standardization. Now let's move to the question number 39. So what is the use of p-value? We use the p-value to understand whether the given data really describe the observed effect or not. Basically, p-value is the measure of statistical importance of an observation. It is the probability that shows the significance of output to the data. If the p-value is less than 0.05, we will reject the null hypothesis. or we will accept the null hypothesis if it's greater than 0.05. So this is the basic idea about p-value. Moving to the last question for this top 40 data analyst interview question. What is a skewed distribution? A skewed distribution takes place when one tail is longer than the other. So there are basically two different types of skewed distribution. The first one is left skewed distribution and the other one is the right skewed distribution. Talking about the left skewed distribution, it occurs when the long tail is on the left side of the distribution, whereas in right skewed distribution, it occurs when the long tail is on the right side of the distribution. Now, let's see the figure to understand in a simpler way. So here you can see that in this graph, the tail is on the left side, right? So what is it? This is a left skewed distribution. And here, the tail is on the right side. So this is a right skewed distribution. Okay, in left skewed distribution, mode is greater than median and median is greater than mean. You can clearly see that mode is greater than median and median is greater than mean. Now talking about the right skewed, here the mean is greater than the median and the median is greater than the mode. Also talking about the left skewed distribution, it is known as negatively skewed distribution, whereas right skewed distribution is known as positively skewed distribution. So this is the basic idea about the skewed distribution.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.